¿Aló? Ok. Hola, bienvenidos a todos. Mi nombre es Moritz Stellmacher y hoy vamos a hacer un taller de remix y es para principiantes de Web3 y van a aprender un poco de Solidity con remix. Y sí, eso vamos a hacer hoy, pero antes que empezamos, tenemos algunos links que creo que es un poco más fácil que ustedes lo tienen si van por ese link acá. Ah, no se ve, ¿eh? La presentación. Ok, perfecto. Bueno, ahí está como un QR code y también los links que lo pueden usar y así va a ser más fácil durante la presentación que ustedes lo pueden ver y lo pueden, solamente tienen que clicar en él y no tienen que hacer el QR code otra vez. Así que sí, sería bueno si ustedes hacen eso ahora y después vamos a hacer un minting de NFTs y para eso necesitamos la dirección de ustedes y tienen que instalar el MetaMask y después cambiar al Network Optimism y después pueden compartir su dirección acá. Así que lo podemos whitelist a ustedes, así que ustedes pueden mintar el NFT y también lo pueden dar un poco de ETH para lo pueden hacer en Optimism. Así que si durante estoy explicando y hacer la presentación, ustedes ya pueden ir acá y cuando tienen el MetaMask, tienen su dirección, solamente lo pueden poner acá. Y bueno, y eso está bien si ya lo hacen ahora, así que más tarde no tenemos que esperar para todo eso. Así que espero todos están bien ahí con el link y entendan todo. ¿Sí? Ok, bueno, esperamos un poquito. Ok, perfecto, bueno. Ah, ¿no funcionó?
Puedes hablar con este un momento mientras que...
Ok. Hello. Ok, bueno. Sí, ¿qué vamos a hacer hoy? Al principio vamos a hacer una introducción teórica y eso podemos hacer un poco más corto si ustedes ya saben todo, así que no hace sentido que eso haga más largo, pero si quieren preguntar preguntas o quieren saber un poco más, sí, empiezo con esa introducción para que saben qué hacemos. Y va a ser un poco alto nivel, así que muchas cosas pueden ser que ustedes ya saben. Pero vamos a ver cómo va y si veo que ustedes tienen interés, lo hago un poco más largo y si no, hacemos un poco más rápido. Y después, y eso es que vamos a hacer lo más tiempo que tenemos, vamos a ver la introducción de Solidity, que creo que para todos ustedes eso va a ser lo más importante, como aprender el lenguaje de Solidity para hacer smart contracts, contratos inteligentes en Ethereum. Así que eso va a ser lo más importante y después vamos a acuñar a Mint un NFT. Ok. En Optimism. Y eso va a ser lo que vamos a hacer lo más tarde y para eso ustedes ahora tienen que entrar a su dirección y tienen que recibir un poco de ETH en Optimism, así que lo pueden acuñar. Bueno, sí, eso va a ser la agenda para hoy y empezamos con la introducción. Puede ser que es menos de 30 minutos, vamos a ver. Bueno, creo que ustedes todos saben por alto nivel por qué estamos acá, pero para mí y porque yo estoy acá y porque creo que eso es una cosa tan importante, me gusta ponerlo como solamente en algunas pocas palabras, como para condensar ¿qué es la cosa que es tan importante? Y la cosa que es tan importante para mí es que la tecnología blockchain nos permite almacenar datos en una forma inmutable. Así que puede ser que tenemos datos en una forma que nadie lo puede cambiar, nadie lo puede sacar, nadie puede hacer nada con eso. Y eso es creo que lo importante que mucha gente no totalmente entiende qué significa, porque eso significa, creo que eso va a ser una cosa muy, muy grande que va a cambiar todo. Casi como 30 años atrás, si dijiste a gente que el Internet es un sitio a donde gente se puede comunicar, también nadie sabía qué se hace con eso. Así que eso es, creo, una cosa que tenemos datos que nada lo puede cambiar. Eso es lo muy, muy importante. Y ahí van a venir un montón de cosas que se pueden hacer que nadie se puede manejar al momento. Bueno, sí, y las soluciones que tenemos ahora son todas muy centralizadas, lo sabemos, como Facebook, Google, Amazon con AWS. Todo esto es siempre no se podía antes tener datos en una forma que nadie lo podía cambiar. Siempre había una gente que en algún tiempo lo podía cambiar si querían. Y eso es la revolución, eso es la cosa nueva, si lo ponemos en muy, muy alto nivel. Bueno, la blockchain, como todos ustedes creo que saben, consiste de bloques de datos y de transacciones que no se pueden modificar y también son administradas por una red peer-to-peer, ¿no? Que como cada uno tiene como una copia, un piso de la copia y así que es muy, muy difícil para cambiar algo ahí, no se puede. Bueno, si queremos saber un poco más la historia de eso, cómo cambió, es que la tecnología blockchain se inventó como un libro mayor, un ledger, para registrar las transacciones de Bitcoin. La idea era Bitcoin es una moneda, hacer una moneda digital que nadie puede controlar. Y para tener eso, se tenía que tener una forma a donde se pueda almacenar datos sin cambiar, que nadie podía cambiarlo. Y por eso la blockchain estaba inventada. Sí, y la blockchain de Bitcoin almacena transacciones de valor, no transacciones de Bitcoin. Eso es que consiste la blockchain de Bitcoin. Y sí, solamente existe por eso, para hacer transacciones, no de Bitcoins. Y eso es que lo almacena. Y la blockchain Ethereum ahora es como la revolución, es que no solamente se usa para transacciones, no transacciones de una moneda, pero se usa para programas, ¿no? Para programas inteligentes. Y ahí se almacenan los datos y también los programas. Y eso es la cosa que ahora es la cosa importante, la cosa que cambió. Y con eso, Ethereum se permite la creación de un montón de aplicaciones que se podría hacer. Ahí ahora es como Vitalik lo llama la multipurpose blockchain. Ahora no es solamente para monedas, sí que también había monedas, como en 2017, como había todo el ICO y toda la gente hacía sus propias monedas, ¿no? Y eso podría hacer, la gente lo puede hacer, la gente hacía, pero también pueden hacer un montón de otras cosas, como DeFi, como redes sociales y como tokens, que en ese año, los NFTs, que ese año o el año pasado empezó, que estaba muy, muy grande, ¿no? Y todas esas aplicaciones es que se puede hacer con Ethereum y que es mucho más difícil hacer, por ejemplo, con Bitcoin. Bueno, y esas aplicaciones se llaman DApp, como de aplicación descentralizada. Okay. There's, I don't know, si no pueden conectar por el Wi-Fi, creo que ahí hay la clave del Wi-Fi. Así que si tienen problema, creo que eso funciona bien. Ok, bueno, sí, pero eso es la DApp, es la aplicación descentralizada que se construyen sobre la blockchain. Y como mínimo, tiene como un contrato inteligente, el smart contract, y eso es que vamos a ver hoy, cómo podemos escribir nuestro mismo smart contract, cómo empezar con eso, y después hay como un interface de usuario, un user interface, que la gente puede interactuar con ese smart contract. Y acá hay como una estructura o como saber si ustedes son del Web 2, del mundo viejo, de ahí cómo es un poco es cómo lo pueden un poco más fácil para entender cómo funciona. Así que sí, el frontend, o lo empezamos acá, como normalmente tienes como una database, donde tienes todos tus datos, y normalmente tieneslo en AWS, Google Cloud, o somewhere, lo tienes en tu mismo database. Pero en la estructura de DApp lo tienes en la blockchain, o por lo menos los datos que son muy sensibles y muy importantes. Porque es muy costoso, por eso hay que pensar como qué datos pones a dónde, ¿no? Y por eso los datos más importantes se ponen en la blockchain. Y después en la app normal tienes el server-side code, tienes tu backend, a donde puedes ejecutar los programas en el server. Y ahora la diferencia es, acá tenemos los smart contracts, los contratos inteligentes, que ahora esos son el backend, ¿no? Solamente también para funciones que son importantes, pero eso es como programas que no se pueden cambiar y que son ejecutados en la blockchain. Y después también tienes el frontend, el user interface, que normalmente es casi lo mismo, pero hay algunas bibliotecas como Ether.js que vamos a usar hoy también un poco, con que te puedes conectar con la blockchain y como si tenías una API y lo puedes comunicar con los datos que tienes en el smart contract, en las funciones que tienes en el smart contract. Bueno, sí, eso es la estructura y nosotros vamos a mirar un poco en los contratos inteligentes, acá los smart contracts hoy. Bueno, y ahora por el fin de esa presentación vamos a ver qué son los atributos de los dApps, por qué qué son como casos a donde sería bien crear un dApp, o en qué casos sería mejor crear un app tradicional. Bueno, que se tienen que saber que normalmente son transparentes, así que la gente puede ver, también los datos pueden ser encodidos y no se pueden ver todos los datos en claro, pero la gente puede ver cómo los contratos funcionan y qué transacciones gente hacía, así que son muy, muy transparentes, que es diferente que que normalmente cuando gente solamente tiene su app y su server y nadie sabe qué pasa con los datos, nadie sabe cómo la gente interactúa con eso y nadie sabe si no daban los datos a otras personas. Así que por todas esas cosas, eso podría ser un caso donde sería bueno hacer un dApp porque es transparente. Y también, que también está interesante, es que mucha gente como saca código de otra gente y interactúa con contratos de otra gente, que eso se hace muy interoperable, ¿no? Así que mucha gente puede interactuar y eso es porque son transparentes y otra gente lo puede usar. No es que cada uno lo tiene en su propio server y nadie lo puede usar. Bueno, esos son transparentes y después, y eso es capaz lo más importante, inmutable, no se puede cambiar. Bueno, sí se puede cambiar si lo escribes, que es upgradable, así que sí, ahí se puede cambiar, pero si no tenía la intención de cambiarlo, tampoco no se puede cambiar. Y eso es lo que es interesante, que ahora la gente tiene la seguridad que eso no se va a cambiar. Y es como se estaba escrito. O sea, si no es como una blockchain a donde alguien lo comprometa, hay hacks. Si no hay eso, va a ser inmutable y la gente no lo puede cambiar. Y eso es la otra cosa que es interesante, capaz también en países como acá, si muchas veces la gente no sabe si cosas van a cambiar o alguien lo va a pagar o algo así, ahí sí que puede ser interesante. Si tienes algo que es inmutable y nadie puede cambiar, usarlo para esos casos. Y sí, hay que pensar en esos casos a donde sí que hace sentido, porque en otros casos no hace sentido, porque también es más o menos lento y caro, ¿no? Estamos todos trabajando en que ya no va a ser tan lento y tan caro, pero hasta ahora es mucho más lento y mucho más caro si tienes tu propio server o tienes AWS o algo así, ¿no? Así que hay que pensar cuándo usarlo y cuándo no. Bueno, sí, eso es más o menos la introducción teórica. Y ahora vamos a ir a la introducción a Solidity. O no sé si alguien tiene comentarios o preguntas por esa parte. Sí. No, sí, yo creo que eso sería lo mejor, que solamente partes que tienen los datos sensibles, esos son los datos que hay que manejar por el blockchain. Pero los otros datos que, no sé, solamente son como, no, que todo lo hace la experiencia mejor, por esos datos no hay que ponerlos. Solamente los datos que sí, que son muy sensibles, como, no sé, sí, que son muy sensibles, como del financio, o no sé. Sí, también otra cosa que se puede hacer es que solamente como se puede crear como un hash, se puede encodar, así que la gente sabe que no se cambió los datos, pero tampoco no tienen que poner todos los datos adentro. Así que solamente es como que se puede saber si algo cambió y no, pero no hay que poner todo. Así que sí, hay que ser un poco sensible con eso, pero también todos están trabajando a hacerlo un poco más rápido. Bueno, ¿otras preguntas o comentarios? Sí.
Tengo una duda con respecto al tema de arquitectura de software, un poco relacionada con eso. Porque veo que hay muchas soluciones de Web3 que ya se pueden implementar en Web2. Sencillamente, en términos de decisión de reglas de negocio, normalmente para las GAMs, ¿cuál es la solución más importante que no tiene Web2 como para hacer esa transición? O sea, ¿qué hace que vamos a decir, bueno, hagamos una Web3 porque vamos a solucionar este y este problema que no puede ser en Web2?
No sé si entendió la pregunta.
La pregunta es básica. ¿Qué hace fundamentalmente una DApp para que se sustituya el Web2 y se implementa la solución Web3? ¿Qué hace que sea fundamental? Normalmente, en general, que ves que sea un factor determinante para tomar la decisión de, ok, vámonos por Web3.
Sí, bueno, creo que eso tendría que ser como algo como eso, ¿no? Que sí que tendría que ser algo que a donde la gente piensa que es tan importante que los datos son seguros y nadie lo puede cambiar. Y tenía que ser una cosa tan importante que también la gente no, o que también está bien si tienes que pagar cada tiempo si ya tienes que hacer una transacción y quieres que interactuar con eso y va a ser muy lento. Y así que, bueno, no creo que es una pregunta que se puede, que yo sé, porque no sé si la gente va a usar o no, pero es como tiene esos trade-offs. Tiene que ser por la manera que es transparente y inmutable, pero por el otro es caro y lento. Y sí que hay que saber cuándo hacer la decisión o no. Y sí, hasta ahora más que hay son todos los finance applications, ¿no? que la gente le usa, porque ahí sí que hace mucho sentido que los datos son inmutables y también transparentes. Pero sí, como acá en la conferencia hay un montón de gente que habla sobre las redes sociales, crear eso en una nueva forma, porque ahí también nadie quiere que gente como tiene el control sobre eso, ¿no? Y eso podría ser otra. Hay un montón de ideas que se pueden hacer, pero sí, es un poco nadie lo sabe que va a funcionar o no. Bueno, ahora vamos a ir a la introducción a Solidity y por eso, y bueno, yo acá también estoy con el team de Remix, que acá también hay muy buenas camisetas, que no sé dónde son, ahí puede ser, ¿sí? Y bueno, nosotros vamos a usar Remix también, que es como la forma, creo, casi toda la gente que conozco que entró en ese space usaba Remix al principio, porque es una IDE, así que pues, ves todo lo que haces, si lo puedes llamar, las funciones de adentro solamente con un button, y todo es muy, muy fácil. Y nosotros vamos a usar Remix ahora para aprender Solidity. Y también hay como un módulo que se llama Learneth, y con eso hemos hecho algunos tutoriales y hoy vamos a ver a esos tutoriales. Y por eso, bueno, pueden ir acá, o si no, si ya fueron a ese HackMD, ahí hay que apretar ese link y eso espero que abre la página. Así que, si ustedes ya tienen el HackMD, solamente van acá. Y si no, también lo pueden sacar de acá por ese link. Así que voy a esperar un poco y a ver si funciona para todos. Y también si tienen problemas me pueden llamar y puedo venir si no funciona. ¿Todo bien? ¿Alguien tiene un problema? ¿No? ¿Sí? Sí. Bueno, ahí el Wi-Fi, no sé si puede ser que es un poco más rápido. Ok. Bueno, voy a esperar un poco más. Y lo voy a tratar también, así que yo voy a apretar acá por ese link también. Y de ahí, sí, tenían que ver eso, que se llama Solidity para principiantes. Y acá son los capítulos. Bueno, sí, eso es la Remix IDE. Y lo vamos a usar un poco más tarde, pero para ahora, sí, vamos a usar el plugin que se llama Learners, que ya dijo, que, a ver, ¿dónde es el home? Sí, acá es como, hay diferentes plugins y eso es el Learners y eso vamos a usar con ese deep link. Ustedes espero que ya van directamente a ese Learners Solidity para principiantes tutoriales. Así que funciona con todos. ¿Sí? Bueno. Entonces, capaz que me voy a sentar ahora. Vamos a ver al principio la sintaxis básica. Eso es que vamos a empezar. Y acá siempre hay como algunas menciones al fin del capítulo. Y eso es que ustedes, espero lo pueden, no son tan difíciles para aprender. Para ustedes vamos a, sí. Ah, ok. Si alguien tiene el problema, creo que el mismo problema como él tiene, es que solamente van a Remix, que se ve así, ¿no? Y de ahí se puede ir a acá el Learneth, y acá se puede importar, y acá se importa ese. Ok, no sé por qué. ¿A eso también estaba pasando? Ok. ¿Y el link directo no funcionó tampoco? Ah, es porque tarda tanto. A ver. Ok, ¿hay otras personas que tienen ese problema? ¿Sí? Ok, algunas. Ok, no sé por qué eso no funciona ahora. Ah, ¿es la red? Ok, bueno. Ok, ok. Así que, no sé, ¿cómo es el Wi-Fi? ¿Qué Wi-Fi están usando ustedes? Ok. ¿Y el otro tampoco funciona? ¿El Devcon? El repósito. Ok. Que el repósito también am, para ellos. Ah, no, para mí está bien, creo. El problema para ellos. Acá es el repósito es ese, que también está acá. Si no funciona, pero esperaba que funcionó así con el link directo. Ok. ¿Funcionó con el otro Wi-Fi? ¿O alguna gente todavía tiene problema? ¿Sí? Ah, tarda un poco, capaz. Ah, él está bien. ¿Y ahí está todo bien? Ok. Así que espero que todos están bien. Ok, bueno. Y si no, sí, también lo pueden ver. Pueden ver a mi página acá y después, capaz, pueden ir acá o con otra gente y ver sus misiones juntos. Ok, pues vamos a empezar. Espero que lo puedan ver bien. Ok, bueno, ahora vamos a ver al principio cómo eso es el Hello World Contract, ¿no? El contrato, el programa inicial, que es muy, muy simple, solamente para ustedes lo aprenden y empiezan a aprenderlo. Ok, no sé, ¿toda la gente todavía tiene algunos problemas? Ok, bueno. ¿Continúo o espero un poco? ¿Ah? Ok, capaz que puedo ver ahí también. ¿Mm? Am, sí, eso no funciona. Si vas ahí. Ah, ya. Sí, creo que es solamente, todo es un poco lento con el Wi-Fi. Sí, ese es él. Ah, sí, pero es el otro repo. No, había ¿viste en el HackMD que puso? Acá, mira, le voy a poner. Es ese repo, si tienen problema, acá. Ok, ¿hay más gente con problemas?
Quiero saber de dónde sacó ese recurso de leer en vivo.
Ah, ok. Ya, sí. Lo HackMD acá es acá, bit.ly remix Devcon links o el code QR para el HackMD. Sí, acá son todos los links y si, acá también pueden poner su dirección para lo podemos mandar a algún is para después, para hacer el NFT, para NFT minting. ¿Cómo?
Yo sé que es luego, pero aquí no se puede. Lo puedes escribir.
Ah, sí, lo puedes editar acá.
Ah, tengo que darle aquí.
Sí. Sí, capaz una última vez, porque alguna gente viene un poco tarde. Si van al HackMD, acá pueden apretar y lo pueden cambiar y lo pueden poner su dirección.
The link to the HackMD, the bit.ly
Yeah, I put it here again. Okay, so acá está el link por el HackMD, ¿no? Otra vez, la última vez. Y si no, capaz que otra gente acá lo puede preguntar y le pueden dar el link. Y si tienen ese, van acá, se va a ver así. Y pueden poner su dirección acá. Solamente con editar el HackMD acá. Y acá lo pueden poner. Y de ahí están bien para ahora. Y eso lo vamos a usar más tarde. Ok. Y si tienen problemas acá, también pueden preguntar a alguna otra gente que ya lo hizo. Pero espero que eso todo funcionó para todos. Ok. Y ahora el tema de learners. También van a encontrar en ese HackMD, tenía que funcionar solamente ese link. Si no funciona, la alternativa es que solamente va a Remix, andan a remix.ethereum.org y de ahí se pueden activar el plugin, acá, el learners, y de ahí pueden importar ese repo. Y bueno, depende al Wi-Fi, tenía que funcionar y ahí se llama Solidity para principiantes. Y eso es que miramos ahora. Ok, si tienen problemas, capaz que otra gente acá lo puede ayudar, o también puedo hacer como una pausa cuando terminamos eso. Así que ahí, después de, cuando finalizamos ese contrato, después de eso va a ser una misión pequeña y ustedes pueden trabajar en eso y gente que tiene problemas me puede avisar. Ok, bueno, empezamos con ese como el Hello World Contract, así que es el contrato muy simple para ustedes para que ya entiendan la sintax básica, ¿no? Al principio acá vemos la licencia, ¿no? ¿Qué licencia ese contrato tiene? Y eso no es tan importante por ahora, pero acá también tienen como licencias que pueden ver, cuál está buena para ustedes, pero si empiezan ahora eso no va a ser muy importante. MIT, licencia MIT es uno que mucha gente lo usa. Bueno, pero si no la tienen tampoco es tan malo, pero van a tener como un warning acá. No es un error, pero dice que hey, sería bueno tener como una licencia acá. Bueno, esa es la línea primera acá. Y después tenemos la palabra clave pragma y solidity. Y ahí ahora tenemos que decidir qué versión de solidity vamos a usar a escribir el contrato. Y ahora acá tenemos el techito, no sé, en inglés el caret operator, que nos dice que nosotros vamos a usar una versión 8.3 o 0.8.3 o más alto, pero no más de 9. Y por eso tenemos el techito acá. Porque con los cambios grandes, como 9, que estaba 7 u 6, ahí sí se cambian como cosas que se pueden romper y que se puede romper el contrato y que ya no va a funcionar si usas con una versión más vieja. Pero como si hay como cambios pequeños, si tienes el 4 y 5, ahí nada se va a romper. Así que sí, ahí vamos a decir ahora, pero para el compiler y si otra gente quiere usar el programa, y Solidity se cambia muy rápido, así que para saber qué es la versión con que estaba escribida, tenemos que decidir cuál versión estamos usando ahora. Bueno, después tenemos acá la palabra clave contract, ¿no? Es como el contrato inteligente, el smart contract, como el nombre del programa que vamos a escribir. Y si con eso lo inicializamos y después lo damos un nombre. Y normalmente no hay que capitalizarlo, pero es como una buena práctica. Y nosotros lo llamamos Hello World porque es el principio del programa y el programa principiante para ustedes. Y sí, ese es el nombre y ya está. Y después acá tenemos el programa, el Smart Contract, que es muy simple. Y ahí vemos, acá tenemos una variable, y la variable, pero vamos a ver un poco más tarde qué significa, es una state variable, una variable del estado. Y eso significa que esa variable, o el valor de esa variable, vamos a poner en la blockchain. Eso va a ser algo que va a estar en la blockchain. Y tenemos esa variable y después asignamos un valor a esa variable y el valor es hello world, que es un string, ¿no? que se ven acá. Muy, muy fácil. Y también tenemos que decir como qué tipo es esa variable, y porque sabemos que es un string, ponemos acá el tipo, que es string, y después hay una cosa nueva acá, que es la visibilidad, y en este caso es público, que significa que lo podemos accesar de afuera del contrato. Pero después hay también más por la visibilidad y qué significa. Pero para ahora solamente hay que saber, ok, eso es como la cosa más sencilla, más fácil que se pueden crear. Bueno, eso es el contrato y también lo podemos interactuar con ese. Ok, bueno, acá es capaz que antes que vamos a ver la misión que ustedes tienen, solamente para ustedes también lo pueden como usar un poco, es que es la cosa buena de Remix, es que lo voy a enseñar un poquito, así que acá hay el File Explorer y ahora estamos todos en el tutorial, así que ahora eso no es tan importante, pero después vamos a ver cómo con ese lo pueden crear nuevos programas, nuevos files, Solidity, y también lo pueden abrir y todas esas cosas pueden hacer acá en el File Explorer. Después acá es el compiler, a donde lo podemos compilar, pero también se puede hacer con control IS, si quieren compilar el contrato. Como el Solidity es el una lenguaje high level, y después que está en la blockchain es el bytecode acá, que hace el compiler, y con eso también sabemos si tenemos algunos problemas, pero no es tan importante por ahora. Y después acá tenemos el tab por deploy y run transacciones, y eso vamos a usar más tarde, pero ahora tengo como una virtual machine, como una versión de blockchain que está en mi browser, que yo puedo usar. Y eso lo hizo acá, y ahora yo voy a deploy, a poner el contrato en la blockchain de mi browser, con solamente apretar ese botón deploy. Y acá está el contrato en mi blockchain, y acá ahora pueden ver que nosotros no tenemos una función para retornar el valor de grid, pero tenemos un botón acá, no demás. Y eso es porque si tenemos visibilidad público con state variables, también automáticamente tenemos esa función. Pero eso no es tan importante para ahora, pero solamente para que ustedes pueden ver que podemos interactuar con ese contrato muy, muy simple. Bueno, eso para ahora no es tan importante para ahora, pero para ustedes para saber, y después vamos a venir otra vez por eso. Así que para ahora está todo bien, solamente a continuar con el tutorial. Ok, es un poco pequeño acá. Así que mejor empiezo de nuevo. Acá estamos. Bueno, ahora que ustedes espero que entendieron todo eso, acá hay una misión, que es ustedes que borren el contrato eso y creen su mismo nuevo contrato, que se llama ahora, ya no se llama Hello World, pero se llama My Contract, y también la variable ya no se llama greet, pero se llama name, y eso es importante, no es nombre, pero es name, y también todavía es del tipo string, y vamos a asignarlo un valor que es ls, de nuevo. Y bueno, eso es, la misión para ahora, para que ustedes lo aprenden. Y es muy, muy fácil, lo sé, pero está bueno para todos ustedes, capaz lo prueben y ven cómo va. Bueno, lo voy a dar como 5 minutos o 10 minutos.
Una pregunta,
Sí.
¿cuál es la versión estable de Ethereum 10 aparte de la 8? Yo creo que la 5 era muy famosa, pero no estoy seguro de cuáles son las más usadas como para desarrollar contratos.
Sí, sí, se pueden ir a la Solidity Documentation y ahí siempre está bueno ir a Latest para saber qué versión está lo mejor. Y ahí Solidity recently released the 0.8 versión. Eso es la que ahora está la estable. Pero eso es, es importante si lo ven en Google, que no solamente van a alguna versión, porque siempre va a ser una versión vieja, así que está importante que van a la latest acá. Ok, bueno, así que sí, lo voy a dar como 5 o 10 minutos. Vamos a empezar con 5. Y sí, si tienen problemas o algo, ok, puede. Y también creo que ahí, ese tablet ahí, el remix, también lo puede ayudar si tienen problemas.
Creo que no me está funcionando porque no he podido activar este. Estaba haciendo manual.
Ok, y ahora,
Mira, me parece.
espera que apago esto. Ok. Creo que el timer ya se apagó. ¿Me pueden poner en el...? Ok. Sí, bueno. ¿Funcionó para todos? ¿Lo pueden? Sí, y bueno, se tenía que ver... Bueno, muy fácil. Se llama... Solamente para la primera vez, para ver cómo se usa eso. Muy fácil, ¿no? Ahí estamos. Y well done, no errors. Así que estamos bien. Sí, así tenía que funcionar, si no, debía tener un problema. Bueno, espero están todos bien, así que vamos a la próxima, al próximo capítulo. Tipos de data primitivos. Así que ahora sabemos cómo crear un contrato muy fácil. Y ahora vamos a ver a datos primitivos, ahora muy primitivos, solamente hay bool, uint, int y la dirección address. La address capaz que ustedes no lo conocen todavía, los otros capaz que sí que la conocen. Sí, acá también una cosa que dijo a otra gente acá es que usamos acá los contratos que usamos en esa clase, en esos tutoriales, son de Solidity by Example, que es un muy buen proyecto también con la comunidad, a donde hay un montón de best practices de contratos. Acá pueden ver como un montón de contratos que DeFi, todos esos contratos, y nosotros que hacemos ahora es nosotros vamos por estos contratos, pero con un poco más de explicación. Pero acá si quieren saber más, también acá hay un montón de diferentes contratos y acá nosotros, por ejemplo, ahora estamos a primitive data types, ¿no? Datos primitivos. Pero sí, eso también, el link también está adentro del tutorial. Pero solamente para ustedes, para saber por qué usamos esos contratos, es algo que la comunidad está creando y los contratos que estaban con todo el tiempo, que gente ayudaba mucho. Así que ahora vamos a ver los datos primitivos. Lo primero acá es boolean, que puede ser verdadero o falso y que en nuestro caso acá lo llamamos bool. También es público, se puede accesar de afuera y el tipo es bool, que está acá, y acá lo ponemos true, que es verdadero, también puede ser false. Bueno, eso ya para el bool no hay mucho para decir ahí. Y después tenemos algo acá que se llama uint, que es el unsigned integer. Y eso se puede, capaz para aprenderlo, que es un poco más fácil para saber qué significa, es que el sign, el signo, es como algo como así, como el negativo acá, ¿no? El minus que tenemos así, ese es un signo, pero nosotros el unsigned es que no tiene, así que solamente puede ser como positivo o cero, porque esos no tienen un signo adelante de eso. Así que por eso se llama unsigned integer y eso sí significa que no son negativos integers. Sí, y eso tenemos el uint y después con ese unsigned integer, el uint, podemos seleccionar acá como declarar como que grande es que tenemos en esa variable. Así que acá lo podemos especificar, tenemos 8 bits y así que lo podemos llamar uint 8. Así, y ahí ponemos como número que podemos poner adentro. Acá también son como los ranges con que lo pueden poner ahí adentro, qué números. Y si no tenemos nada, es como un uint, es lo mismo como 256. Así que eso es lo mismo si poníamos eso acá. Bueno, y eso es el uint, son números positivos y después si podemos especificar, si sabemos como qué grande van a ser, podemos especificar como qué grande que son, cuántos bits. Y lo mismo, casi lo mismo tenemos acá con integers, la diferencia es que también pueden ser negativos. Y al último tenemos la dirección, la address, que se usa mucho en Ethereum, que es la dirección que ustedes tienen como como un account, external account, como un account que ustedes tienen con una adresa acá que lo pueden manejar, que pueden hacer cosas en el universo Ethereum con eso. Pero también los contratos tienen una dirección, así que si ustedes quieren interactuar con un contrato, también usan esa address. Y sí, la dirección, la address, acá tiene 20 bytes. Y sí, eso es el tamaño de la address. Y después hay también otras versiones, como una versión especial, la address payable, donde pueden mandar, recibir Ether, pero eso para ahora no es tan importante. Acá, lo último, también capaz ese capítulo tampoco es tan importante, pero solamente que ustedes conocen algunos datos primitivos y van a usar muchos esos datos. Y acá el valor que van a tener si no está definido, así que acá el boolean va a ser false, uint va a ser 0, int va a ser 0 y la dirección va a ser esa dirección. Bueno, sí, eso muy fácil. Ahora vamos a ver, acá es la misión otra vez. Sí, crear una nueva variable new address que es pública, que es una address y ahora eso es un poco complicado, así que ahí tienen que pensar un poco porque no tenemos la solución fácil acá, pero sí que van a poder hacerlo. No tampoco es tan difícil y si tienen que poner como un valor acá que funciona, no pueden poner cualquier valor, pero tiene que ser un valor que podría ser una dirección de Ethereum. Así que esa es la misión, la primera, crear esa variable. Y después una variable otra vez negativa y que es pública. Y ahí tienen que saber cuál es el tipo, pero creo que después que vimos eso también van a saber cuál debe ser. Y después la última nueva variable va a ser newInt, y eso también es un poco difícil, puede ser. Ahí también tienen que pensar cuál es el tamaño más pequeño y también el valor más pequeño. Sí, eso es la misión tercera. Y la primera y la tercera capaz que un poco difícil. Bueno, pero vamos a poner otra vez 5 minutos. Lo capaz un poco más, 7 minutos. Moritz. Acá. Moritz, sí, es alemán, así que sí.
Intenté poner en la dirección un NS.
No, eso no va a funcionar. No.
¿Cómo le hacen para poner NS? Hay que hacer como...
Okay, how's it going? You want more time or is all good? I mean, I think let's move forward. Also, if you don't have the solution, you can also just do it later. And maybe I will not even look into it. I mean, you can also just show the answer, as you see here. And then you will get it. Oh, sorry, disculpa. Cambió en inglés. También pueden ver como si ustedes todavía no saben la pregunta acá, también pueden ir acá a Show Answer. Si no, también pueden como tener más tiempo después y lo pueden probar. Y por eso también no vamos a ver la solución. O si quieren también podemos ver la solución, pero capaz que si ustedes quieren que continúe más tarde, ¿no la vemos? ¿Ah? Vamos a ver la solución y continuamos. Bueno, then vamos acá, check answer. Acá, la dirección acá, lo más fácil sería solamente poner la dirección acá, que es la default address acá, pero lo mejor sería que si ustedes ya estaban usando MetaMask, también lo podrían copiar la adresa suya y lo ponerlo acá adentro, que también podría funcionar. Después acá, eso era fácil, solamente un integer negativo, ¿no? Podría ser cualquiera. Y después acá la más pequeña es con el 8 bit y después el valor más pequeño es el 0. Así que sí, esas serían las soluciones para esa misión. Y bueno, continuamos. No, sí, pero tenía que ser una que funciona, que es una valid Ethereum dirección. Pero sí, lo más fácil sería solamente tomarla de acá, o lo más fácil todavía es solamente la default, que está esa. Ok, ahora vamos a ver un poco rápido a los variables. Acá tampoco es algo muy interesante, algo muy difícil. Y sí, por hoy vamos a ver las cosas más fáciles y después ustedes pueden continuar un poco. Así que tenemos tres tipos diferentes de variables, que tenemos los variables del estado, que esos ya hemos visto nosotros, ¿no? Los state variable, que son esos que están que vamos a poner en la blockchain, y si cambia algo, el valor de esa variable también, eso se cambia en la blockchain, y también por cambiarlo tenemos que hacer una transacción. Por eso, porque queremos cambiar algo en la blockchain. Y sí, esos también cuestan plata. Así que, Ethereum, no plata. Así que sí, así que esos son los del estado, porque cambia el estado, el state variables, el state of the blockchain, o el contrato. Y sí, eso tenemos acá, son afuera de una función. Después tenemos acá variables locales, local variables, que tenemos acá adentro de una función, y después vamos a ver también a funciones, eso va a ser el próximo capítulo. Y ahí tenemos como una función, do something, vamos a ver en más detalle en el próximo capítulo en funciones, pero también pueden ver que eso es como una variable que solamente existe entre esa función. Así que es una local variable, capaz que la mayoría de ustedes también lo sabe ya, y eso serían los global, pero no son globales, esos son state variables, y esos son los globales. Pero sí, esos son los locales que no vamos a poner en la blockchain, eso no va a cambiar la blockchain, solamente existen cuando ejecutamos y llamamos la función, en ese caso la doSomething. Y después tenemos los variables globales, y eso también, que alguien dijo que sería bueno si podíamos tener la INS address de una la INS dirección de una dirección. Y sí, con ese Eso sería un poco diferente, pero esos variables globales también se llaman special variables o variables especiales, como son variables que podemos usar para saber algo de la blockchain, como el estado de la blockchain o cosas de la blockchain. Es más que solamente una función, pero una variable que nos da más informaciones. Por ejemplo, tenemos acá dos. Uno es el block timestamp, que mucha gente como usa, que no hay una manera fácil para saber como cuánto tiempo es, pero el block timestamp como es una manera de saber eso. Así que ahí podemos saber cuál es el timestamp del current block. Que algún miner puso como un nuevo block y eso tiene el timestamp y eso podemos saber. Después acá tenemos, esa es una muy importante que van a usar mucho, que con el message.sender, y eso es que lo llamamos, el valor de esa global variable va a tener el valor de la persona o de la entidad que llama esa función. Así que con eso, la persona o la entidad no tiene que poner su dirección acá adentro, pero porque podemos usar esa variable global message.sender, con eso podemos saber cuál es la dirección de esa persona. Sí, la address of the caller. Y sí, y hay un montón de diferentes variables globales que lo pueden ver acá también en la documentación de Solidity. Sí, acá pueden ver algunas. Y eso también va a ser bueno para la próxima misión, porque ahí la misión es para crear una nueva variable estado pública llamada block number, que es un uint, creo que capaz que eso no se dice acá, pero es un uint, y que queremos hacer es que asignar el valor del actual número de bloques de la variable del estado block number. Eso va a ser un poco, capaz suena un poco raro, pero si ustedes ven a la documentación, capaz que van a encontrar algo que va a funcionar por eso. Así que sí, acá vivíamos en ese capítulo a diferentes variables, ¿no? El state variable, local variable y después a esas variables globales, y eso está bueno a jugar un poco con esas variables globales. Y sí, con el link que hay acá pueden ver la documentación y después capaz que pueden encontrar la solución por esa misión con eso. Ok, así que lo doy otros 5 minutos y creo que después tenemos una misión más y después de ese vamos a ver cómo usar el script para minting un NFT. Así que una misión más y estamos listos con eso. Ok. Bueno, empezamos. Y sí, hay que ver un poco en la documentación. Okay, so I hope this was, sorry, espero que el tiempo estaba suficiente para verlo. And sí, ya lo había alguna gente que tenía la solución, que acá tenemos un uint público que se llama block number, que tenemos acá. Y después acá usamos esa variable global o variable especial que usamos block.number y ahí le tenemos. Ok, tenemos un poco tiempo, así que vamos al próximo capítulo. El último capítulo para acá. A ver. Ok, vamos a ver ahora a funciones. Así que acá tenemos ese contrato que se llama Simple Storage. También otra vez es parte de acá del Solidity by Example. No sé dónde está ahora, pero sí debía estar acá al principio. Y eso va a ser muy fácil. Tenemos como un número, un uint, así que es como la variable se llama num. Es un uint, es público. Sí, lo mismo que hicimos antes también. Es un state variable, variable del estado. Y ahora tenemos la cosa nueva que sí, solamente lo declaramos, pero no lo vamos a asignar un valor ahora. Así que ahora tenemos las funciones para hacerlo un poco más dinámico, a donde lo queremos dar un nuevo valor y también que queremos leer el valor de esa variable. Así que por eso creamos una función y la palabra clave, muy fácil, también se llama función y después lo podemos dar un nombre. En nuestro caso usamos el nombre set porque lo queremos poner un nuevo valor. Después acá tenemos en los paréntesis acá tenemos los parámetros para esa función que en nuestro caso lo llamamos también num, pero para saber la diferencia tenemos un guión bajo acá, así que sí, eso es como para saber que esa es diferente de esa, pero también va a tener, lo vamos a usar para eso. Y después tenemos que decir también qué tipo es, y en nuestro caso es un uint también, porque lo vamos a usar para entrar un nuevo valor en el num. Así que en la variable del estado que tenemos acá. Así que eso tiene que ser lo mismo. Y después tenemos que decir otra vez, acá tenemos la visibilidad, así que quién puede usar esa función. Y si lo ponemos público, todo lo puede llamar. Así que nosotros y toda la gente, todo el mundo puede llamarlo de afuera del contrato. Así que eso lo queremos hacer para también usarlo. Y al final, acá adentro de la función, lo asignamos el valor del parámetro guión bajo num al state variable solamente el num. Y de ahí ya estamos. Muy fácil, así podríamos poner un nuevo valor a nuestra variable. Y ahora tenemos acá cómo leer una variable del estado. Y por eso creamos una nueva función que se llama get. Y ahora en los paréntesis acá no tenemos nada adentro porque solamente hay una, no tenemos que especificar qué queremos, solamente hay una cosa que podemos devolver y eso es el num. Y así que no hay que poner algo acá especial. Otra vez va a ser público y acá hay una cosa nueva que es ahora una palabra clave que se llama view. Y con eso la podemos diferenciar, esa función, y eso es una cosa nueva de Solidity y blockchain que ustedes no van a ver, creo, en otros lenguajes de programación. Y eso es que con el view ahora decimos que no vamos a cambiar el estado del blockchain, no vamos a cambiar acá nada, solamente queremos leer algo de la blockchain, pero no queremos cambiar algo. Así que no hay que hacer una transacción. Con eso, porque cambiamos algo, así que el valor que tenemos acá dentro de esa variable en la blockchain, eso va a cambiar. Y porque lo cambiamos, tenemos que hacer una transacción. Así que hay que pagar para eso y eso va a ser una nueva parte de la blockchain. Sí, esa transacción va a ser parte de un bloque que va a ser en la blockchain. Y eso es porque queremos cambiar algo y eso va a cambiar en todo, sí, en toda la blockchain, en toda la gente que tiene una copia de eso. Así que hay que pagar para eso. Pero acá, como solamente queremos leerlo, no hay que hacer una transacción. Bueno, y eso se puede decir con la palabra view, o también hay una otra palabra que se llama pure, que no vamos a usar hoy, pero también van a encontrar acá en ese tutorial si quieren seguir con eso. Y eso, el pure, es que ni un vamos a leer algo, solamente hacemos una computación. Pero eso no vamos a usar ahora. Y después acá tenemos que definir como qué son los tipos que vamos a retornar. Y en nuestro caso vamos a retornar solamente el uint, porque vamos a retornar el num que tenemos acá, de la state variable, y ese num es un uint, así que va a ser el tipo uint, y después solamente vamos a retornar el num con el return, palabra clave return, y bueno, eso ya está. Y con eso la pueden compilar y también acá lo podemos ver cómo funciona. Vamos a apretar acá deploy. Y acá con set vamos a poner 2. Y acá tenemos el 2, 3, 3. El negativo, eso no funciona, porque es un uint. Y acá también tenemos, porque es público acá, también tenemos la otra función que tenemos automática, que ya dijo, para devolver el valor. Bueno, eso es era la final capítulo acá. Y creo que acá hay una opción que es muy fácil, si la quieren hacer, crear una variable del estado público llamada b, cual es del tipo bool y se inicia con true, y después crear una función pública llamada getB que devuelva el valor de b. Sí, eso debe ser, creo que eso va a ser fácil, no vamos a tener muchos problemas con eso, así que voy a poner capaz 3 minutos. Y también había una pregunta, creo, ¿no? Sí. Sorry. Ok, sí, la última media hora que tenemos, así que sí, vamos a ver la solución para eso. Ok, como dijimos, crear una variable del estado público llamada B, ¿sí? Y se inicia con verdadero, true, que tenemos acá. Y después creamos otra función que llamamos get-b. Y eso, eso sí, devuelva el valor de b. Sí, tenía que ver como así. Y sí, espero que ustedes, eso creo que no era tan difícil. Que hay muchos problemas, lo vi, es con el que si vas a check answers y tarda un tiempo y no la página dice que timeout o algo así. Así que normalmente tendría que funcionar un poco mejor si el internet, si el wifi está rápido. Pero si van a tener como problemas también en la casa o algo así, nos pueden avisar. O normalmente también se pueden como solamente apretar reload y de ahí tendría que funcionar. Pero sí, avísanos si hay problemas con eso. Pero bueno, vamos a ver que acá, como nosotros vemos a la sintaxis básica, tipos de datos primitivos, variables y funciones. Después hay funciones vista y puro, eso ya hablé, que también como eso es el puro, el pure, y la view, que ya vimos acá. Después hay modificadores y constructores, que eso también está interesante. Inputs y outputs es un poco más complicado. Visibility, control flow, sí, estructuras de datos un poco más complejas, loops. Hay un montón de otras cosas que ustedes, si quieren, pueden que pueden continuar a ver todo eso. Después tenemos como transacciones acá. Y eso es para principiantes, ¿no? Es algo que es más o menos fácil. Y todos esos contratos vienen de los contratos de Solidity by Example acá. Que creo que son muy buenos y es algo que mucha gente usa. Y después también, si tienen como más interés, también pueden ver acá esos contratos, como verifying a signature. Cosas muy interesantes son acá y creo que eso van a ser también, va a ser muy bueno para aprenderlo. También tenemos acá como los ERC 721, el NFT contrato. Y eso es algo que vamos a ver ahora, porque eso que es el tercero parte del workshop, es a ver cómo podemos mint un NFT y capaz un poco podemos ver qué es un NFT. No tenemos tanto tiempo, pero espero que lo podamos hacer. Sí. Bueno, vamos a... Acá, eso era el curso Solidity para principiantes, pero también hay otros cursos de Solidity NFT, de ERC 20 token y contrato de subastas. Acá es como un poco más complicado, ya es como un contrato, como hacer un contrato de subasta, eso de un NFT. Eso es ya un poco más complejo, pero eso ahora vamos a ver un poco en lo del contrato de NFT. Solamente un poquito, porque no tenemos tanto tiempo. Pero bueno, no voy a ir a la introducción, pero también ustedes lo pueden leer. Espero que lo voy a intentar a explicar un poquito. Hay dos diferentes tokens y como también el token, como ustedes ahora han visto cómo crear contratos inteligentes. Y con esos contratos inteligentes también se pueden manejar tokens. Y los tokens que espero que cada uno de ustedes lo conoce o es escuchado de NFTs. Y esos tokens tienen que ser manejados de algo. Y esos tokens se manejan por también contratos, como los contratos que ustedes lo vieron, ¿no? Y esos contratos la gente lo escribe y después tienen un token y después pueden hacer cosas con el token. Sí, ya lo expliqué en el principio que hay los monedas, los tokens ERC 20, que era muy popular en 2017, que ahí la gente hizo un montón de ICOs, Initial Coin Offerings, a donde la gente puso sus monedas afuera, como escribió un contrato de tokens, de monedas, y después, después dijo que van a hacer algo con eso. Bueno, eso era muy, muy famoso en 5 años atrás. Y ahora, que es muy famoso en los últimos años, son los non-fungible tokens, los NFTs. La diferencia es con el fungible tokens, que todos los tokens son lo mismo, es como una moneda, y el non-fungible token, todos los tokens son diferentes. Así que, por ejemplo, si quieres crear una moneda o votes o algo así, podría ser que todos son los mismos y lo puedes intercambiar, pero si, por ejemplo, quieres poner una obra de arte o algo que es especial, es diferente, lo usas con un NFT. Sí, y con esos contratos que también, para que son interoperables y la gente lo puede usar como en sus wallets, o también pueden interactuar con otros contratos, para que todos esos tokens se pueden usar sobre el ecosistema. Por eso hay un estándar de tokens. Y eso es el estándar que se llama como ERC20 o el ERC20 o el ERC721 para los NFTs. Y nosotros vamos a ver un poco a el ERC 720 y creo que está acá. Bueno, eso tienen el interface, así que tienen funciones que todos que tienen que usan ese estándar van a tener esas funciones. Y eso está bueno porque así si creas algo, lo puedes hacer, por ejemplo, si quieres interactuar con un wallet o si quieres interactuar con otro contrato, sabes que va a tener esas funciones y lo puedes usar. Bueno, vamos a verlos. Acá también hay eventos, pero no vamos a andar en eso. Hay como funciones, por ejemplo, balance off, a donde con esa función se sabe la dirección de alguien, cuántos de esos tokens esa gente tiene. Esa es esa función balance off. Tiene la función owner off. Así que cada token en el NFT estándar tiene una token ID. Así que el contrato puedes mint un nuevo NFT y siempre va a tener otro ID. Y así que puedes saber de ese ID cuál es el dueño de eso, cuál es la dirección de eso. Y después también lo puedes transferir a otra persona, que es una función muy importante, ¿no? Acá tenemos, sí, otra forma de transformar, y también approve, que significa que otra gente le puede manejar los tokens para esa gente. Y acá se puede ver si está approved. Y sí, eso es, bueno, no vamos a ver todo eso en total, pero que es importante que ya se ven, no hay tantas funciones, hay algunas que son importantes, y esas que las funciones que ustedes si quieren usar o si quieren hacer su mismo ERC721, su mismo token contrato, lo pueden usar a esos, o van a usar ese estándar para otra gente lo puede usar. Y una implementación de ese estándar lo tenemos acá de OpenZeppelin, que es una compañía muy famosa para hacer contratos que ya un montón de gente tiene muchos audits, mucha gente lo ve y ve si todo funcionó, y esa es una implementación de eso, por ejemplo, que va a tener todas esas funciones que vimos como approve, pero que vimos nosotros era el interface, y que vemos ahora es que como algo implementó todas las funciones y todavía más que ellos tienen acá dentro. Bueno, eso es como un contrato de NFT, y que se puede hacer también en Remix, que está muy bueno, es que, por ejemplo, acá usamos un contrato de OpenZeppelin, el ERC721 acá, y y solamente lo importamos del GitHub de ellos. Y acá creamos nuestro mismo ERC o mismo NFT contrato y se ve así nomás. No tiene mucho más que eso, porque lo usamos todo que la implementación de ellos, lo damos un nombre, tenemos un símbolo y acá ponemos donde le ponemos la metadata de ellos. Bueno, eso es solamente una introducción muy rápida por los NFTs y si quieren ver más, lo pueden ver en ese curso. También tiene la función acá mint, así crea un nuevo token con una ID, un nuevo NFT de ese contrato. Pero yo quería explicar eso porque que vamos a hacer ahora es que vamos a mint un NFT de Remix que es como un reward. Y eso es también otra cosa que se pueden hacer con Remix, es a interactuar con ejecutar un script y así que podemos usar una biblioteca como Ethers.js y con eso podemos escribir JavaScript también o TypeScript en este caso y podemos mint en ese caso el NFT. Y eso es que vamos a ver ahora. Que no va a durar mucho, pero capaz que vamos a tener algunas complicaciones con el Wi-Fi y por eso puede ser que tarde un poco más. Pero sí, pero eso solamente quería dar una introducción por los NFT y también me pueden preguntar después si quieren saber más sobre eso, pero para saber que no es tan complicado y se pueden usar contratos que ya existen y nosotros usamos un contrato así para dar los Remix Rewards. Ok, bueno, ¿qué hay que hacer? Es más o menos seguir que nos inscribamos acá. Espero que cada de ustedes ya pusieron la dirección suya acá y ya veo que hay un montón, así que espero que sí. Nosotros que vamos a hacer primero es clonar ese repo. Así que voy a ir acá. Vamos a ver, ok. Acá estamos en el File Explorer y acá hay un botón acá para clonear un Git repository. Acá tenemos que poner la URL y eso es el repository que queremos usar. Así que eso es que voy a clonear. Eso es que ustedes van a encontrar acá. Ok, eso es ese que dijo que puede ser que tarda un poquito. El repositorio es un GitHub y... ¿Ah? ¿Dónde lo guarda? Sí, está... acá ya tenemos. Lo van a encontrar acá, son los contratos. Si lo clonearan, lo van a encontrar acá. Y acá lo ven, nosotros tenemos, ahora funcionó, acá tenemos contracts y acá tenemos ese contrato, Remix Reward Upgradable, y eso es un contrato. Y acá también van a ver que acá también usamos un montón de los Open Zeppelin contratos también, y eso también es como un contrato de NFT. Un poco más complicado puede ser, pero acá lo pueden ver. Pero nosotros no vamos a andar sobre eso. Y ahora hay que compilar eso. Lo pueden hacer así. Y eso puede ser que va a tardar un poco también. Ok, eso se ve bien. Así que hicimos eso, clonear, completar, y ahora vamos a ver el script que queremos usar. Vamos a andar al File Explorer otra vez. Y acá tenemos scripts. Y acá tenemos el remixer mint. Y eso es el script. Y acá ven que eso es TypeScript. Acá también TypeScript. Y tenemos, acá importamos Ethers, que es una biblioteca muy famosa para conectar. Y acá ahora tenemos la dirección del contrato, que ese contrato que ustedes ven acá, ya lo deployamos, eso es live on blockchain de Ethereum en Optimism. Y después que hay que hacer es que conectamos con ese contrato y nosotros queremos que llamar la función SafeMint acá. Y para eso queremos a Mint un NFT a una nueva dirección. Así que ustedes, la dirección que ustedes pusieron en acá adentro, yo por ejemplo puso esa, ahora lo pueden poner acá adentro. Y ahora el scripto debería ser listo. Ahora la última cosa que tenemos que hacer es conectar tu Optimism. Así que espero que ustedes vieron acá las instrucciones acá, que se pueden, after instalar MetaMask, se pueden ir acá nomás, apretar a Connect y después deberían ser conectados acá a Optimism, debería ser Optimism acá. Y ahora acá se puede conectar a Optimism también. Y acá nosotros vamos a usar ese Injected Provider MetaMask, que significa que ya no usamos la virtual machine del browser, pero usamos la conexión que tenemos con MetaMask, que en nuestro caso es la conexión a Optimism. Y ahora sí es esa dirección que tiene un poco de Ether. Acá también vemos que tenemos un poco de Optimism Ether. Así que eso debería ser suficiente. Y ahora podemos ejecutar el script. Así, ahora ven que MetaMask me dice que tengo que firmar esa transacción, pero acá. Y ahora vemos si todo funcionó. Public Mint, se ve bien. Y acá tenemos también ese Remix Rewards. Acá abajo es como una página para ver los rewards. Y yo, a ver, si yo ya estoy acá. Capaz te tengo que conectar. Sí, capaz que tarda un poquito, pero se ve que acá funcionó. Interactuado con el contrato y tengo ese token. Bueno, eso era como el mint de ese particular script. Y no sé, ahora creo que ya estamos casi listos con el tiempo, ya estamos un poco más del tiempo. Así que si eso no funciona para ustedes, también yo pienso que si alguna gente lo quiere continuar con eso, y porque sé que la red acá es un poco lento, también podemos ir al hackerspace abajo y lo pueden tratar ahí. Y yo puedo ir para algunos minutos, si lo quieren probar ahí, también lo podemos probar ahí. Pero ya, no sé, si tienen algunas preguntas o lo están tratando y tienen problemas en algún lado, me avisan. Ok, se ve que todos están haciendo algo, así que espero que funcione. Ok, la pregunta era, bueno, después de conectar con MetaMask en Remix, solamente ejecuté el script. Así que solamente me fui acá y apretó a ese botón. Pero si tenemos que ser conectado con MetaMask, que se ve acá, y si tenemos que estar en Optimism, que está acá, que creo que es el Custom 10 Network, y hay que tener un poco de ETH, así que hay que ver si tienen un poco de ETH, porque si no, no va a funcionar. Si no tienes suficiente ETH, vas a tener un error acá que se dice insuficiente ETH. Eh, ac- Creo que el contrato es que ustedes no saben, pero que es que tenemos como un whitelist a donde pusiéramos las direcciones que ustedes ponían acá. Así que ustedes creo que pueden, con esa dirección, pueden mint un NFT, dos NFTs pueden mint, pero no más de eso. Así que lo pueden ejecutar 2 veces, pero no más. Así que también para otra persona, si quieren, lo pueden ejecutar. ¿De qué? Ah, creo que es un IPFS, pero no sé. La verdad que no sé. Creo que. Acá tenemos el File Explorer. Acá lo puedo abrir los contratos. Eso es el contrato que compilé. Eso es el contrato que se hay que compilar. Y después acá hay el script, que es en TypeScript, que hay que ejecutar. Después de ese está compilado. Y hay que ser conectado con MetaMask sí. Y eso debe ser todo. Aparte von también conectado a Optimism. Ah, no, la imagen no se puede cambiar, porque la metadata está en el contrato, no se puede. Sí, está en el contrato. A veces sí que se puede, pero así no. Sí. Bueno.
Ya hice todo, ya me dio un hash de que ya me devolvió esta información.
Ujú.
Y bueno, el siguiente paso creo que es
Ok, bueno, creo que no sé cuál es lo próximo. ¿No? ¿No hay nada después? Ok, bueno, entonces también creo que pueden estar un poco más acá. Pero el workshop oficial terminó, pero voy a estar un poco más acá. Si tienen problemas, lo pueden ver. Pero sí, hay como las camisetas ahí. Y si quieren, sí, solamente continúan con el workshop. Y ya, gracias por todos que estén acá. Está muy bueno. Hasta la próxima. Bye.
Thank you.
chains. So it was actually quite hard, and for us. Other chains. So these are actually our questions, and that's why it was so long to all of us to learn more. And once we looked at all the other chains, we want to talk about the results. This is how it's actually my pleasure to announce that I'm going to meet some very prestigious since yesterday, and I'm gonna. So you know when you move your funds. We should constantly monitor infrastructure for upgrades, and we should really monitor the security parameters. And this is tough. Because some of these constructions are quite complex, and you need several information, you need to be able to read from spreadsheets. I will try to do that. It's not arrived. Quite a big one is the multi-chain. Multi-chain is one of the biggest bridges with the biggest DL. Turns out that last year they actually removed from escrow quite a lot of funds, literally millions of funds. So normally for that type of bridge, you expect that you put your funds into escrow, and on the other side of the bridge, to provide liquidity to any tokens on a lot of different chains. And to make sure that this is exactly what happened, you would have to like go to all the other chains and check it out. But you know, my question to the multi-chain team is, was this part of the contract, right? Were users aware, and what is the consequence? Can actually users withdraw all their funds? And more importantly, what is this additional trust assumption? Because if validators can remove funds from the escrow, with all sorts of things as well, right? How do you actually monitor what they're doing? So that's one. Then you have something called Plasma Bridge. Some of you, again, might be aware of, because this is one of the two bridges that you normally use to move tokens to Polygon. And this particular one has a very interesting documentation. It says in the documentation that it provides increased security guarantees because there's a 7-day withdrawal period. During that period, you can challenge validators from Polygon. So it's kind of like a Plasma exit mechanism. However, to the best of my knowledge, this was actually implemented and deployed on the testnet, but it was never deployed in mainnet. Right? So if you look at the mainnet code, by the way, who's looking at the mainnet code and the contract? Actually, very, very few of them. You can see that the method that allows you to actually challenge the validate this is empty, right? You can't do that. So frankly, the Plasma Bridge right now has the same security assumptions as the POS bridge, the main bridge that you normally use in the Polygon, and it's got this user nuisance of 7-day withdrawal period. And the last one that I wanted to mention, which in the documentation the risks were properly disclosed, but again I think that the user should be aware of that if you use the Omni Bridge to move your funds to the XDAI chain, they might invest some of these funds. They might actually put the funds that you normally expect to be in the escrow into Aave, into Compound, or wherever they like actually, right? So normally it's called rehypothecation. This is the practice where banks are using your funds to actually invest them, and you're running into liquidity risk potentially. If you were to withdraw all the funds, they may not be available. They might be like locked somewhere in say Aave or whatnot, right? So the whole process is very transparent, but the power of validators to actually do that makes it easy. Summarize what you will be seeing on the beat bridges section. So first of all, we kind of differentiate primarily two different bridge types. The first one is a token bridge, and that's the bridge that mints tokens on the destination. And then, so this is something that we should be like intuitively expecting. What is the most confusing for end users is that if you go to a UI of almost any bridge, you will not know if you're actually using token bridge or a liquidity network. In fact, some of the bridges are hybrid. sometimes, for some tokens, they may actually mint you tokens. Sometimes they may use liquidity pools, and it, like as is the case for the multi-chain, you can have like some mixed results. Some of the tokens may be minted for you, and some of the tokens may be actually coming from the liquidity pool. So these types of bridges we will call hybrid. And again, if you compare token bridges to liquidity networks, they have a very different risk profiles. So for the end users, I think it's very useful to actually understand the difference between the two, right? You have unlimited liquidity for the token bridge. You have tokens that if you keep the token at the destination, you will face the risk of the validators of that bridge. And generally, token bridges can be quite slow and expensive, while the liquidity network is almost like the opposite, right? It has limited liquidity typically, so you may end up with your tokens being stuck. But tokens have the destination risk of this network. They're actually at the risk of the token bridge that was used initially to move tokens to the liquidity network. So again, this is the risk that's actually quite difficult to disclose. And finally, they can be fast and they can be cheap, right? So this secure bridges, provided that there are no bugs in the implementation, right? So what can go wrong? Even if you've got external validators, everything can go wrong, right? They've got full access to the escrow, they can mint whatever they want to mint. If there's a bug, you know, you can have billions of tokens minted out of thin air, and validators can censor, they can steal, they can freeze funds, they can do whatever, right? You have to fully the end game for all of us should be to build trustless bridges. Because everything else, we need to put our trust on some other parties, and these bridges are very, very hard to build. We had some problems with Arbitrum Bridge. There was a bug. It was essentially, fortunately, uncovered, and the bridge wasn't hacked. But as you can see, the roll-up bridges can be buggy. Same situation happened with Optimism, and this is one of the reasons why these bridges are right now hopefully yet permissionless, and I hope they will be very soon. As you can see from this transaction, that's actually what is it? This is actually over 700,000 ether from one version of the bridge to another version of a bridge, and that power has Arbitrum multisig, right? So even though you may think that Arbitrum has fraud proofs and whatnot, they still have a multisig that can move all the funds from the bridge, and they did in this very transaction. We saw this transaction, we analyzed this transaction, it was pretty great, and no one knew that there was a transaction moving essentially billions of funds around. So, this is how short term, they might be quite useful because we need that functionality, but in the long term, eventually we need to find a way to actually make sure that the code behind all these roll-ups is actually secure. And as I said before, I mean, the code is very, very complex, right? These bridges are actually very hard to analyze. I guess for a while, none of these roll-ups have shed the training wheels, so you should really also understand what are the current assumptions. Every single team that we talk to, they have promised us that eventually these training wheels will be shed. So there's some hope for the future, but how do we make sure that such complex software is bug-free, and how do we make sure that these roll-ups will not be hacked and stealing funds? And I think this is probably one of the hardest questions from the perspective of perspective. We don't seem to have a solution for dealing with discovery of potentially critical bugs without actually relying on some oversight. If the bug is found, we all want some good guys to shut down the bridge, fix the bug, and restart the bridge. That's quite obvious, right? No one wants really the bridge to be drained by malicious actor. However, right now it just seems that the best we can do is to sort of create a multisig of some trusted security engineers, I guess, a security council of sorts, and these guys can perform
Okay, so I'm going to give another kind of thing to worry about that I hope is going to be at least useful to you on a going forward basis. And it revolves around the term digital ownership, of what is digital ownership, how it's being manipulated, what are the risks, what are large corporations trying to do about it, and the like. But before I get on a downer, I wanted to say thank you all for moving Ethereum to proof of stake. I mean, what an enormous achievement. Thank you very much. And I actually moved all of my personal Bitcoin to Ethereum because of this just in the last while. So thank you all. It's really wonderful to see this whole ecosystem take steps forward in the way that you guys have brought it. Okay. Publishing the files of digital ownership versus the decentralized web, which is the working internet archive. So what does it mean for the mega publishers, soon to be internet So even though if you've paid them for a textbook in the electronic world, you can't go and sell it to somebody else or give it to somebody else or actually own it in any real sense. So where the wonder of the blockchain was to have an artificial scarcity in the digital world, we've now allowed also mechanisms of holding on to things past when it was normally released based on being paid in the we have about 2 million hours of television news, so you can search what people said, which has been very important. We're not just the United States television news, we also now have Russian and Ukrainian news that's being useful to find out what different populations are getting fed by the large media companies. And we have about 6 million books that we've digitized, one page at a time, that are available for free for lending, and a lot of web pages. We're probably best known for the Wayback Machine, but we've got over 99 petabytes of data. I just love this number because it's just kind of ridiculously long. And so we're going to break through 100 petabytes of data. So we've also been pioneering this idea of the decentralized web by going to values-oriented next generation web, where it's peer-to-peer backend on the web with the file storage. Parts of this pioneer happened to 1984. So is this happening? Yes, it is happening. So they get to hold on things forever. They can decide what can be done with them. And these issues will be forever. So they're going to get access to what? And they can change anything about what it is that they can see into a way. Contract, they can go and set whatever terms they want. And there will be fewer and fewer publishers. there seems to be a competition in the United States between the states to go and say how much banning can they do, and that's a pride in one of the parties in the United States to go and surface and restrict of what people can see in the library system. So there's libraries can't buy things, they can't, and they're starting to get rules by governments to take them out. What libraries do is they buy, preserve, and we have time for a few questions, if at all. Otherwise, you get some more time back. adherents and having close-up violence of certain soldiers in their war. We want to have copies of these, but we don't want to be at publishing platforms. We put some speed bumps in the way of making it so that it's not just a Twitter click. YouTube and those sorts of things are publishing platforms. There's also some things that are not just calls for violence, but they're ongoing harassment. So these are I'm having a little hard time understanding.
Oh, sorry, first. So, I suppose everyone in here has used torrents before, right? And there is a problem of seed.
So there's been a long bed of work to try to get open access network. Basically, writer pays government created material, which is great, but it doesn't solve everything. So how do you get people paid as well as we can to build a system that works for more than just a few big publishers. And so, do we have the solutions in the digital world? No, not yet. Hence this talk.
Thank you so much, Brewster.
Thank you very much.
I'm sure there's other people who have questions. You can find Brewster over to the right. Right now, it is time to eat, so feel free to go out to the lounge and grab yourself a bite to eat. I hope you have a great rest of your afternoon. Again, my name is Gloria. I'm with Little Box. If you have any questions or you have any needs, it's fine.
We need that. We want that. Yeah, see. Hey, everybody. Wait, sorry. Yeah. Okay. Hey, thanks everybody for being here. I see that we have currently some people standing. Does anybody who has an empty chair at their table want to raise your hand right now? If the chair is taken, it's okay. We won't judge. All right, so this is kind of a weird setup, so we're going to keep this a little bit informal. We have an empty chair here, as you can see, and we're doing a little bit of a mini fishbowl. We have a lot of people in here who've probably thought a lot about the topics that we're about to discuss, so we want to invite you, if there's a question or a topic that you feel like you have something to add, come sit with us for a minute and join in. If you decide to do that, give us a quick, like 15 to 30-second introduction of who you are, where you're coming from, and then just join the conversation, but also leave space for others to do the same. When you've kind of said your piece, go home. So I wanted to open this before we introduce ourselves with a quote from one of my favorite essays of all time. The optimal user is someone who does not want the burden of choice or feels they do not have the time to make their own decisions. It is for this person that the modern web is designed, and it is this type of person the modern web encourages all of us to be. So this is from Zach Mandeville's essay, The Future Will Be Technical. It's at coolguy.website. It's a really excellent piece of writing about sort of our relationship to modern technology and the way we exist online and the ways that it damages us. So, starting from there, sorry, I'm going to pull up my notes again. I'm going to have our panelists introduce themselves in a second, but just to kind of set the stage for our topic here, in the modern web and what we think of as Web 2, everything has kind of these guardrails on it, right? Everything is simplified, our paths are clear, you have only so many options, and this makes things easier, but it's also really disempowering. So I think that we all in this room probably agree that things like can and should be different. But what that means is still a little bit fuzzy, right? Like it's still left to be defined, and there's even an argument to be made, I think, that it shouldn't be defined so much as discovered, like in cooperation with the people that we're designing for. So with that, I'm going to invite the panelists to introduce themselves. Let us know, less interested in affiliation and more in sort of what you do, what your background is, and the kinds of people that you design for, who you think of as your users.
Awesome. Hello. I am Scott. I co-founded Gitcoin back in 2017, I think. I'm trying to remember. It seems like a while ago now. I think for me, you know, I actually don't come from, which is, I'm the outlier on this panel, like a design background, but I do a lot of community design and think about the role of the community in participatory decision making, both in the context of the DAO that we run, but also in the process of, you know, things like quadratic funding, which are more about local first sort of community-led decisions for funding. And I think, you know, the quote that you mentioned is actually like very resonant to me because the experience definitely I had growing up in the web, I think reflects that, and certainly was, I think, like a, you know, I was at this era, I grew up in this era where I think it was just on the precipice of things like Facebook and all these big platforms, which I think I don't need to dive into the details on, like, that we all know kind of have created this tension. And I sort of saw that magic of the internet disappear a little bit. And so I'm very hopeful that with the tools we're building here, we think about bringing that magic back and, like, kind of think about, you know, the weirdness of the internet as it used to be as something that we can actually, like, use in an empowering way within our own communities. So that's just what came to mind, but I'll leave it there.
That's perfect.
Take over. So guys, I'm Hester. I work as an independent UX researcher. I have a background in psychology and interaction design, and yeah, kind of do what is necessary at any given time. So I don't like sticking to a particular function or role too much. My kind of views, I think, have been mostly influenced by my last 5 years or so at Status. For those of you who are not familiar, it's one of the, I'd say one of the older projects in the space, but also an incredibly principled one on bringing privacy and security and participation to everyone by putting access to Ethereum onto a mobile phone, among other things. So that's kind of like what has, in a way, re-educated me, or educated me in the first place about kind of the ignorance I had around, like, privacy and data I'd be giving up, and kind of the trade-off that I was making for convenience. For context, I also spent a very short stint at the ads department of what is now Meta. And so I have a bit of a nuanced view on kind of the big bad wolf of social media companies as well, seeing problems as very systematic. So that's another lens I try to look at things from. So I guess that's me. Rachel.
Thank you. Yeah, my name's Rachel. I work at the Ethereum Foundation on the Privacy and Scaling Explorations team with Althea. My background is in fine arts. I went to school for sculpture, and I was doing a lot of work related to, you know, how do people interact with objects and spaces, and how can those interactions create conversation and communication. And it was also, I think, a time where I was exploring a lot of, like, how can you find metaphor to explain things in new ways? And that's what I relate to the work I do on the PSE team. We're working with developers who are creating zero-knowledge protocols and apps. The content is really abstract and complex, so a lot of my role is, like, spending time with developers or in conversations with Althea and other designers, other communicators, and saying, like, how can we find ways to make this understandable or familiar so that more people can be involved in conversations around designing for ZK. And the users that we're focused on right now are a lot of other app developers and designers who want to be making their own products with the zero-knowledge protocols that our team is creating.
Thank you, and I will also introduce myself, but I wanted to lead with you guys. So my name is Althea. As Rachel said, I also work on the Privacy and Scaling Explorations team at the EF, but I lead communications there. I actually also have a fine arts background, but as a fine arts major, I really gravitated toward what most people would call crafts. So I was a ceramicist. I was really a potter because I just could never really enjoy or get my head around the idea of creating things for people to just consume. I wanted to create things that people would, like, use and have as a part of their lives and eventually destroy probably or give away or whatever, that things that are not sort of there for money or to, like, you know, accumulate value or to just be pretty to look at, but things that really are a part of your life that you kind of build experiences around. so Rachel's kind of explained what PSE's like user base is, but in terms of communicating with that user base, I have a similar kind of approach of wanting to put out things that people, we don't just want to market ourselves, right? We like, that's not even a little bit what we do. But we want to educate people and like invite people to be a part of this, to create stuff with us, to give us feedback, to help us iterate, and to like just themselves become builders of the worlds that they want to live in. So this panel is ostensibly about user experience, but I think it has to start with kind of redefining what a user even is, and maybe just throwing out the word user entirely, because it kind of sucks for the way that we want to think about the people that are interacting with the things that we create, right? Like user implies this very passive thing. We make, you use, it's this sort of client-server model of like human interaction, and we expect as users to have our platform sort of consume and parse and spit back out little packaged things that we can like then process in this very simple and very sort of deadening way. I'm a little bit biased on all of this, obviously. But to think about users in a different way as being sort of more human, having like you know, entire lives, minds, responsibilities, like capabilities, really requires a huge mental shift. It means thinking in a very different way about sort of who's on the other end of whatever it is that you're working on. So I wanted to ask you guys, like, you've all come from more kind of traditional backgrounds, right? You didn't all start in Web3, which is a term I hope to never use again in this conversation. I'm sorry, I hate it. Because it defines itself against the thing that it's trying not to be, right? And we want Web3 to be something a lot better than like Web2 with a blockchain on it. Like those foundations are just broken. We don't want to build on them, we want to rebuild them. So coming from the backgrounds that you did, what have been some of the challenges or like the things that you've had to really unlearn or rethink or reimagine as you've been coming into this new space and like coming with this new approach?
I think for me, the biggest learning has probably been that, so I before I even did anything in I'll say crypto, not Web3, like the, my work was actually in more machine learning, which is very like much removed from the person, because I mean, you have sort of this notion in machine learning of like working with people, but only in the sense that like people at some point made like training data that you're then kind of applying like at a much later point. So like people in the past, like often like the far past did something, now you're kind of drawing on that. I think with something like quadratic funding and what we're doing with Gitcoin, it's much more about like kind of, even the word agent isn't great, but like I'll use agent as compared to like algorithm. And I think you know, what we're trying to do is like have people form kind of collective intelligence, like, you know, at a given point in time where they're actually present and they're actually participating and they're actually making a decision, you know, for now for the future, versus kind of using this previous past like training data. And I think that's, you know, one shift that's been really interesting for me to explore, and I think it's been kind of exciting to see that like crypto tends to be a lot more about like the idea of people being participants in a system, even when you know, they're just kind of providing signal or providing some kind of like aggregate information. But I think there's something deeper to that, which is just like, Simona Pop talks about this a lot too, also in the Gitcoin community, the idea of like kind of human thriving or like bringing your like whole self to something that you're doing. I think there's definitely, even beyond just like, I think the user experience kind of concept is a symptom of a broader way of framing like the interaction we have with like institutions, organizations, in which we sort of talk about like, oh, like I guess we're sort of like a customer, or we're like, you know, we have one facet of ourselves in the conversation. But I think it's actually much more important for us to think about like, how do we start to bring more of ourselves to the institutions that we're building, and then how do the institutions change as a result of that? So I'm kind of partly thinking of this in the context of like this shift from algorithm to agent, which isn't entirely correct, but is one thing I'm interested in. And then I'm also thinking of it in terms of like kind of bringing like one part of the elephant, and that sort of like blind man and the elephant analogy, to like actually trying to look at the whole elephant and look at the whole picture of each person that's in the community to better kind of serve them in the institution.
Thanks for mentioning the word future, because that was my cue to my notes. I was like, oh yes, future, that's what I wanted to say. No, I always have this, because we were talking about like users, what defines users, and in UX and design, like this is like always eternal ongoing debate, right? Users versus human-centered versus like the creators. There's a lot of different labels that you can give and a lot of different views on it. Yeah, I have my own, but I think my most critical insight relates more to how we define UX, which like traditionally, coming from a psychology, cognitive psychology background, was always focused on the usability side, like how efficient can we get people through flows? Are we providing the right information? But it was never focused around the future context. And to me, that's been pretty eye-opening, to the extent that I actually looked up the official kind of ISO definition of UX, which actually does include like context and long-term impact of what your experience is when you're using something. And yeah, to me, it's been most interesting to see how the systems that we're building require us to think beyond these basic flows, to talk in design language, to what is this going to do for people in the future, be it the initial users or indirectly their context, their environment. Yeah, I'll leave it at that. But Rachel. Oh, right, no, there was one thing I wanted to say. It occurred to me just now how interesting it is that we are sitting here talking about participation design and, like, reminder, open chair. Yeah.
Can I take it?
Yeah.
I will get some water.
You really just wanted the water, didn't you? We have to share a mic if somebody comes up. That's okay.
Hey guys, I'm Dimo from the Embar Wallet. And actually, one of the I've been with my team. We have some people here. We've been building products since 2013, and we got into Web3 in 2017 probably. And one of the huge issues that we always had with products is user experience, right? And the thing that we have with Web3 right now is that it's very hard to get those Web2 people into Web3. So what do you use? You use the tools that we have already, like email and password, right? And we're trying to make it really, really secure to get those people in a secure and known for them manner to get into our products. So I'm a little bit nervous. I'm sorry. So we have created a model where you can create an account with username and password. And we are smart wallets, which means we are built on top of smart contracts. And we're able to get the private keys and put them on the browser and put it on the backend. We have like 2 different private keys. And this way we're able to get something they already know and to put it in our product. We don't want to change, like we're not able to come with something like very different. It doesn't make any sense to come with something very different and educate people how to use it. We're using things that they already know. And the other point is that basically Web3 and blockchain is not, it's complex. And one of the things that we've been working on is explaining transactions in a human-friendly way. So
you're signing something and we're explaining you exactly what you're signing, so there is no bothering, right? And basically this is the two keys of our product. Of course, we have very smart people, and they've been working on very interesting things, and the wallet itself works with abstractions, and we're taking advantage of all those beautiful things that we have from the smart contracts in general. But this is why I actually attended this talk, because that's the most important part, like to get the Web2 users and bring it on Web3. That's the whole thing in here. So we have created a product that my mom can use easily. So she has an email, right? And our point here is to create it securely, like to create an account securely into Web3.
Yeah.
So yeah.
Awesome.
So go ahead.
Well, do you see, like, so, like, I mean, you're talking about, like, kind of privacy, security, like, and I think that, like, ties in to actually your work, like, Rachel, like, pretty deeply. Like, how do you think about, like, explaining that stuff to users? Like, that just seems very difficult, especially with ZK, especially. It's, like, even on its own complicated. But if you want to respond to that first.
So when I joined the team, that's where my head was. Like, wow, this stuff is so weird. How do I explain it to my parents? How can we make these apps that my friends and family can use? And I was very stuck in that like headspace, and it took me like a little while before I realized that was like a misdirection for us and our team specifically, because we're making public goods. What we want to do is we want to make protocols that other people can build with. We want to create proof of concept applications that people can use that inspire them to build and to make.
So I really liked also and thank you for being the first to join us, by the way. You're very brave. I'm not kicking you out. But if anybody else does want to come up, you know, that wasn't so bad, right? Yeah, come on. Yeah. But I wanted to just like come back to a point that you made about using kind of... You want to come back? Well, now we've got another volunteer. The more the better, right? But about using kind of human-readable language to describe these kind of complex processes. This is something that Rachel talked about in her presentation yesterday also, that yes, the stuff that's going on is complicated, but a lot of the times where you lose people is actually just in literally the language that you use to describe it, that people are not stupid and they're not like incapable, but they don't know what a zero-knowledge proof is. They don't know what a polynomial is, whatever it is, that like putting that stuff into just more common language can go a long way, and it's something that I think we kind of forget, that people do like to understand things, people like to explore, people are curious. So like to kind of empower people by helping them to understand what's going on and helping them to see the tools that are actually in front of them. So I think that was a really like a powerful point, so thanks for that. And did you want to?
Yeah, I just...
Oh, are we on? Or, sorry, Scott, did you have something to...
Okay, yeah, so just to build on what you were saying about complexity. So, well, hi, I'm Nelly, head of adoption at IXEC, one of the oldest projects in France. And, well, I want to share my experience because I love mass adoption and inclusion and diversity in the space. And when I joined this project was launched by researchers. We're doing blockchain confidential computing. And one of our first audiences was people looking for computing powers, data sets, applications. And it's a very technical audience. And then my job is kind to bring like our technology to masses. But when you're doing with oracles, confidential computing, you know, it's not as easy. So we came up with this thing. It's a new product. And it's about using confidential computing to protect our personal data. So the idea behind this is like, hey, our protocol is complex, and how can we make people identify with our product, with our features? So trying to sell oracles and trusted execution environments is hard, but we realize that the thing that was linking us to the audience is like nobody identifies with computing power to oracles. Is really hard, but we all have an identity. We all have personal data, and what we're trying to do is like create an avatar, and then you put all your personal data, email address, age, everything. You transform it using confidential computing, using confidential NFTs, and this is the way that now you're going to connect and access products and services in Web3. And then everybody can identify it with hologram. Hologram is me, is my personal data. I transform it and then I connect. So one of things I learned, like try to find that feature, that narrative that really connects you with your audience, even if your project or your protocol is complex.
Yeah, I think that's really important, like finding something that people can connect to or like see themselves in, or that, like Rachel said, again, in your presentation was just really good. I'm going to like reference it probably a few times. But something that feels familiar, like, something that is like something that you know. Did you have something you wanted to add there, Scott?
Well, just that one common theme, I think, and it probably will come up like as other people come up as well, which I'll like say anyone else wants to come up should. I think it's really actually interesting to think about like education, because we don't actually educate users in a lot of, we kind of do it implicitly in existing design paradigms where we're just kind of like, here's the flow, and like then you walk through, and by definition you've now understood what you're supposed to do. There's a lot of like pre-work that's I think required with like a lot of these products that like we're sort of touching on, and like I think there's the option of trying to reduce that. There's the option of trying to like have people better identify with that. And so like just going back to like your like sort of first question, like how are we redefining what a user is, like that part of participation is like being involved in kind of learning and growing and like educating. And that's actually something that people I think are like often in the context of like using a product or being part of a community like sometimes uncomfortable with, but it's really important to be able to do that. So.
Yeah, definitely. So, and that kind of leads me to, and I hope that this one will also be interesting for you. Welcome. Like another thing that I wanted to bring up, and I think education is like a big piece of this, but it's also much deeper. How you inspire people to take responsibility for the actions that they take, responsibility for giving the feedback that helps to shape a platform, just responsibility for kind of curating the spaces that we create together. What are some of the other things that we think about when we're trying to give that power to people and inspire and expect them to make that contribution back?
I can give you a quick response to that. No, I was thinking along the lines of the first two people that joined us up here, that we were talking about language, right? And how do you use language to help people understand what's going on. And if we want to talk about participation design, that to me is where the pivot is between users and participants. You need to know what's going on. You need transparency on the system in order to participate. So yeah, just like my line of thinking of the distinction between designing for users, designing for participants, we need a lot more system transparency, which also means we need to understand how these things work, and especially designers need to understand how to bring it then to the surface and communicate it. But I'm very curious how that aligns with what you were going to bring up.
So, hi, my name is Germany, like the country. So I'm co-founder of a hyper-local DAO in Tampa, Florida, called Tampa Bay DAO, TBD for short, because we're always figuring shit out. But yeah, so one thing we really like to do is help out the local community, and kind of comes back down to education and onboarding. Because in Tampa we have a diverse group of people, old, young, and one thing that kept coming up for us was before we started getting to ZK rollups or different networks in the crypto ecosystem in Web3, I realized as we were doing these really educational classes is we kept missing the initial principles in which governs crypto. And so what I did was created this visual web, and it has starting in the middle, which is the part that people forget is self-sovereignty. So people ask me, "Whoa, well, why are you here?" And I'm like, "Well, if you read the Devcon white paper, like, what does it really mean?" So that's in the middle, and then it kind of breaks out into the trifecta, and it goes into like trustlessness, consensus, proof of work, proof of stake, Ethereum. So then people start to understand like a ravel of, oh, now I understand the greater whole. Now I see why we need ZK rollups to get for that. And I think that really helps in terms of what you were saying as well, which is like education is key, but education forms of like the principles versus really getting into like the bytecode of like, well, here's how we got to do this. We got to shard it. Like, no, we don't. So yeah, that's all I just like wanted to say with that. I thought it was interesting because education really is important for that.
I really want to see that visual.
So I actually think I like posted just like open source. Anyone can just download and use it to teach people in your local neighborhoods or communities. So yeah.
Awesome. And sorry, what was it called?
I have to
where
like
can we
post it
find
up.
it?
It's like on like Kumo. I'll like share out whoever wants to connect after this and give you the link. So
Cool. Yeah, thank you so much for that. Rachel, did you have anything you wanted to add there?
Well, yeah, I guess it's just so interesting to think about, like, everyone who's talking right now is designing for different audience members, but we're all thinking about education on different levels. So I get stuck on this idea that I hear people, say like, well, this has to be usable. Like, this stuff is not approachable yet. And for me, it's like, that's okay. That's where we are right now. But like, if we don't spend time like really educating ourselves, like the people who are making it, and documenting our process and documenting our learnings, then like we're not going to get to that like endpoint that everyone's visualizing, where like everything is really easy for anyone to use. Like Germany was saying about like creating these visual maps, creating these resources for people from different learning levels to onboard into the space. I think that's just really important.
I really like that, and I think this is something that we forget a lot, that like we are also users and participants in this, like all of these things. We're sort of the first participants. We are hopefully building in the way that we hope other people will continue to build. And so to kind of build for ourselves, I think, is not selfish, it's practice. It's like, that's the first iteration, and we learn what that learning process is like by having to muddle through it as we go. So yeah, I think to sort of just, as Rachel was saying, like, document those processes and really pay attention to what it's like for us to learn, and for us to find that inspiration is really important and like really valuable. And we have a new friend.
Yeah, super grateful to be here in the presence of everyone. My name's Sean. I'm working on a community-owned and operated proactive healthcare system. So it's a DAO, and this seemed super aligned because in healthcare, we think a lot about how we can co-create health experiences for people, especially people combating stuff like chronic diseases, have to have some sort of lifestyle change. And it's quite interesting, the parallels between Web3, where we have to basically design for a participatory experience, because if the people involved in the experience are not playing an active part in designing what they want to do, and in a sense, autonomy, in healthcare, that helps people stick to whatever they're committing to do. And in Web3, I think what we want to design and what we want is to let people come into our product or our community, and then figure out how they intentionally, with their own values, missions, fit in the community. And we spend a lot of time like figuring out how that looks like for a healthcare DAO. And I'm curious to hear what your guys' thoughts are on that kind of intentionality in community onboarding.
Do you want? I'll just quickly say, I think there's definitely, thank you, yeah, there's a huge challenge with anything to do with community, which is, what is the boundary of community? Like, what is the community? What is the goal of the community? What's the purpose? Why are people there? What is their like kind of, how did it start? What were the principles behind that? I think one of the challenges is always I think actually it's easier in some ways with a defined mission, like you're talking about, to rally people around something that, in this case, if it's a group of people that all have sort of like some amount of like chronic illness, like I think there's a shared sort of kernel of similarity and like a feeling of kind of congeniality between people by definition. Whereas, with something like crypto, I think, like maybe just not to go too off track, we mean many different things by it. Like lots of people in this room probably mean different things by it. And so figuring out like what those like kernels are, what those like core like principles are, like Germany said, I think is like really important as we think about like, not necessarily even like, I think boundaries may be the wrong word, but like what is the sort of like inclusion criteria in the community? And that's important because you need to make sure that if someone is participating, that they're doing, to your point, like they're taking the responsibility, doing the relevant work. So it's a little bit of a tangent, like it's not directly answering the question, but like I think that's a really important like just discovery process for any new community.
Yeah, yeah. This is a conversation, right? So I don't think you missed any question. No, thank you, Sean. Where's Sean? Sean left. No.
You're back there.
No, it gave me. It added a dot for me in like the framework of going from like user to participation, which is ownership. That's in between, and getting this sense of ownership. And I don't know too much about like the healthcare industry and how that's like transitioning into letter-based applications. Not sure what else to call it.
Call it whatever we want. It's
yeah.
fine.
Yeah, healthcare seems like an interesting case because that's where ownership ties to like this very intrinsic, you need ownership over your own body. Like it makes it very tangible. And if we want to expand ownership to communities, you first need that sense of ownership over the community, that you are impacted by decisions that are made the same as you're impacted by decisions that doctors would make over your own healthcare. So it just added that question, in my mind at least, on how do you first create ownership over the community before you ask or try and incentivize people to participate in it. Starting to draw a framework here. Yeah.
Awesome.
I just want to add a quick point that with designing ZK stuff, I feel strongly that I don't want people to feel polarized from being participants in creating the like products that use zero knowledge. Like it sounds sciencey or mathy, and I think we have this like obligation to make it approachable so that people know what they want. Why do we have to only follow former models of saying like we'll figure out what they need and design for them, when we could try something different where people can like co-create the experiences that they want?
Hi, my name is Manu, and I'm one of the founders of Doing Good, also founding member of API 3 DAO and a couple of other DAOs that I participate. I really like the conversation. However, I have a couple of things that is bothering me quite a lot.
Let's hear it.
Yeah, most of us are here building tools, as you said, for ourselves. But most of the people that are building the space are actually from very privileged countries. And yeah, basically those tools that are being built are not being built for the people that actually need it. And that bothers me a lot. Also, another thing that bothers me is that we are using a lot of terms, or we're creating these new terms like, let's say, stable coins, which are not really stable. We know that they're not stable. Or we call them soul-bound tokens. What the fuck is that, you know? And yeah, it's just very confusing for people that are outside of the space. It's not really inclusive when we are creating these new terms that cannot even be translated. When we talk about staking, I don't even know how to say that in Spanish. I need to explain it all the time to people. So I think that we are getting into a trap when we are creating all of these new terms and so on. We're trying to onboard people, and we're trying to onboard masses, as we say, but in reality, we're just onboarding other geeks. And yeah, to me, it's really bad. And we say that also we're creating a more decentralized space, more inclusive space, when in reality it's just a bunch of white people just doing that, just talking between them. So, you know, are we really doing what we're saying that we're doing? Are we really using the language and the tools that we have for inviting new people to join us? Or are we just, you know, trying to be cool?
Thank you okay. Really, thank you for like bringing up some really challenging and like really important points. And there were a couple of different things there that, I don't know, maybe we can get to all of them. But maybe let's start with the first one, which was, yeah, that we tend to be sort of insular, like we're sort of designing for the people that we see. And this community is, you know, we would like to think that it's global, but it's really difficult to figure out how to reach people. And we end up designing in ways that like make sense in my brain, but in a place that I've never been, in a culture that I've never experienced, in a language that I don't speak. It can be really difficult to predict, which also comes back to kind of what Rachel was saying, that there's a difference between trying to figure out what people want and then make it, and then like this sort of hopefully interactive process of inviting people in to like figure out what it is they need and help them help themselves build it. And there's this problem of like literally knowing how to find those people is really challenging. Like I don't necessarily know where to look, and to try to come with like prescriptive solutions, or like, you know, go out with my binoculars looking for the person in the third world country that I'm supposed to design for. It's really difficult to kind of know where to start with that sometimes. So I did want to ask like panelists and our new friend, kind of how do you think about, like we tend to, when we do, you know, user research or try to like measure the impact of the things that we make, we rely on kind of simplified, like easy things like analytics and like metrics that they're satisfying because you can count a number and think it's the right number and check a box, but they're actually limiting and kind of useless and opaque and don't really particularly connect to reality. And they end up also like leading you to design for the people that are already there. And certainly not like leading you into new areas or like inviting new people in. So wondering how you think about like how to measure success, or how to like get richer, better feedback, and have that be a more interactive process, and just sort of open the borders of it so that more people are able to participate, and more people are able to kind of create.
Hey guys, I'm Raghav. I'm building a community-led fundraising platform, albeit not quadratic. But just to, like, on what you said, I often think, and it's something I was thinking earlier, like for quadratic funding, right? Mathematically speaking, it's not the most straightforward thing. But, you know, like, let's say in the third world today, like in India, I'm from India, a lot of people don't have bank accounts, right? The goal is not to teach them how a bank works. The goal is perhaps first, let's get them bank account. Let's tell them, okay, this is why it's good for you. You don't need to know the economics of it yet. So I think a similar thing can happen here, where like our first goal is, as long as we can get the service that we need, let's get that to them. And over time, as that leads to whatever prosperity we hope for, then we can reach a point where we can have education around those things. If we just keep waiting for education and just for that we don't provide them what we can provide them today, I think that would be a misstep. Also just to, yeah, so go ahead.
Yeah, no, I think that's, like, my biggest, you know, I think learning from the last few years is that, like, you need politics to be, like, what's the word? So, like, prefigurative. Like, they need to, like, basically, like, you need to, like, take action towards the thing that you want to see in the world in some way. And I think crypto does that by definition. Like, we just build things. We, like, they sometimes don't work, you know, at all. Sometimes they work kind of okay, but they're kind of janky. And then hopefully sometimes they work really well and, like, are sustainable for, like, the long term. I think the biggest challenge I see, aside from dropping my phone apparently, is that we really don't have a, we're talking here about like participants, but we don't have a really good way to do that globally, as Althea mentioned. And I think that's still a missing point here. We're still doing better than like, Meta or something like that, where like you're literally just in a room in like Silicon Valley, like designing for a community that's global, like as if that's going to just magically work for everyone. I think there's more like local first principles and thinking here. But we still don't have that really broad global participation. I think it's one of the reasons that like, we sort of like as a community need to be having more conferences in places like Bogotá to like participate more with local communities. We probably are not doing that enough, but I'm hopeful that we're like getting in the right direction there.
Quick response to that, because honestly, I do think there's a lot that we can learn from traditional companies in this area of how do you design for local communities. Even being at a conference, I'm not sure how many people actually go outside of the venue to explore. Personally, big proponent of field research. Trip to Venezuela was most insightful in my last 5 years in crypto. Just to kind of make the point, I think there's a lot that we can learn from traditional companies in how do we study and work with local communities. There is a reason that some of these companies are so successful to the extent that we believe it's detrimental, because there are some things that they've managed to do really well, and understanding needs on the ground in local communities is definitely one of those things. Dream job. Maybe to riff on that a little bit, one of the challenges I found in trying to get more on the ground experiences and insights and connecting to communities to work and design alongside has been that it requires a certain degree of openness in what we're building. Because you go on, like you land, you put your feet on the ground, and you're like, oh my God, this is never going to work. But you've already spent 6 months like developing for something that's then not going to work. And so that open mindset plus the funding to that like uncertainty of what the outcome will be is, I think, something that as a community we can all contribute to. How? Not sure. Maybe there's someone here who has a better answer.
The question that I actually came to ask, so we speak about obviously ownership and self-sovereignty and stuff, and that obviously comes at a cost of like, there's a lot more finality of action in the blockchain, right? Once you sign something, you sign it. So do you think the future of these apps, or anything that we build in this new internet, is more about communicating to people that your mistakes are your mistakes and that's okay? Or is it more about making sure systems are sort of, they have the scope for mistakes, which can be from simple steps like an are you sure pop-up box all the way to maybe some kind of like magical reversible transactions on chain? I don't know.
Does anyone have a response to that? I mean, it's a great question, right? And it's sort of the opposite of, or it could be the opposite of the thing that I said at the very beginning about sort of putting like bumpers on everything so that you just can't screw up even if you wanted to. And there is this really interesting dynamic between trying to give people choices and then not sort of putting people in danger by just like throwing them into a snake pit without even telling them what a snake is first. Like that you have to give people the tools to not make those horrific mistakes, but also not do that in a way that limits them from making like all of the choices that you would want them to have. I know you. Hello.
I didn't know when the session was ending, so I was going to chill at the end, but I just wanted to thank you guys for the conversation. But I think in that regard, as far as like how do we create ecosystems where people are more able to make mistakes, et cetera, I think a lot of it has to do with progressive disclosure, people getting used to some of this technology as they get aware of what's really happening on the front end, on the back end, and on the actual protocol level. So just kind of walking them through that focus of like, okay, this is some sort of hand-holded, guided functionalities of how you actually get into this ecosystem. I think there's a lot of education, communication around language, all those things that you guys have already kind of highlighted that will lead us to that. But it is a long journey. Like, people need to come and play with some of this stuff, and we don't have the opportunity or test nets or all these resources where people can experiment with some of this stuff and not have that risk factor associated with it. So I think gaming and all these other mechanisms of like pull apps, et cetera, provide you that opportunity to interface with this technology and then learn a little bit more. But we need more use cases. We need more creative thinking around some of this functionality for people to actually start using it.
Thank you for that. We do kind of have to wrap up now, but yeah, I want to thank all of you and also everybody who was brave enough to come up here and join us. You guys brought a lot of really good points and good questions. So yeah, thank you for that. And I wanted to end on another Zach Mandeville quote, if I could just, there we go. So, and I think Akil, you actually wrapped this up rather nicely for me. To build whatever you're building for everyone, we must expect and empower the best from anyone. So thank you, everybody. Let's go out and do that.
Everyone kind of leaves the room. We have this whole room tomorrow as a UX workshop. So if you guys are excited in kind of continuing these conversations, we're going to have some great speakers from Optimism, Status, all the client teams to kind of really discuss adoption and the issues that we kind of face. So Alex Van de Sand, like all the design thinking individuals are kind of coming tomorrow, giving lightning talks. And then after lunch, we'll have workshops going on all day long. Thank you.
facto, Ether will become something very special. Money, internet, it's like money for the internet money. There's this deep friendship between Ether and Ethereum that I'm going to try and tell you about today. But before we get there, I want to give you a mental model around the temperature of money, or some people call it the velocity of money. When I invite you to think of money as water, which can be in multiple states. It can be liquid, it can be solid, if it's cooled down, and it can be in this gas state if it has extremely high velocity. And this is interesting because at layer 1, we have mechanisms that explore these extreme temperatures. So you can take ether, water, and at layer 1, you can freeze it, you can steam it, and in the process of steaming, reducing the velocity of that ether in this kind of put in a black box. And something similar happens with burn. Burn is all about
Test, test. Does this thing work? All right. Bienvenidos, buenos tardes a todos. Thanks for coming. All right, so I'm going to talk about why and how to run a node, and no, you don't need any ETH. So first I want to start off, if everyone could help, please raise your hand if you've ever wanted to run a node. Okay, pretty good. And then keep them up if you know how to run a full node. Okay, and then keep them up if you are currently running a node. Okay. About like maybe 6, 7 here. So. Okay, first we'll start off like, what is a node? Well, a node is software that downloads a copy of the blockchain, all the history, all the state, all the accounts, transactions, and it keeps that up to date as blocks and transactions take place, and it also helps others run a node. So when you start up a node, you ask all the others for the history of the blockchain. And this is really important because the foundation of Ethereum is really like a network of decentralized nodes, and without those, why are we here? I guess we could just build a centralized solution and have something quicker, and yeah. So we'll go over four of like the main reasons why I tell people like, hey, you should run a node. So again, supporting the network. It's each additional node that joins is additional capacity to the network. It makes the network more robust, more secure. Again, easier for a new node to start up, has more nodes to get the history from. Also, it's really important that we have people running nodes that are from different clients, meaning different node teams, different client teams. Right now, it's kind of a big problem. If you've heard of Geth or Go Ethereum, right now about 80% of nodes are Geth, and if there were to be a bug in Geth, that would cause quite a problem for the network. So we'd much like to have users run like Besu or Nethermind. Yeah, this makes Ethereum much more resistant. And I'm sure it helps the Geth developers sleep at night as well. Okay, another big reason is to avoid lock-in. This has to do with like the problems of kind of the Web 2 that we talk about a lot, centralization. Having a decentralized network of nodes both helps Ethereum from being kind of like locked into maybe a small group of developers or teams, and it also it enables like additional systems to be built on top of Ethereum and have these properties. So if you can build a system on top of Ethereum, and if designed in the right way, a property can only really be changed if all the users and participants want that property to be changed. When we talk about forkability, this is what we mean. One other cool thing is, kind of relates to the last slide, is you get to vote on changes to Ethereum if you run a node. So let's say Vitalik and some of his friends create an update to Geth and say, we want 1 ETH every block, and we're going to send it to devs.eth, and they all update their nodes. You can choose to support them by taking that update, essentially voting with their change, or you can decide not to, and you can not take that update and just run the current version that you're running. So if a lot of users don't update their nodes, if the like centralized exchanges and your wallet providers, like they don't update their nodes, then this update doesn't take place. But let's say like all of those actors do update, then it's most likely that this update goes through, and if you don't have a node, then you don't really have a choice. You don't have a vote. You don't have a voice. Okay, and this is a picture from one of Vitalik's blogs. Again, talking about, if there were to be some sort of attack on the Ethereum through this, like a new update comes in and does something bad, it takes funds, that would be considered like the attack we're talking about here. And all the users, all the node operators that decide to take that contentious update, they may end up on one fork, and all the other users and node operators might end up on another fork. And he talks about these are kind of like the 3 scenarios that would happen in this case. And so we prefer the options like toward the left. So we would want something like this to fail, obviously. And however, even if it just ends up in chaos, meaning like, maybe half the exchanges show one state of the Ethereum and maybe half the exchanges and wallets show another state of Ethereum, that's still like much better than the attackers becoming victorious. It kind of makes the attack like extremely expensive, even if the attack doesn't, isn't victorious, or doesn't fail, I should say. It's still extremely costly. All right, and then an important question everyone wants to know is, can I run a full node? A lot of people I talk to, they want to run a node, but they don't know if they can. So here are some of the requirements. Your computer needs 8 to 16 gigabytes of memory, 2 terabytes of fast SSD storage. This is kind of the biggest problem for people is this fast SSD storage. Even some of like what you might think is like a really fast external storage drive, like it's super highly rated for like moving videos and in photos. It might not be fast enough for syncing a node. Let's see. Right now, only 1 terabyte is used by nodes to store the state. This is growing about 10 gigabytes per week. Some nodes have options to use less. They're kind of they're just beyond like the experimental phase. They're solid options, but they have their limitations and don't quite maybe meet all of the use cases that people need. And then the CPU is not usually a bottleneck, so most laptops that are within like 5 years old should do fine. One second. Internet can be a little bit of an issue, so you need about 10 megabits upload, download, and it needs to be lower latency connection. The data cap can be a problem in the US. A lot of internet providers have a 1 terabyte per month cap. I've talked to some people here in South America, and they don't seem to have that problem, or at least they're not aware of it. And then definitely can't really run it on like a slow cellular or Wi-Fi connection. Okay, I'm going to quickly talk about like the SSD types. Kind of the number that you want to know is this like 10K input-output operations per second. So yeah, nodes, they are essentially writing like tons of like small files back and forth, reading and writing to the SSD. And this is kind of like not really a common rating that SSD companies tell consumers. Because it's not quite applicable to what most consumers are doing with their SSD. Most consumers are just, like moving a large video file, storing photos. Okay, internal SSDs, M2, NVMe, that's like very popular now. Within the like $200 range you can get for this. And then, you probably just want to stick with that. The other options, if you have them like lying around, those might work. That's not going to work. External SSDs, the reason why I want to emphasize this is because I think there's a lot of people out there with laptops and don't have like a dedicated desktop or a computer just for running a full node. And so I want people to be able to run a full node on their laptop, maybe like while they're not using it, or if they have an extra one. So check to see if your laptop has like one of these connections, either Thunderbolt 4.3 or USB 3.2. Okay, now this is the interesting part because these are some of the upgrades or potential upgrades coming to Ethereum in the near future here. So when you hear proto-dank sharding, that's EIP 4488. And actually in the worst case scenario, this would add 2.5 terabytes per year for node operators, which is just not really an option for at-home node operators. So in one of Vitalik's write-ups, he said that if proto-dank sharding goes through, we also need EIP all the fours. And what that does is eliminate historical data requirement from the nodes, which would save like 500 gigabytes, and kind of like cut down the requirement on nodes having to store like all of this data. State expiry is one that is contentious again. What it does is essentially eliminates the requirement for nodes to like keep on to store certain transactions. Let's say like before a year or so, and unless that state is updated. So I have a feeling this probably won't go through. So don't count on that. Stateless Ethereum is a really cool change. No storage would be required for the node, so it would pretty much eliminate that 2 terabyte SSD requirement. It would still be good for like some nodes, some users to have that history, but it wouldn't be a requirement. So you could run a node and still validate all the blocks and transactions and really participate in all those benefits I mentioned earlier without the storage. But again, this requires like Verkle trees and is a pretty difficult upgrade, so don't quite count on that. Ethereum Portal Network is a really cool, actually like separate network built on top of Ethereum or to the side of Ethereum. It leverages like BitTorrent architecture and would kind of enable everyone to run a light node actually like embedded in their wallet. So like most of our wallets right now, they talk to like Infura or Alchemy to get transaction and send a transaction. This would essentially eliminate that point of centralization, and your light node would actually talk to other light nodes, which would talk to full nodes whenever you send a transaction. So really promising, but quite a bit of work there. I think they want to have, just for a time reference, I think they want to have something out by like the end of next year. All right, the fun part, how to run a node. Okay, could I get a quick hands, like if you've heard of dApp node or Ethereum on ARM, I guess? Maybe a quarter of the people in here. Okay, so yeah, they're great. The only difficulty with running a node with dApp node is you pretty much need a separate computer. It installs an entire new operating system, which is also can be a hurdle for people that haven't installed a new operating system on a computer. But they're great. They've been around for a while, and I would say like are pretty battle tested. Option 2 is the command line, which is for super technical users, technical users who are familiar with the command line and don't mind monitoring their node from a flurry of like command logs. And then this is actually from Ethereum.org's website. And I actually photoshopped nice node here, or not photoshopped, but like edited the HTML. So this was kind of like the vision for nice node was like, hey, I think we need a third option, one that is for like the non-technical user. There's tons of people passionate in the Ethereum community who want to run a full node, but don't want to hit the command line, don't want to buy another computer. Technically, it's possible to just download an app on your laptop and run a full node. So why don't we have it? So I'm hoping someday when this gets to a more stable version that they'll include me on ethereum.org, but we got to prove it until then. So I'm going to talk about a nice node, which I am working on. And so this is what the current version looks like. This is our alpha release, version 0. And you can see this is just like an app running on, I think this is Windows. And you've got both your execution consensus clients here. Super simple, stop, start, remove. You can kind of see like what is it doing here at the top. Like, okay, awesome, I know how much storage it's taking up. I can see like what's the latest block it's at. How many peers is my node connected to? And then kind of in line with this idea that like I want everyone to be able to run a node, I also want everyone to be able to like, no matter what language you speak, we'll have a translation for that language. And all of these languages were translated by contributors, just people with a good heart who came out and said, yeah, I'll be glad to translate like whatever we can and into another language. So Nice Node essentially supports translations. We just need people who speak all of the other languages to help out. Okay, hopefully this loads. So this is a design for our next version, much like cleaner UI. At first, only the Ethereum node will be available, but I'm designing it to be general so that you can run other nodes. I'll talk more on that. So you pick Ethereum node, then you pick which client you want to run. We conveniently show you which clients are minority clients. You can select a few options, select where you want to store the data at. Again, these are all things you'd have to do from the command line. And then this will actually take the screen. I think I'll show it to you later. And then we have to install some dependencies here. And we just hit start. And our node is syncing and running. And we have this beautiful UI to see our node. And everything's great. Okay, so this is kind of a key piece of information for a lot of people is like, can my computer run this node? No, you don't have to go to like guides or websites to read through things. It's in the app. Yeah, we can see like, hey, is your CPU fast enough? How much memory do you have? Do you have an SSD? Does it have enough space? All of that stuff we can do, so we do it for you. And this may differ by client, and in the future, this may differ by node type, meaning the hardware requirements may differ. Some nodes maybe use a smaller amount of RAM, others you might use more storage. So we'll give you that green check mark if you're good to go, based on the node type. Okay, a few more screenshots here. Yeah, just wanted to leave these up here so you could see them without the video. This is really like important to me, being able to change the settings on your node through the UI. Again, to do this now, you have to go to the docs of the client team, try to find like the right flag with like the dash, whatever, and hopefully you format it rightly. I don't know if it needs quotes, does it need a comma in between or a space? You don't have to do that. With Nice Node, it's here. Yes. Okay, Nice Node is cross-platform, meaning it works with Windows, Mac, Linux. This is a screenshot of Windows. Ooh, looks like it's not going to play. Yeah, again, I designed Nice Node to be as general as possible, meaning as L2s start to decentralize and provide nodes, maybe sequencers, Nice Node, there should be very minimal changes to support those new node types. And actually, like users could open a pull request to Nice Node's GitHub, and those new nodes would be in Nice Node in the next release. For the technical folks, Nice Node is sort of a UI wrapper around like Docker containers. So any node type that has a Docker image will be like really quick, really easy to add to Nice Node. Yeah, eventually we want to add things like staking as well. So this is a UI screenshot of like what it would look like if you were to add validators. And then you can just kind of see like, yeah, Arbitrum does have a node out. I don't know if I don't know how involved it is in their layer 2 yet. I think it might kind of just be like a replica node and not quite the same priority as they're kind of like their own. And then the and beyond here is, okay, if our like Web3 dreams take off and Web3 infrastructure is really where we go to, and the users we control the platform, we control the data, then we're going to want users to run some of these Web3 infrastructure nodes. So just for example, like this video is being live streamed over LivePeer, and they have a network of video transcoders. And then, so they transcode this video, and any one of us, if you have a graphics card, can join that LivePeer network, and we can use our graphics card to transcode that video. So this is just one example of, like a Web3 infrastructure that users can participate in and have more of a say in, and it's something that I think we can support, and so we show it here. Okay, and this, I think this might be the same video. Okay, and that looks like the same screenshot. Maybe I hit it back last time. Okay, a little bit for our roadmap. So we're really close to releasing the redesigned UI UX and the super simple onboarding, walking you through like the hardware requirements, other things like that. I want to get more translations. We're going to work on that hard, push on that hard, hopefully by the end of October here. After that, there's some internal changes that we need to make to support more node types for the future. For the technical folks, that's Docker Compose. That means kind of like there are nodes that contain multiple services, and so that will help those node types. And then additional features. I think I can show you these after. So yeah, node notifications. If your node has an error log, like we'll show you a notification. That error log won't get like lost in your terminal, and you'll never know about it. And then you can like search logs. Maybe if your internet goes down, we'll notify you that your internet was down for a brief time. And then after that, by February of next year, we'd like to add layer 2 nodes and more Web3 infrastructure nodes. All right, so it is critical to Ethereum's mission of decentralization, censorship resistance, and resiliency for users to be able to run nodes. And this is extremely important to me because like all of the other good things we talk about here, will only last, will only exist, will only really be possible if we have a truly like user-led culture of like running nodes, and if the core devs continue to make it possible for users to run nodes. So for like, if we want this dream of like open global infrastructure, super low transaction fees for the world, like open financial system, Ethereum for everyone, we need users to continue to run nodes. And Nice Node's mission is to simplify node running. And thank you. Gracias a todos. So I want to open it for questions, and let's see. I just want to move it to this slide. Real quick, if you want to help, we need everybody. Join our Discord, reach out on Twitter. There's a website here you can translate on, which I'll get notified as soon as someone translates. So that's cool too. And question time.
Thank you for your time, first of all, in the presentation. I've got this core philosophical question that I've had for a long time, which is, I feel, and maybe this is a lack of understanding, that full non-validating nodes are overvalued, because in the end, the state is really managed by full validating nodes. So why does it really matter that there are more and more non-validating nodes in the network? Why does it matter so much? And isn't it easy for some big entity or to just deploy thousands of full non-validating nodes, which don't need stake ETH, to overpower, to kind of cyber attack the non-validating network?
Okay, so tell me if I understood your question right. So your question is, what's the importance of non-staking, non-validator nodes like without ETH? What's their importance?
Why is it stressed so much? Let's keep the requirements low so that anybody could run one. When I don't really see the
Yeah. So it's a great question, and what it does is the non-ETH, non-staking nodes actually keep the validators. It keeps the ETH staked nodes honest. So yeah, if let's say some centralized staking service gets 75% of the validators, and they want to push through a block that sends all the ETH to them, the non-ETH nodes will say, hey, that's a funky block. That doesn't apply. That doesn't follow the rules of Ethereum. You're trying to steal someone's money. Reject that block. I'm not gonna take that transaction and share it with anyone else. I'm gonna drop it and say that's invalid. So it essentially keeps them honest.
That makes a lot of sense, but is it still easy to overpower, since you don't need an ETH requirement, like the monetary premium on cyber attacking the network is really low. Like if right now you have 10,000 non-validator nodes, to push another 10,000 into the network is very easy economically. So how strong really is the defense mechanism going on?
Yeah, that's a good question. So like if someone were to on some cloud service just spin up like a ton of non-ETH nodes, I think it would probably be more costly than it would be. I think it still would be pretty costly, and I think even if let's say they have triple, quadruple the number of like honest, nice nodes, then I think the attack would still fail, or it may in this case default to chaos. So I think I'm probably not the best person to speak on terms of like, hey, we need X number of honest nodes, but I think a sufficiently. So right now I think it's at about like 8,000, and yeah, I don't know what that right number is. I was reading one of Vitalik's blog, and I think he even said, I'm not sure how many it is. It's probably more than like a few hundred, but I don't. Yeah.
It's not that many.
Yeah, I'm not the best person. I hope the core devs thought about that. Okay.
You talked about adding validators to nice node.
Yeah.
And you also talked about making this very simple for people to run on their Windows computer that don't have very much tech experience. It's, my father could run it, my mother could run it in their home, and they don't do anything with tech. So if they get all this set up and I show them what Ethereum is and they put all this money into it, and now they have this money running on this Windows computer there, and it has no battery backup, it has no, they just shut it down because they don't want it running all night. Well, obviously now they're getting slashed, and so you have a lot of these people who don't know about these things, how to set up the hardware. Aren't you kind of concerned about that? Or maybe they think, I want to set up two. They use the same contract addresses, they set up two, and boom, 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 they start getting slashed because you can't have two. Have you thought of, before people get into this,
Yeah, that's a good question. Is like if we do make it easy to use, like we need to also make it very clear like what they need to do, and then probably also make it very easy for them to like stop it or withdraw or notify them. So yeah, if we're going to make it easy for people to onboard, we also need it. That's a great point. We need to make it easy for them to kind of get off or help them get off.
you mentioned, hopefully it comes on Ethereum's website later, like you edit the HTML and put it there. I would think that would be one of the vendors look and say, well, how responsible are they? It's like nice node's responsibility to do that before like Ethereum would say, oh hey, this could be used for people's homes because they were responsible.
Yeah, I think the quick answer is I would, in the app, we're going to just make it like super obvious, like lots of warnings, like, hey, you need to have your internet on, you need to have this computer up. And yeah, hopefully our solution is a lot better than the alternatives. Like hopefully we're way better at notifying people when their node does go down, things like that. Yep. Yeah, no incentives right now. For a non-ETH, non-validator node, yeah. So, and that's a great point. Like, if you're someone who like the SSD is like a big commitment for you or purchase, like maybe running a full node, I don't want to discourage you, but maybe it's not the best use of like your money or resources. Like there is no like direct incentive at the moment, other than obviously like making sure Ethereum works and stays up. So it is, yeah, that's a great point. Yep. Yeah, I mean, certainly we want to make it as user-friendly as possible, and one thing we have thought about is like letting users opt in to automatic updates for their nodes. So wherever possible, they don't need to do anything. And I think that that's probably a big part of running your node is just doing those updates and then having some sort of like alerting. In terms of like if some other problem were to happen, like we would try to diagnose it as best we can, but I suppose that like for an issue we can't diagnose. I don't have an answer, but it's something I'll definitely keep in mind. Okay. Yeah. The other thing I do want to have is like if I'll like show the command that nice node used to start the node, so you can just copy and paste that command and like leave the app if you want, and then you can just go to the command line and that's something I want to do too. Right here.
First of all, congratulations. I really like the new UI that will come.
Thank you so much.
I have a question because regarding all these challenges, it's based on like how to get people that's non-technical people into this ecosystem, right? So I really like to see this kind of UI that's guiding to you and trying to get in this with basically no effort, right? To say like how to build a one-click application. My question is, when your team like build this, it's based on like there is a research behind like for what kind of age or what is the this kind of people that can afford like this is easy to use, because even if this is easy to use for us, maybe that kind of steps and select option, all the stuff will be tough for an elder or even a young people. Like there is a research behind that, like this is like accurate for this age people or non-technical people, whatever.
Okay. So just to repeat for the stream, it sounds like there's concerns that we need to make sure that if it is super easy to get in to get started, that we make either some guide rails or some just make it the user aware that what they're getting into. And so yeah, I mean, what I'd have to say to those concerns is I think we could do something where instead of letting like the user, this is just something I thought of now, like click like yes, 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 and then they're good to go, like deposit. Maybe having some kind of like speed bump kind of thing where like they have to either like demonstrate some technical knowledge of like what they're getting into, just sort of like maybe basic quiz or something like that. But other than that, I mean, yeah, did I address your concerns? Was there anything else or? No, okay. Yeah, I think maybe some sort of speed bump just so they can't click through like super fast and get themselves into something they didn't know. And now this program is taking up all their SSD space in the background. Yeah, absolutely. Right there in the white sweater. Yeah, I think you were first, blue shirt. So if you don't have any ETH and you're not staking, no slashing. If you're staking with nice node and your node were to go down, it would be slashed just like any other node. Yep. That's a great question. His question was, could this be a web app? And I don't think so as of now. I think there are limitations on the browser, which you can't basically run a command. A web page can't just like run an arbitrary command on your computer, but like an installed application can. Now the front end part of Nice Node, we could separate that out and put that as a web page. It's actually like mostly the front end is basically a web page. It's basically running in Chromium. There's the underlying architecture for Nice Node is called Electron, and it basically downloads Chromium, and so it's like its own little web browser there with extra permissions to interface with the operating system. Yep. Any other questions? Okay, here again. Right now, no plans. I want to stay open source as long as possible. We've been supported by first ETH Staker in a CLR fund, and then Gitcoin, 2 rounds of Gitcoin. And then we recently got a grant from City DAO, which funded the improved onboarding experience that I showed you all today. And then hopefully we'll get more grants and stay open source. Yep. I've seen people ask that. I think if there could be in the future, and I think absolutely. I think there are lots of groups or foundations, maybe like ETH Staker or the Ethereum Foundation, who would provide some incentive. I think the limitation here is probably like you need to prove that the person running the node is a human, or that proof of humanity Sybil resistance problem. So I haven't thought through the whole consequences of tying your proof of humanity ID to your node, but I think with that, people would give out incentives. Other than that, I don't know. I don't know how they would do it without Sybil resistance. Yeah. If you're not staking or not validating, there are no incentives, no monetary rewards. Yeah. I mean, that's something I've thought about. I haven't quite worked on now, but the the app can know whether you're on battery, whether you're on power, whether you're on Wi-Fi, Ethernet. Right now, we don't have any internet speed check, but that's something we could definitely add. So I do, in the long term, I do want to make it so that you can close your laptop lid, the node stops peacefully. Wherever you go next, you open your laptop, maybe just plug it in, you eat dinner, and it's syncing while you're, and then while also potentially we could have a setting while I'm working, don't use resources, just run in the background, or just pause while I'm working, maybe from my typical work hours. Yeah. Okay, all right. Anyone else? Okay, I think that's it. I posted the slides on the Nice Node Twitter. There's tons of links in here. So you can check out the slides there. Awesome. Thanks, everyone. Thank you. And gracias los organizadores y al equipo y a todos. Okay, that's it. Thanks.
Broader ecosystem. We're already starting some discussions with L2s about how they can directly fund this incentive.
Gracias.
Yes. Let me just put these back to them, and then I'd love to talk to everyone else. Oh, sorry.
Got this for you. Thank you so much.
There's a ton of important to have also a variety of approaches, different curators, different mechanisms, so that we can make sure that the incentives to contributing back to the Ethereum protocol in the context of amazing application layer projects is over time. Thank you, and have a good
day. No, it's not mine. Sorry, my Spanish is late. Almost. Okay. Yeah.
How does the protocol guild
So
feel about those
one
kind of outcomes?
one thing maybe
What sort of
is that
downsides do you see?
I am already on the speaker. So one thing maybe is that
obviously we have like 9 teams
I will share my connection for internet, but if something goes wrong, maybe you could also share yours so that like
if they start doing some weird stuff, there's other options for people to choose different clients, and obviously if we have many more clients, their influence, they won't really have an influence. But nevertheless, they have certain interests. They might they're probably going to launch a token. Tokenomics, how do they pump their token? These kind of questions.
Yeah, you definitely picked the hardest question, given they announced yesterday. So yeah, this is really interesting and it touches a lot of different areas about protocol governance, incentivization, funding the core protocol work. And like you said, I know them all personally, so I do have a bias here, but I do expect that they will maintain their neutrality. Leaving or joining?
Leaving.
If they're leaving, so they can claim any assets from vesting at any point, but there are windows in the contract. So once they leave contributing core protocol work, they won't receive future vesting, but they can claim it at any time. It's permissionless like that. Does that answer yes? Yeah. Anybody else?
I have one.
Sure.
How do you think about deciding what should be funded, and how do you sort of, in a way, prevent or get ahead of not having favoritism kind of come into play?
Yeah. This is something that we've been trying to iterate on through the pilot, and one of the reasons we wanted to start really small. I mean, 10 million is may seem like a large number, but split between 120 different core contributors, it's not that massive. But we were very intentional about raising because the eligibility framework is going to be exactly right the first time. And so that's part of this pilot, is figuring out what sort of scope we want to take on. And I think what we've learned in the last 6 months since May is that it's probably better for a more narrow scope and as explicit as possible. We want to make sure that it's very clear that these are people that contribute value, because if you aren't explicit or don't maintain rigor in the eligibility process, again, the mechanism will lose its value and a lossy signal for people who are interested in contributing to something that's going to get their money into the right place. So make sure that we're iterating and starting small is how we've approached it.
And just out of curiosity, did you kind of compare this thing with the retroactive funding model, and sort of what was kind of the pros and cons list that you made in reaching kind of pick this model?
Sure. So retroactive funding is great in that we can also plug into that. However, these individual teams, they don't have to rely on their own liquidity. Because Protocol Guild is biased towards the individual, you can imagine a sort of a union that represents them, and makes it very, very straightforward for people interested in funding, like Optimus's retroactive funding program. They can just point it to a single address and scale it accordingly, however much they'd like to give back, rather than possibly missing some of the big crucial work over the past 2 years. They can rest assured that this is a mechanism that's going to be very, very tightly curated. But yeah, I'm super excited to plug into retroactive funding, continue to bring things like that as all possible, and I'm sure there will be even more mechanisms in the future that are a good fit for these types of things.
Awesome. Do you have any other last questions? Great. Well, please give Trent a big round of applause.
Thank you.
We'll take a 1 or 2 minute break before we get ready with the next talk. So you can stretch a little bit, and we'll be resuming in 2 minutes.
talk for the afternoon. And for this talk, I'd like to invite Alex to stage to talk about building blocks after the merge. So without further ado, please give a big round of applause for Alex Stokes. Okay, hello? Great.
Hey everyone, good afternoon. I'm Alex Stokes, a researcher at the Ethereum Foundation. And yeah, the title here says block building after the merge. There's like a subtitle which is moving forward. You'll see in a bit maybe another variant of this talk that looks at more into the technical side of things. And I hope today to kind of communicate like a sense of the landscape around this topic and like maybe it's like the obvious buzz phrase here. But yeah, so let's get into what that means. And hopefully by the end you'll have a sense of maybe how like the landscape and what some of the concerns might be moving forward. So I've kind of always said that putting currency in crypto, like cryptocurrency, is like this double-edged sword because
I think we can
yes,
start.
you know, there's like this like speculative aspect.
Okay. Hello. Can you hear me? Oh, perfect. Thank you. So, hello everyone. Welcome here in Bogota, and thank you for coming. I'm Attila, and I'm from the Swarm Foundation. And today I'm going to talk about the Swarm, where the project is at the moment, how you can run your light node, how you can run a full node, and talk a bit about future plans as well. So, I don't know how many of you are familiar with Swarm, but basically Swarm is decentralized data storage and distribution technology. So also I'm not sure how much of you are familiar with this original idea of Ethereum being the world CPU, but at that the Swarm origins coming from the same time, and then at that time there was this idea of this Holy Trinity, where Ethereum is the word CPU, Swarm would be the word's hard drive, and then Whisper would have been the messaging system. And like things turned out to be differently, but still the idea and the roots of Swarm is coming from that. So you can think of Swarm as being a huge hard drive based on peer-to-peer technology. And then when I'm talking about Swarm, people usually ask me, okay, so how is it different from IPFS? Like, this is the question that everyone is interested in. And then it's quite different, but since the goals of the projects are similar, then I think it's worth mentioning, like, what are there's some kind of core ideas that are built into Swarm and maybe differentiating with different or alternative decentralized storage systems. So one thing is that Swarm has a very strong focus on privacy preserving and being permissionless. So it means that you, in order to upload to the Swarm, to this world hard disk, you don't have to have a node. So that's different. From IPFS, you have to have your node. And I will talk about later, like a bit more the differences in like how the data is handled. But then again, going forward on this list, like Swarm being Ethereum native, which means that it uses a lot of primitives, like crypto primitives that are used in Ethereum, and also the smart contracts it uses are running on EVM, so it doesn't invent its own blockchain, and it does not try to create that problem because that is solved by others, and it's not the area of focus. It has robust defenses against blocking or changing access, so that this is kind of the thing that we call censorship resistance. So once data is uploaded to the network, as long as there is someone who wants to keep it on the network, then nobody else can take it down from the network. Or that's the idea, and then I will talk about later where we are with that. There is also a feature which is like auto-scaling. So because this is a distribution network as well, the data is you know, when the data is downloaded, then the copies are stored on nodes, and therefore it's available on more nodes, so that it has this property that like more people sharing the same kind of data sets, the more copies there are on the network, and that can help with like CDN type of functionalities. There is integrity protection with content addressing, but also there is mutable updates with signed chunks. So you can have both of these things together, and with that you can think of also like as a not only just storing like static data sets, but like have data structures that can be updated and can be used for application layers. And eventually it forgets data or content that is no longer relevant to preserve. So as I will explain, like you have to pay in order to get the data on the network. And if nobody is paying for the data, then it means that it's no longer relevant, so it will be deleted. So these are like, from this you may get an initial impression. And I will go to some details, but not in a very deep level, because that's not the focus of this workshop. It's going to be hands-on, so don't worry, I just give a small introduction so that everyone is on the same page. So basically, when you upload data to the Swarm, what happens is that Swarm takes the data, splits it into 4K chunks, and then assigns and then optionally, currently it's optional, encrypt the chunks, and then based on the chunk's content address, finds the nodes that should be storing it on the network, and that means that the data is spread on the network. So then you want to upload any data to the network, then when you have a node, then it will find the nearest nodes that matches the content address of the data chunk, and send it there. And then when you try to download the data, the same logic happens. So then basically you access any nodes, and then it will find the route on the network, and then get back the chunks from the nodes that has the address closest to the chunk's address. And so that's the basics of like the storing data on Swarm and the main concept. And also, there are different kind of nodes. So as Swarm evolved, we realized that one size does not fit all. And then at the beginning, we only had this full node functionality where like the nodes were storing data. It was also used for accessing the network, and like basically all the functionality were in the full nodes. But eventually we realized that most people won't necessarily need full node functionality. So we separated like into different ways how you can access the data on the Swarm network. There is a gateway that we provide as a free trial version, so to speak. There is an ultralight node which you can install on your laptop, and then it doesn't use too much resources, but then with that you cannot upload to the network, because in order to upload to the network you will have to pay for the data, for someone to store it for you, and that's something that you can do with a light node. And I will install this on my computer. Like, we will see like how the internet works. So far it was not always great, but let's I hope someone like sacrificed some goats to the demo gods today, so that we can have some luck with that. And yeah, so we basically realized that if you want to see like a Web 2 kind of view of like this different product packaging, then I can show you this, that basically there is a free trial on the gateway that you can access from the browser. You don't need to install anything. You can just go to this website. You can upload data, download data, but it's limited to certain size. And then also that as the nature of the gateways, the gateway operators must comply with the law and then remove some data, and then at that point, like censorship resistant cannot be maintained or guaranteed. If you want to access directly the network, then the recommended way to do that is by using either the Swarm desktop app, which is like easy to install, and you can install it on your laptop or desktop computers. And then we recommend this to most people that want to create data and store network, or just want to simply access the data on the network. And it comes into varieties like this ultralight node, which does not require you to do any kind of transactions on the blockchain, but that's limited, so then you can only access data but not upload. If you want to upload, you will have to buy the Swarm native token, which is called BZZ, and then with that you can buy capacity on the network so that you can store your data. And with the full node, it has the full functionality, but it also means that you need to run this on a most likely on a separate server, because like if you run the full node on your laptop machine, for example, it may use your network connection in times that you don't want to. It has to be run 24/7, because then that provides the availability for the data for others on the network. So if you close your laptop, then I will talk about later, like you wouldn't be able to participate in the earning part of this thing. So like how you can earn money by storing data for other people. And so yeah, like we realized that the full node is not a very good choice for most people running it on their laptops and stuff. So for that, we recommend the desktop app, and the full node we recommend people who are more seriously want to store data for other people. And then, so maybe to recap like this, like the light node considerations is lightweight, use only resources if you request them, on demand, so it doesn't have to be running 24/7, and you can start without a penny. So that means that you don't need to make any transactions to start using it, but later you can unlock it with more functionality. And the full node has different hardware requirements, so like currently we recommend that you can start running it on Raspberry Pi with like 4 GB RAM, 70 gigs of disk space. It has to be an SSD, so most likely if you want to use a Raspberry Pi, you have to connect your external SSD to that, because it's quite demanding on the disk, as a storage system should be. It's always on, so it's supposed to be run 24/7, and you have to do one transaction in order to participate in the being a full node. Basically, you have to deploy a checkbook contract so that you can participate in something that we call the bandwidth incentives. So let me just talk a bit about that. So basically, there are two kinds of incentives. There is bandwidth incentives, that is like incentives, like money that you can earn for sharing data on the network. And then there's storage incentives, that is like you can earn by storing data for other people. And so like everyone, maybe I don't have to explain here the importance of incentives here, but like maybe what's relevant here is that like these two things are separate, and currently only the bandwidth incentives are running on the mainnet. So currently you cannot really earn money by storing data for other people. This is something that we are working on currently, and this is on testnet, so we are planning to rolling it out like soon once the testing is done. And yeah, so maybe just to show you like the data economy in the network is that what we see is that what is interesting in Swarm is that consumers who are downloading data from the network are actually paying for downloading data. There is a way to use it without paying, but that means that your speed is limited, so that you don't. Basically, the nodes are prioritizing paying nodes who are paying for downloading content. And so the interesting thing here is that this enables a new kind of economy. So currently the internet has this problem that by storing data can be quite cheap. But the problem is that if you try to store a large amount of data and your project gets successful and people start downloading data from you, then suddenly your costs are not on the storage side, but actually on the bandwidth side. So if you're using Amazon or something like that, then you will have to pay a lot for the bandwidth. And that can be, for small project, that can be like prohibitively expensive. So like storing, like, I know, I had this example that storing like 40 gigabytes for a year is like few dollars maximum. But like if there are like 10,000 people downloading that from you, you can start paying like money in the $10,000 range, and then small projects may not be able to afford that. And by changing this kind of dynamics and making the downloaders pay can enable new kind of applications where even like small projects can afford to host big data sets. And also this enables hosting public data sets or common good data sets that we consider, like, for example, Wikipedia data or OpenStreetMaps data, or like it would be good to see like blockchain data. It doesn't really make sense to blockchain data be stored on all the nodes. It would make sense to have like one common good space where everyone could finance and maintain as a common goods. And there are many other use cases that this can enable. And what I see here is that this can create this kind of new kind of applications where business opportunities can rise, when data creators can create something that is stored on Swarm, and then that can be shared with consumers, and then here you can figure out, like, you upload data, you get back the reference, and then giving access to that data can be turned into business opportunities. So that is also something that we considered solved problem. And now I'm going to the more hands-on part of the workshop. So I will go to the terminal and do some stuff that people does usually in the terminal. And so the first thing I would like to talk about is that so the Swarm currently has an implementation called B, and you can download B from the website, and you can install it on your computer, and then you can configure it and start interacting with that. And so there is a dev mode for this. Like, I wanted to show this to you because that's quite easy to use, and it's quite handy when you are not sure if you want to be invested in this and you don't want to spend too much time on that. So basically, once you have the B binary installed on your machine, which is called B, then this dev mode can be just invoked with this B dev. It starts up, and then it's ready to serve requests. So you can access the B API on the port 1633. And it also has some other functionality in ports 1635. Like, it's currently that like data-related functionality can be accessed on the 33 port, and then administrative functions can be accessed on the 35. And maybe I can show you like the documentation for this. So like we have quite complete documentation. So how the API works, and then like maybe I will do this at the end, like once I went through all the things. So I just wanted to show you that basically like trying it in dev mode can be quite easy, and it does not take you a lot of time if you just want to try it to upload data, download data, check out, fill the API, then this is the recommended way to do. And then there is a desktop app. So for that, I will need to, I forgot to do this, but I will do some quick housekeeping. So application support. So I already have it installed on my machine, so I need to basically, sorry about this. So I just moved the folder, so it forgets everything. So you can go to the website, and then on the website you can, yeah, it's later. This is going to be handy. So on the website you can download it, and I already downloaded it so that it's on my machine and I don't have to rely on the network. However, like installing this, like this is a completely networked software, so in order to demonstrate this, I will need also network connection to be working. But the point is that, so there is a desktop app. It's an Electron app, so it's available on all major platforms, Mac, Linux, Windows, and it has different versions that you can download. So if you, this is the GitHub page, but you can also download it from the website. And once you have this file on your machine, okay, wait, let me just find this. Like here, download Swarm desktop. Let me, sorry about this. Yeah, 0. Oh, I don't have it. Okay, so then let's do, like, how would you do it? So I download the x64 DMG version because I have the, okay, maybe I don't do that. Okay, sorry. I will just open the downloaded version. Yeah, I guess this is going to work. So yeah, okay, I already installed it. So I just need to start it. Like you install it as a Mac app, you put this in the application folder, and then you start it. And then, yeah, it starts with downloading B. So currently it's it just, yeah, it's again, I didn't think of this because on a normal network this doesn't take too long. And this is only needed because we support M1 Max, so it has a different version, and it has a different B version, so it downloads the M1 Mac B version if you have an M1 Mac or like Apple Silicon version, and then for me it's an old Intel Mac, so it downloads that one. And yeah, after that, so as you can see, like this is a desktop app. You have to go through the installer. Let me check like where it is. So so it already created the things, but downloading B. So you don't have to wait for this. Normally it's like this. If this doesn't work out, then I can show you an already downloaded version and installed. The only problem with that is that there is a step, like when you download the app, first it starts in a mode where like it's this ultralight mode, so it's a limited version. You can only access data, but you cannot upload. And in order to unlock this upload functionality, you have to do the thing what we call the crypto onboarding, and that is basically you have to fund your node. So the Swarm mainnet uses the Gnosis blockchain, and that means that you will need to have some XDAI so that it can make the transactions for you. And also for uploading data to the network, you will need the BZZ token. So I will cancel this because like it's not working very well, and that's not good. But I will show you the network anyhow, or the version that I had on my machine installed already. So I will just need to put this thing back to the library application support and swarm space desktop. And if you have that, then when you start the app like that, no, I forgot. Yeah, okay. Let me, that's the demo effect. And then the network. Yeah, maybe. So, yeah, so I did some testing and it did not really work well. So this is how I tried to do my network connection. And yeah, I managed to overwrite this for some reason. Okay. That's not good, but we will. Oh yeah, that's true. Okay, thanks for, like in the when you're sharing a screen, it's not necessarily you see these things. I put it inside. Ah, okay. So that's good. So we will need to do some. Okay, I will just put back here, remove the application support swarm desktop. So it means someone is listening to what I'm talking, and that's good news. All right. Okay. Let me check. Yeah. So now you have all the files downloaded, and it's already set up for running. We just need to start it. So in this case, it just starts up as this small icon, and then it opens the UI in the browser. Oh, and something is happening, but this is not what I expected. But anyhow, the point is that, like, if you have a working internet connection, like, then this is working. So and you can do this. So yes, I can use your computer. You have HDMI. Devcon Workshop Wi-Fi. All right. Oops, not that one, that one. So wait, something is working actually. So sorry, what is the password? Okay. Okay, thanks. Thanks everyone. All right, let me see if it works better or not. Okay, so it's somewhat working. Like I can show you the most functionality of this thing. So yeah, there is one warning which might just go away once the network is in a condition where it should work. So yeah, like you can see that I have connected to 114 other nodes. It went, wait, yeah. Okay, it's jumping around. So this is not what usually happens. But yeah, it's like you connect around 100 nodes and 100 peers, and then you can use that to to upload and download data. You can go here, upload, download. So the only difference is that when you install it in the first time, you don't have the wallet set up and you don't have this checkbook, which is also not working at this moment. But the point is that at that point you have to do this crypto onboarding, and for that we actually have a way to, like different ways to do, like you can use either a gift code, which we have here. So if you are curious and want to try out and you don't want to buy BZZ, then look for Gasper here, and then he has a bunch of codes already printed, and then like with a good internet connection, so that to have a good experience on that. You can also set up it with XDAI, and we also provided some guides how you can do it with a bank card, but like we are crypto, so don't do that. Use the codes. And then, so with this app, then you can here, like you can upload and download content. I'm a bit like now scared to try it because it might give you the impression that it's not working, but it is. So like I will upload my presentation in this format. I need to add the postage stamp. Okay, I have one. So there is this concept of postage stamps. So when you have the money for uploading, basically this postage stamp is something that you need to attach to your content, and basically it's two things, like you buy a certain capacity for a certain amount of time. So this is like we call it postage stamp, and then you attach it. I mean, Swarm attaches it to all your data that you uploaded, and this is how the storer nodes know how long they should be preserved. And then this is also used later for the redistribution of the value of the postage stamp. So the node operators, when they have the data stored in the storage incentives game, what I will talk a bit about later, they participate in that, and then they can get the value of these postage stamps. So here I chose the postage stamp, and then I will upload it, and then we will see. All right, so something worked. I mean, this is cheating a bit because I managed to upload the data to my locally running Swarm node, so it doesn't mean necessarily that it's already propagated to the network, but yeah, it's like it would be good to share with someone and download that, but like this is how it works. Like it generates this hash, and then you can just copy this hash and then share it with someone else, and they can access the data with this hash from the network. And yeah, it has some functionality where you can manage your wallet and then your balance and your checkbook. So the checkbook is the thing that is used for the bandwidth incentives. So if you are running a full node, then this checkbook is you don't necessarily have to put money in it. But if you want to download big amount of data, then you can basically make it faster by putting money in the checkbook. And then how it works is that when your node is requesting data from another node, then they create a balance between them, and if your node is only downloading, then your balance will be negative. So then eventually you have to settle that balance, and you can do this with the checkbook. And if you have a full node, you don't necessarily have to do this because the full nodes are participating in sharing the data, and then basically over time your balance will even out. So you can also do that if you want to use your full node for uploading data as well, but it's not necessarily to do that. And then we have these postage stamps, and then here you can see the statistics of postage stamp and manage postage stamps. Like this is the idea for this is that you can like basically create different kind of content, what you want to share and for how long, and then for those like different kind of categories, you can create different kind of postage stamps and upload the data according to this category. And there are also features called feeds. So this is the thing that I talked about, these mutable chunks or mutable data with signed chunks. It enables you to create like a version that can be updated over time, and then with that you can here in this UI, you can even use that as a, for example, if you upload your website, then the basic model where you upload it will be like you will get like the content hash of the data that you uploaded, but that will change over time as you change your website. So if you want to avoid paying the cost for like updating your website every time in ENS and then point it to a different ENS record and pay the transaction cost for that, you can use this feeds functionality and then basically update. You can update your feed, and then your feed will also have fixed, it's like a not changing hash that you can put in ENS, and with that you can update your website through the feeds, and for that you don't need to change the cost on the blockchain. And we have some settings here. So this is the desktop app, basically just a UI, and it looks like it's stabilized a bit. So now we have everything working seemingly, and then we have like a normal number of peers. And yeah, this population is not very correct. So we have some analytical tools, and it shows that there are about 2,000 nodes in the network currently. So it's like not 3,800. And most of the nodes are actually like run by organizations that support Swarm. So there are individual nodes as well, and you can also start your node. And I will talk about that in a minute. So I will just stop this down because like this is the desktop app, and if you want to try out, look for that guy. Okay, so then there is another mode, which like the full node. So in order to do that, you need to read a bit about like the documentation. And we just realized that it seems like most people recently doesn't really like reading or like reading documentation, or it seems like the way how to do it better, it would be video maybe. But so we have documentation about this, but we often get questions from people like how to do that. But actually the documentation has this, like it describes the necessary steps, and then I'm going to go through this and explain this. Maybe it's complicated how it's written, but this is what you need to do. Basically, you need to create a config file, add 6 or 7 things to it, and then you are good to go. So let's start. I will start from an existing config file because I already created this, and I will go through that line by line so that I can explain like how it works. So this is an existing working full node setup. Maybe I can make it bigger. Oops, I made it smaller. So so yeah, like first of all, like you need to tell B that you want to run it in full node, so you have to do this full node true. You have to specify a data dir, so like this is where your files live, and then you have to make sure that on that disk where it points to, you have enough space for that, and it's also, you have to make sure that it's an SSD so that it's fast enough. There is a password, don't use one. But I mean, that works for demo purposes, and that protects your wallet. But like what we do, what we say here, and maybe what's important to mention is that so when you start B, the first time it creates its own wallet, and the reason for that is that we don't want people to accidentally, import their wallet with their funds in it, and then like it's much better just to start your node without with an empty wallet and then fund it and then let it run, because currently there are ways to secure your wallet. So Swarm also uses a thing that may be familiar from running Get, this Clef. So there is a version of Clef which works with Swarm, which is called bclef. But we found actually that was one of the source of the problems of installing your Swarm node. So that made it quite complicated. And because of that, we no longer recommend by default to run it with Clef. Also, we recommend people that don't put a lot of money in their full node. So in the storage incentives, I will talk about, like, if you want to participate in earning BZZ, you will have to stake some money in it, but the current stake is like 10 BZZ, which is worth like $5. So I think it's like $5 is not really worth the hassle of setting up bclef, and just you can secure your thing with a reasonably strong password. Then there are two other config options that it's also documented, but I will just tell. So the swap endpoint is maybe, it has this historical context. So initially we had this, the swap is called bandwidth incentives internally in Swarm lingo. And for that, you need an RPC endpoint. And I just added one. It's a public endpoint, but obviously you can use, like on the Gnosis chain, it's like you can use getBlock or whatever provider you want to use, or you run your own node, of course. But so this is an RPC endpoint to access the blockchain. And you also need an initial deposit config variable. So by default, it's not 0, because historically we recommended people to put some money in their check. This is for the checkbook, so in order to have some balance, but we found out that in order to start, you don't really need this. And if you don't want to use your full node for uploading or downloading data, then you can leave it to the initial deposit to 0. In order to do that, though, like there is an initial transaction if you want to run a full node. It deploys a checkbook contract, and for that you will need some XDAI in order to make the transaction. But that's the only initial cost that you will need. And there is this thing which is documented also, that you can fine-tune your B node to increase the default number of open files, which is something that Unix system have, like basically the open files can be open files, but also the network connections in Unix are represented as files, and then we use quite a few network connections, so it's better to increase the default values. And then one more option is this resolver options, which is only necessary if you want to use ENS. So there is ENS integration of Swarm, that if you have an ETH domain registered, then basically you can set it in the ENS record. You can set it to your Swarm address, and then it will work with Swarm, but it only works with Swarm if you set up a resolver for that. And since this is happening on Ethereum mainnet, this requires a different RPC endpoint than the swap endpoint. So this is a kind of a trade-off, and this is also optional. And this last option is only needed if you want to enable the debug API, so we want to have access from the HTTP API to the internal administrative functionality of your node. Most likely you want it, so for the sake of completeness, I added it to the default configuration. And I will just try to run this, so let's see. I will skip the step of like doing running it one by one, like so starting it and following the documentation step by step, and then if that fails, then adding the new one, the new config line. I will just use the prepared config that I just explained. Okay. Why there is no B here? I will just use. I have one. I usually build from source. So, oops. Okay, address already in use. Okay. there is something running here already. Yeah. It's not the... sorry, no, I am wrong tab. It was the dev mode. So, full node B. So this is how you start it. You specify the config file, and then you start it, and then it runs. I will make it a bit smaller so that maybe you can see more at the same time. Smaller, yeah. So what you can see here is that like you have a node running, and then it connects to all these other nodes, and then it sometimes logs things like this, like, you know, you have to be familiar with these things. I can show you how it looks like from the beginning. So you start it, it prints this B, and then some things, it prints out some public keys and addresses, version, the chain backend, and overlay address. So there is, it uses a different address than your Ethereum address that it uses, so that basically it's something that it's a bit harder to just, you know, run a lot of random nodes, and then this overlay address provides some kind of protection against running a lot of nodes and trying to take over some part of the network. So yeah, and then at this point we have a full node running, and maybe if the network is working, maybe we can even try to, okay, I closed, no, sorry, I closed it, all right. I don't no longer have the hash that I uploaded previously. I just wanted to try, maybe it downloads. So the thing is that now it's, if you start a full node from scratch, at the beginning it will start synchronizing data. So the current full node capacity is around 20 gigabytes, but it also has some caching and some other overhead. So it uses more data than that. But it tries to like synchronize 20 gigabytes of data, and that is one B node's capacity. This is something that we consider increasing in the future, but for now it's like, seems a reasonable default. And then basically when you start an empty node, then it will try to fetch as much as it fills up this internal storage space, and so that it can serve other nodes from that. So it may happen that if you run a full node, then it might not be able to, or it may slow down your computer at the beginning, or you know, it might not be able to access all the data immediately. Interestingly, if you run a light node that is not doing any kind of synchronization, it just asks the data from other peers, and then it works as soon as you install it. So it does not have this synchronization period. Like if you use IPFS and install that, you know that it also have to wait. You have to wait a few minutes until it becomes usable. This is not the case with the Swarm light node, but this is also the case with the Swarm full node. And so, like, this is how you can set it up. So maybe, yeah, we have like 12 minutes left. So maybe I will just talk a bit more about like the storage incentives part, where it is currently. So yeah, there is currently a testnet and the mainnet for the Swarm network, and the testnet uses the Gurley blockchain. And then in order to participate in testing, you will need some Gurley BZZ. We can provide that if you want to try out in the Discord. We have a Discord channel, so if you join there and if you ask, well, we want to participate in testing, then we can give you Gurley BZZ for trying it out. These codes are like actually like equivalent to a private key, so like if you want to try it on mainnet, you can also do, and then you can use these codes as a wallet private key, and then from that you can figure out the rest. You can import it to MetaMask and then transfer the money to that. And so what's maybe interesting is like the current status of the project and what are the next plans. So currently the storage incentives are on the testnet. So that means that we are testing out this functionality. It's quite interesting actually, and I suggest you to read about it. That basically there is a lottery game kind of thing that, so the nodes that have like that share the same partition of the network, they collaborate on the blockchain in a game that like they have to commit a proof of the data that they are storing, and they have to create a consensus on that, and then based on that they select a winner that takes the pot, but over time it's statistically everyone can win, and that's how the distribution, the redistribution of the funds are solved. And yeah, this happens through smart contracts, so we will post a lot about this because this is our current focus area that we want to get done. And once that's working, that will enable that will finally enable this data economy that I just showed you previously, where like people can actually buy capacity on the network, and then node operators are compensated for their efforts. And so that's one thing, that is the current effort that we are doing. And after that, we will work on making be more stable for like handling bigger data sets, and then enabling it for use cases which it requires on bigger data sets, like for example like video and stuff like that. And once that's in place, then that can open the Swarm as an application platform for application, and then storing data on that, and that can generate like the activities on the network. And we are also going to upload some initial like public good data sets that we talked about, like so that to bootstrap the network and make it useful from the get-go, but also to compensate early adopters who participate in the mainnet. And then eventually we expect that like others will follow, and therefore like we can bootstrap this data economy, and then this can be a self-sustaining system. So this is what I wanted to tell, and we have some time left for questions. So yeah.
You said when the full node runs, it synchronizes existing data. How much storage does it keep for existing data? How much does it keep for new data?
So it has a limited capacity. So it's 20 gigabytes currently, what it uses, and like it uses existing data in the sense that like it will populate it with data that is already uploaded to the peers, so that it will connect their peers which has similar address space, and then fetch the data from that, so that they basically share the data in a partition of the network. And for that, the capacity currently is 20 gigabytes. You can also pin data on your node, and that's an extra space that is used. But also pinning is a bit different in this context than IPFS. So because like if you pin data on your node, it doesn't necessarily mean that it's available on the network, because your node will be only contacted by other nodes if the data hash matches your node, and then if you upload your data, it's not guaranteed. So then it only means that from your node it will be available. That can be useful for some use case if you want to make a gateway for Web 2 kind of like, so as a gateway like for like compatibility, or for applications or websites that does not have like built-in integration with Swarm. So like basically providing a transitioning phase. But yeah, so that's an extra capacity, and that's not counted in this what we call this 20 gigabytes is called the reserve space, and this is what you need to prove actually when you participate in the storage incentives, that you are storing that data. Yes.
Yeah. So there's a lot of other decentralized storage networks.
Yes.
I'm trying to figure out
So yeah, I didn't really want to go into this part because this was meant to be a workshop and not necessarily a marketing talk. But yeah, so this is what I wanted to talk a bit about in the beginning. So yes, so for example, like the thing that, for example, the built-in incentivization is something that differentiates from others. So like with IPFS, there is no incentivization. You can have incentivization with Filecoin, but Filecoin is actually not the same thing as IPFS. So it requires to run a different daemon, and then it's different tooling and the different trade-offs. So what we feel is that like this is an integrated solution that seems to be easier to set up and may serve some use cases better. And then we can discuss like what are those use cases. So, I mean, what we feel is that with IPFS, you store files and folders, and that's useful for many things, but we feel that, for example, Swarm, you can store like data structures that can point to things, and then basically you can create like databases and applications that stored on Swarm and uses Swarm as a backend. So it's like not only for storage, but also for like messaging and as a decentralized cloud, not only just the storage part.
Here, sorry. Two questions quickly. Number one, as I understand, you have to pay to download and pay to upload, right?
Yes.
Okay. Second question. You said something about Clef, using Clef in Swarm, for example, when you're using multiple Hive clients as a single cluster. But the documentation says it recommends it using Clef. But you right now just said a few minutes ago that probably you're having a little bit of problems with the Clef Swarm. So how does that work?
So what I recommend here is that if you want to try out running your own node, start without Clef. If you have multiple nodes and you want to manage the keys for them and you want to basically have an operation running multiple nodes, then consider running it with Clef. But by default, I think it's easier to start without Clef. And what was the first question? Sorry. Yeah, the upload and pay to upload, pay to download. Yes. We have 3 minutes left. Any other questions? Yeah.
When you after me. So it's regarding the download and upload payment. So let's say we have this app, YouTube or Netflix, running fully on Swarm, and there's content that's very viral and everybody's watching it. And of course, you as a provider don't want to pay for the bandwidth. So in terms of a user experience, that means that every user of this app will have to have some sort of a wallet that will have to pay for that content to consume it.
So yeah, that's a good question. So how I imagine this is that basically this depends on the application layer and how the application layer manages this. So like in this regard, like Swarm is if we talk about like it's a decentralized cloud, then it's again like somehow applications can abstract this away. So also on YouTube, you don't pay for like Google Cloud, but like you pay for the YouTube. And then how it handles this problem in the background, it's a different story. So we don't have all the answers to that. But like one way to do that is, or one way how we imagine this is that this post-system mechanism, currently it's tied to your node, but it doesn't have to be that way. So it can be actually portable, and then basically you can make your application hand out postage stamps, and then with that it can enable uploading even in the browser without having to connect to a full node or like having to have capacity for things. So we have ideas about that, but this is something that still needs to come when applications are built.
All right, and I have a question here. You show us that Swarm take an archive and divide it in small blocks, while sharing the network. What happens if, for example, my node is corrupted after this project, and what happens if an user want to make modifications to the file?
So all the data on Swarm is stored by this content hash. So basically, with that you can detect if the data has been tampered with or like changed or corrupted, and like all the data is replicated on the network. So like if only one node is changing the data, then actually it can be caught, and actually it will be caught once it's participating in the storage lottery and make a claim for storing data that they have. They actually need to make they have to create a cryptographic proof, and when doing that, it will reveal that like if they tampered with the data or changed or corrupted, then they cannot really. So at that point, they might lose their stake and stuff. So in this regard, like the system has integrity protection built in, and yeah. So how to put it, like, yeah, so the content hashing makes a lot of things very easy in these regards, like the content address hashed. Or, yeah, we also have a grants program. If someone is interested in developing apps on Swarm, then we are looking for ideas also, and the thing is that we don't want to build everything. Like, actually, we want to build as little as possible, and then create this ecosystem where people participate and create their own stuff, and by that contribute to the network and the common goods. You have a question?
At the beginning, you told us that full node is multi-platform.
Yeah. So it's written in Go, and Go provides like easy way to compile it to any platforms. Mac, Windows, Linux, you have ARM version, everything. So I managed to even run it on my phone, so on Android. So yeah. All right. If there are no more questions, then thank you. Yeah, okay, sorry, I'm leaving. Yeah, like, I will be around, I just pack my stuff. Yeah, thank you.
In that world, basically. example, and this is not meant as a slide at all. Or the other thing you can of course do is halt and recover via the social layer, but that's very slow. So where do we want to end up on that graph? That's basically this what I call the unicorn zone there, where everyone could customly validate the network, but we still have like really high speed. So how can we basically find a way to get there? And that's where we're all
Sí, tú sigues en la correa.
something goes wrong. But a one-off n honesty assumption is a way less severe restriction than a majority honesty assumption. And then these problems are automatically resolved on some sort of settlement platform. And then the alternative, as I was saying, PK rollouts, they are just cryptographic magic, right? So in that case, you don't have to do this interactive problem. This little kind of database symbol there. Yeah, and with that, basically, once you have like an explicit settlement system and you have an explicit data availability system, now basically you can break out of this kind of graph of this full node versus throughput basically trade-off. And how can you actually use this now to kind of to build full blockchain systems? That's kind of what the second part is about. Like how do you actually turn this into something useful? And this is going to be very picture heavy because I don't know. For me, it's mostly about giving good intuitions here for like my mental models around this. Basically, that was my motivation for the talk. So again, this is like an execution chain. I drew a little box around it. It's basically in its own box there. It has its own security. And that's the world as it used to be, the blockchain world. We had a lot of these boxes like a couple of years ago, right? And now we're adding these exciting new tools to the picture. We're adding settlement and we're adding data availability. And how do they basically change the picture? Well, first we kind of have to bundle them in some, or like we kind of put them into some used for fun. And the way we like to think about it is bundling them into what we call settlement chain, which is its own blockchain there. You can see it has its own security. And it's not the only way to do this. Like if you, for example, know Celestia, which is a really interesting other kind of project that basically works with similar kind of models. They keep data and settlement separate. But for us, the way Ethereum kind of likes to work is by combining them into separate chains. So now we have these two separate chains. How do we basically now actually make use of them? Well, the way to do this is by, and that's what the arrows are for, by basically turning the execution chain into a rollup. It kind of functions as it did before, but now it uses the settlement chain for data.
Hey everybody, how are you? Thanks for coming. Today we're talking about starting a little bit. The slides are on Spanish, but I can see that we have like more of a multicultural audience, so no problem. We're going to be talking in English. And if you don't understand anything on the slides, please let me know, no problem, but just focus on me. So on the layer 1, we had amazing applications. We got a lot of applications, very interesting. For example, AMMs that could let you transact with different tokens, but these were very, very, very expensive, right? We also had oracles that allow us to introduce data off-chain into on-chain, right? But it was also very expensive. Moving data on-chain is expensive. We also had gaming, where you can have NFTs, very cute NFTs. You can have your sword for your game, your gun, and so on. You can maybe move it to another game, but still the game was directed by a single entity that had the control over the game. So the game logistics, the game logic was not on-chain. It was not auto-regulated. Yes, because this is very expensive, right? Also, we had voting apps, but also, again, writing in storage, writing to the blockchain is very expensive. So voting was also really expensive on layer 1. So this is very interesting application that we have in the layer 1, but that introduces problems when we are talking about cost. So we know the current state of things is either we have a huge machine that is processing everything. We know this. For example, banks, current APIs, companies, startups, and so on. Very huge machines. They can process a lot of transactions very quickly. And now we're looking at the blue part, where we are trying to create a decentralized system, which is when a lot of persons can verify the integrity of the system, right? This is what we're trying to do. The problem is that this is very slow and this is very expensive. And the computation repeats itself various times at different points. So it's not optimal for scalability. Of course, this was a choice when we decided to create Ethereum. We wanted decentralization, we wanted security. It was a choice to sacrifice at that moment scalability. But now we know better and we can do better stuff. Oh. So the question is, can we get decentralization, security, and also scaling? Yes, we can do with zero-knowledge rollups. And we are here today to talk about Starknet. So we're talking about a platform, a layer 2, that is secure by Ethereum. It allows you to create smart contracts, general smart contracts. It's Turing complete. The cost of execution is much lower, and you can create amazing things that are not possible, even imaginable, in the layer 1. So we can get much more for each piece of gas. So this is a quote from Nelvin Sasson, our founder, at Bangladesh in the 29th of July. He's talking about the objective of Starknet, which is creating a solution for scaling that is focused only on scaling Ethereum. And this is called Cairo. So at Starknet, we are experts on both the Ethereum virtual machine and also in creating Stark systems. And there was a conscious choice not to use the EVM to scale. We created a new virtual machine called Cairo. This was a conscious choice because we believe this is the way to achieve the biggest scaling. And this scaling is going to come from smart contracts written in Cairo. In Cairo is the virtual machine, but also a language we have. So what is Cairo? Cairo is a Turing-complete language, programming language that allows you to create provable programs. In this case, in Spanish, programas demostrables. You can execute your Cairo program, and then you can prove a smart contract on the layer 1 on Ethereum that this transaction was correct. This allows us to have much cheaper transactions cost, and because when the smart contract on the layer 1 validates that this proof is correct, it's much cheaper than running the transaction itself. So this allows us to create to get much more scalable solutions using the layer 2, in this case with Cairo and Starnet. So this is our solution, the zero-knowledge rollups, specifically talking about Cairo and Starnet. You can get extremely cheap computation thanks to Cairo. And we can create, and this is key, we can create interesting applications that could only be made using the layer 2. It's impossible, practically impossible to do on the layer 1. And this is some interesting data that we got during the last week. Starnet plus StarkX plus Starknet. So Starware, the company, has different solutions. One of them is StarkX, and the other one is Starnet that we're talking about right now. And both together have more transactions since July than Bitcoin, Lightning, and other layer 2s. This is something that is not very well known, but as you can see, coming from July, the blue line is the StarkX plus Starknet. Down is Bitcoin in orange, and under that are other layer 2 solutions. So as you can see, StarkX and Starnet is currently being very, very used, and we have been live in mainnet since June 2020. So we are not new at this. We know how to do it. The Stark solutions is very good, and as you can see, it's been very used. And very interestingly also is that 70% of that comes from NFTs. It's very interesting. For example, with Immutable, with Sorare, interesting. So now, thank you very much for coming. Now we know that Starnet has a lot of potential. You can create it whenever you want. You can deploy it currently. And actually today we'll be creating a voting application that we're going to be trying on Starnet. You can use it. Cairo is a different language, we know it, but it's also a language that everybody can use. It's not hard at all. So my name is Omar Espejel. I'm a developer advocate at Starware, and thank you very much for coming today. The goal of today is for you to get the resources to start studying Cairo, if you want, to go into Starnet, and also make a small example of a voting application. So now we talk a little bit about what is being done in layer 1 that is very costly and we can improve. Now let's talk about what can we do with all this power that cheap computation can provide us. For example, we have a solution called CKEX. It's a company that is offering high-frequency trading. This, of course, is impossible in the layer 1. Imagine having micro positions and trading with them. I don't know, it would be impossible because of the cost in the layer 1. Makes no sense. We talked before about voting. Voting is very expensive too. So there are also solutions, for example, SnapshotX, that allow us to vote much more cheaply. Yes? So there are a lot of applications that are being already developed inside Starnet that are using all this power. Another one, for example, is the government of Buenos Aires created an application that allows you to have an identity on the blockchain as a user, as a citizen. They chose Starnet because it's very secure, it's highly, highly secure, and also it's very scalable and very quick. So these are only some examples, but the ecosystem is growing by the day. For example, we have tools, amazing tooling, for example, coming from Hardhat, OpenZeppelin, Chainlink, Zoom, Alchemy. Those are well-known companies. But we also, and maybe more interesting, we have different applications on the top, as you can see, that are being created originally on the layer 2. So this is very interesting because it's, and this is my opinion, it's not for the company overall, but it is interesting when a company comes from layer 1 and then puts its applications in layer 2. It's great. They are using the lower fees and that kind of stuff. However, I believe that the real power is being used by those that are created natively on Cairo in the layer 2. Yes? It's a little bit like, for example, when you had Windows in your computer, Windows 98, for example, and you had these nice and cute games. And then comes, for example, Windows XP. Right? It's more powerful, you can do much more stuff, and these games can be passed into XP, okay? So these old games can be passed into the new software, and they run well, it's okay. They maybe could leverage some of the power of the new operating system, but the real power comes from that is being built on top of XP that could not be done in the previous operating system, right? That's what we're talking about here, something that is completely different and out of the league of the layer 1. We can create something very, very interesting that is impossible to create. For example, we were talking about the games that they didn't have the logic on chain. This is now possible. So imagine that you can do operations, summations, multiplications, divisions, whatever. You can do that because the gas is much, much cheaper. So a company, I don't remember, I know the name. What is the name of the project that was creating this on-chain reality? Topology. So Topology created a game on-chain, and it's auto-regulated, okay? So you don't need a central entity to decide if you're allowed to play it or not. So it will stay forever as long as Ethereum exists. This is something that is, again, impossible in layer 1. And for me, the power is going to come from that part. So now the question is, what can you create that is completely different from what has been created in the layer 1, using all this new power, all this new potential that you can find in the layer 2, that is so completely different, never done before. Imagine you can do, for example, machine learning on chain. You can train models on chain. You can create any kind of mathematical operations on chain. It's completely different, and what we need is people that start building these applications that are eye-opening. So for the beginning, you will need to start installing Cairo, StarNet. Of course, I don't expect you to do it right now, but you can follow this QR code for some instructions on how to install Cairo and StarNet so you can get going. It's not difficult at all. And while you scan it, we also have a repo that is called StarNet EDU, where you can find a lot of educational material. I will show you the link in a couple moments. And inside StarNet EDU, you can find a lot of tutorials on different stuff. For example, you can know how the Cairo syntax look. We're going to look at it in a moment. You can, for example, create a token, an ERC20. You can create your NFT, ERC721, tutorials. But even more interesting, how you can create your own bridge from layer 1 and layer 2, a trustless bridge. And for example, how can you create your own wallets? Yeah, so you can, if you can scan this QR code, you will find all that material inside, and you can get going by yourself without any problem. Those tutorials are amazing, and they have onboarded a lot of people into the ecosystem. Also, we have a newsletter that is very nice, and you will have a lot of educational material there too, and also some interesting projects happening on the ecosystem. It's also there. You can subscribe. It's a Substack newsletter. And finally, what we're going to be doing today is a voting application that will allow a person to either vote for 1 or 0, 1 for yes, for example, 0 for no, and deploy it on the testnets. If you have any question until now, you can tell me. This is the repo that we're going to be using. So if you want to have the repo, you want to clone it, you want to copy the code, or just look at it, feel free to scan these QR codes. Any questions, comments? While we start with the coding part? Nope? Okay.
I have a question, actually. How many of you know how to code in Solidity? Can you raise your hand? Cool. How many of you have ever coded in Cairo? Oh, a few of you. Cool. Okay.
Coming from Solidity into Cairo is very simple, really, really simple. And it's great that you're already working with Solidity. Perfect. If you want to go to the testnet and see already and interact with this contract, feel free also to scan this QR code. It's the testnet already working with these voting contracts. I deployed a couple minutes ago. So in this table is the Starboard team. We have some swag in here if you want to come also. And I don't know, guys, do you want to add something else before we start coding? Oh, perfect. Okay. Do you need another QR code? Do you have already the one with the contract we're going to use? Is this one? Remember, please. So let's go to the codes. So this is our voting contract. Again, the goal is to create a contract that allows certain predefined addresses. For example, me as the admin of the vote, I can tell, okay, this address can vote, this other address can vote, this address can vote, because we don't want everybody to be able to vote, only certain participants of a project, I don't know. And they will be able to vote yes or no, yes with 1, no with 0, and yes, that will be all. So for this, let's review the structure and how Cairo looks. This, here we're importing our packages, very similar to how it looks in Python, as you can see it. Then we define structs, as you would, for example, in Rust. First, we're creating a vote counting struct, where you will be able to store the votes with yes or no. So, for example, we'll have 10 votes with yes, 0 votes with no, something like that, the counting of the votes. Secondly, we have voter info, where we store information about the voter. In this case, I simply added an allowed member that it will have a 1 if it's allowed to vote, or 0 if not. If this person has already voted, it will have a 0. Now coming to the storage. The storage variables allow you, if you know Solidity already, these are very similar to you. They allow you to map from one expression to the other. In this case, for example, the first one. Now let's go to the third one here. I am able to map an address to a is registered variable that in this case is a felt. So Cairo is type, it's a type language. Now you might ask yourself, what is a felt? Felt is what is beneath Cairo. Everything is a felt inside Cairo, converts into felts. And basically, for our purpose right now, if you want, we can get a little bit deeper in a moment, but for now, in order to make the most of the time, a felt is like a big integer number, a huge integer number, okay? So in this case, as you can see, the address has not an address type as in Solidity. It's a felt, okay? So we're mapping an address that is a felt to a felt called is registered, that will have a 1 or 0 or whatever. We haven't defined it yet. And on the other ones, we are mapping other information. And interestingly, in the first one, we are mapping nothing, yes, nothing, to a structure, the vote counting. So this allows us to read or write into the memory. That's as simple as that. I can read this, or I can write into the memory using these ones. So using the storage variable voting status, if we read it, and if I will go right now to the deploy contract. So this is the deploy contract I'm using right now, Voyager, which is a block explorer for StarNet. If I go to the read part of the contract, I can see what voting status is doing. Using a getter function that we will see in a moment, we can see the status of the voting. Right now, because nobody has voted yet, we have 0 votes with yes, 0 votes with no. So that is the storage. We are reading right now this storage variable with a getter function that we will get to that in a moment. And also we have the voter info, and it's the same. I won't go into this, but basically we're storing information into the storage of the blockchain. Now, let's go to the constructor. Looks very similar. You know, when you initialize your contract, when you deploy it, you have to define certain inputs, as in Solidity, exactly the same name. So this constructor will ask for 3 different input variables. As you can see now, we can view how a function looks into Cairo. It's very simple, very similar also to Python. And what is important here is this part. These are the inputs, the explicit inputs to this function. In this case, the inputs for the constructor that we have to provide it when we deploy this contract. So I'm asking for an admin address, the person that's going to be able to manage this contract with a field again. Then the number of addresses that will be able to vote. And finally, this is a pointer. So it's important to know that Cairo is a low-level language. So here we can manage the memory. We have to manage it. So the register addresses is basically a vector with the different addresses that are able to vote. I can add 5, 6, 7, 8, whatever. And this pointer field points to the start of that vector. But you won't even notice that. The logic behind it is that this is pointing to the start of this array of different addresses, but you won't notice that, as you will see. Then we're basically using a contract, because we have OpenZeppelin on top also of StarNet, so you're able to use very secure contracts thanks to OpenZeppelin. And here we're using the ownable contract from OpenZeppelin. Before, I imported them here. So I imported the ownable contract and the posable contract libraries from OpenZeppelin. Ownable basically defines who the owner is of something, and posable, it allows you to pause a contract in case of an emergency. Say that, for example, my application is being hacked, so I can pause it. As simple as that. But also we have ERC-721 logics and ERC-20, so you can use it with OpenZeppelin. That's very, very useful. Very, very useful. Any question until now? We have seen the constructor, we have seen the storage variables, structs, how to import. How are you finding Cairo? Too difficult, or is it nice? Any questions? Yes. How do you? Sorry, what was the question? Yes, for example, if you have, in this case, we will be using addresses that are in an hexadecimal format, right? It will simply be converted to a field. Behind it will be, we will actually deploy right now our contract using hexadecimal values, and you won't have to convert it to a field. But you also could convert it to a field and also deploy with that. No problem. Right now we can think of it like big integers, and we can get deeper into that. Any other question right now? We have seen constructors, storage variables, structs. Well, perfect. Okay. So we have our constructor, and with this we can deploy our contract. Also, this, as you can see, the structure of the contract is very similar to Solidity. We're trying to follow the guidelines of smart contracts in Solidity. You have getters, you have the constructor, and the format is very similar. Also, if you go to this contract, it's very well commented, so you can know what is happening.
So does it have inheritance? Because we give the ownable contract function basically explicitly the admin address, which is not like.
Okay, so the question is if we have inheritance in Cairo. Yes. I think you guys can.
Yeah, sure. So there's no inheritance in Cairo. You don't inherit your contract. What you do is you import your function. So if you're looking at the top of the contract up there, here is importing a template developed by OpenZeppelin. So he's importing the full contract, which is called ownable. So it means that he imports all the functions that are inside of this contract. And inside of this contract, it creates a few variables that can be initialized, and one of them is called the initializer, which is supposed to be called during this constructor. Does that make sense?
Yeah, I was just curious because
so it's not explicitly, it's not automatically initialized because it's not like the contract is not ownable. It imports some function and it has no way to know that this is the specific context of the constructor. So you need to initialize it explicitly. Regarding the question on felt earlier, I'm not sure what confuses you, but when you're looking at variables in Solidity, at the bottom of it, at the end of the day, it's a number. And Cairo is a fairly new language. It will get better in the next few months. But right now, it treats everything as a number. So if you want to perform actions when you need strings, you basically need to assume that you receive them as numbers, you convert them, you do your operations, and you do all this kind of stuff. Make sense? Sort of. Yep. Yeah, so a felt is, as you mentioned earlier, I think I heard you say it, it's a field element. So Cairo is like a felt, you can think of it as a big int, but it's basically a number over a big field, a field that is a prime, that does indeed field integer mathematics and arithmetics. Does that make sense? So it's really like you can treat it as modulo operations. The only time where it gets weird is for divisions. Division sucks. I don't like them.
Well, they're handable, no problem with that. So, for example, we were talking about the ownable contract. This is the one that we're importing. So we have it here locally, and we're importing from it. This is the ownable, which comes in a namespace. So we're importing these functions.
Yeah, that's fine. I was just like curious because.
Yes. No problem. There's no inheritance in Cairo. Perfect. So going back to our contract, let's go to. So we import these functions, ownable and posable, from functions inside the ownable namespace and inside the posable namespace. You can, yeah. And there's a question there. The Solidity? No, you cannot import it right now in Solidity. These contracts that we're showing from OpenZeppelin are written in Cairo, are native in Cairo. I think there are plans to have more contracts from OpenZeppelin, right?
Yes, OpenZeppelin is working to create the standard implementation. So any kind of contract you have on Solidity, you're used to have, that is done by OpenZeppelin. We're working towards having that. That being said, I mean, it takes time to develop contracts that are secure and everything. So if you want to develop them, you should. It's worth it. It's fun. And, you may develop stuff that gets used by other people, which is great.
Yes. Actually, OpenZeppelin, the contracts in Cairo by OpenZeppelin, they have a lot of contributions from people outside the community. So that would be great also.
If somebody manages to write a Cairo contract that is the equivalent to the staking contract in Synthetics, which is used by everyone, I'll buy you a beer.
More than a beer. It will eventually happen. It's better if it's one of you. Okay. So we got our constructor. And then we can get to the part. Here we're using the initializer function inside the ownable namespace. And then we go to the getters. It's very simple. Functions, by definition, in Cairo are private, not like Solidity. So here, if we want to have getters, functions to read information, we have to explicitly tell that they are getters. So, and something that I forgot to mention before, but this is the way, like very similar to how you do it in Python, how you define that this has a particular set of properties, this function that is coming. In this case, with Vue, we're defining getter functions, functions where you can read from. So right now, we are creating this admin function that, as you can see, is exactly the same format as it comes in OpenZeppelin, for example, in ERC20 or ERC721, simply reading who the owner of the contract is. So for example, if I go again back to the contract, deploy contract here, I can read who the admin is. As you can see, this is a felt. But here I can convert it to hex. This is the owner of the contract, that is myself. Is this same direction. So talking about wallets, it's a good opportunity right now. You can use right now RGNX, which is this one, and also Bravos, that is this other one. Very recommended. You can use the StarNet faucets. You can simply put in Google StarNet faucets, and you will be able to send yourself some fake ETHs, so you can start making some interesting things using Girly. Or, more interestingly, you can also bridge your own ETH from the Girly testnet in the layer 1 into the layer 2 of StarNet. For example, here we're using Paradigm. I can ask for some fake ETH, send it to my MetaMask, for example. And then, using the bridge, I can connect my MetaMask, which is currently my wallet in layer 1, and connect, for example, RGNX here as my wallet in layer 2, and I can bridge this fake ETH from Girly layer 1 to layer 2. So this is also very interesting. It's the same thing as asking for it in the faucets. So, coming back to the contract, we have another getter function here. It's also a very typical open settling style function where we are posing, we're asking, we're reading if this contract is currently post. Right? Very simple. And then, more interestingly, here we have a view function to know the voting status. Is the one that I showed you before. It will let us know how many people voted yes, how many people voted no. As simple as that. Again, you can see in this function that we have an explicit argument, and by now you are already asking yourself, what is this? What is this inside these keys? These are implicit arguments. This is something that is different from other languages. You might not have seen that before. But basically, these repeat themselves all the time. syscall pointer, percent pointer, and rate check pointer. We're interacting with the memory here. So we are talking that these are pointers actually to a felt and to a structure called hash building. No problem. No, we don't need to get that. That is something that we're repeating in each function. It doesn't matter. The real use is here. So we're asking here for an explicit argument that is the vote counting. Sorry. We are asking for nothing here. It's empty, the inputs. And the output is this. A status, a variable called status, that is the vote counting structure that we saw before. Again, Cairo is type. It's a type language. This helps for security. Any question until now for this function, for example? Yes. Yes. Again, you can read it. You can read from the get voting status. This is the one that I was showing before. And currently the votes are yes or no. This is practically the structure we have and define here. This one. Votes yes, votes no. It's exactly the same here. Okay? So, yeah, sure. Using syscall. You can call, of course, these functions from another contract. You can call them. And we'll go to the external functions that also allow you to write. Perfect. Okay. Yes. Yes, that is what I was telling before, that is the implicit arguments. These are arguments that are passed without you explicitly telling these functions that you have passed them. So they, for example, when we are reading from the storage, you have to provide these functions. The pencil pointer and the syscall pointer, you have to provide them, and they go into the read function. So inside here are the implicit arguments. You don't see it because they are implicit. But yes, exactly. These implicit functions, if I take them off, we will have an error. No problem. It's not hard to get used to them. And also, as you can see, each function that I am adding here has them repeated. So no problem with that. Okay. Also, we have another view function where we are getting the status of a voter. And yes, in here we're simply reading into the voter info a storage variable that we had before using the argument reads. So now going deeper into this, we can read and write from this storage function. In this case, we are reading. And as you remember, this storage function asks us for a user address that was precisely a field. So if we provided a field, then it will return us, let's see, what does it return? Yes, if we provided an address, it will return us a voter info structure, okay? So here I'm reading from it, and then we're returning it, simply as that. Status equals status, because the name of the variable here is status. And to see an example of how to write, this is exactly the same storage variable that we saw before, voter info. We were able to read from it if we are inputting with the address, and we now know that it returns an struct. Okay, so now we can write using the argument write. We can write on it. So we're writing on the storage of our contract, and right now this is basically an address. We will go deeper in a moment over it, but this is an address, and we're telling it for this address, please map these structs. Okay, very similar to how you look at it in Solidity. Yes. Method.sender is, I think I have it here, get caller address. With this, you are getting the address of the contract that is calling this contract. So for example, in this case, this is the most important function, is the vote function. So what it does is simply it's getting the address of the caller, it's storing it, and then we're reviewing the information of this person to see if this person has already voted or not, because we can only allow them if they have voted. And yes, in a moment we will go into that. Oh, could you repeat the question a little bit louder, please?
How do you handle
A variable? Like an address, you mean?
There's no notion of msg.value in Starknet because there's no native currency. Everything's in ERC20. So there's no value attached to a call, and there's no payable function. Did that answer your question?
Okay, so yes, So let's go quickly into the most important function, the two most important functions, the register voters, and this will help me to talk a little bit more about recursion that we use in Cairo. So again, as you can see, we have the implicit arguments, as always, and then we are asking for two explicit arguments. The register address length, this is the length of an array, and the second value is the array itself. So first argument is the length of this array, the second argument is the array by itself. Then what we're doing here is, and again, you can see all this contract in the repo I showed you before. It's in start.edu. In case you want to follow it closer in your houses. And then what we're doing here is simply, and this is a classic function of Cairo that is using recursion. So right now, we don't have force in Cairo. You have to use recursion. And this is a classic function for it. What we're reviewing here is that this is the end of the recursion. So if we have already passed through each of these different members of the array, that is, if the length is 0, then we can return and the recursion is finished. Then here we're creating a small struct, the voter info. You remember we defined a struct called voter info. Here we are creating this votante info where we have this new voter info. So I'm saying here that allow is equal 1. It could be 0, for example. So this function, what it's doing is that each of the address that I'm providing, it will register them as voters, and will tell us that they are allowed to vote. Okay? And then continuing a little bit with the recursion, what we're doing here is writing into storage, into the storage variable register voter. Yes, this one. We're mapping, as you remember before, we're mapping an address to a number. So this is an address. What we have here is, this is the array, very similar as you would do it in Python, for example, and other languages. You have the array, and you can index through it using the square brackets, okay? So I am indexing inside this array. This could be a number like 1 or 2 or 5, depends on the number of addresses that we are adding. And then we will say that the value for that address is 1. We are simply mapping it here. And then comes the recursion part here. We are reading again the same function and providing the length, but this is a lower length. As you can see, if we have, for example, 5 different voters, now we are providing it with 4. Okay? And we are sending it with the register addresses. And then it will repeat until it passes through each of the different addresses, and it is starting from the last one up to the first ones. I know this looks a little bit crazy using recursion, but it's no problem. You can get used to it, and I think that this will improve in the near future, right? Yes. What happens if you accidentally told them you've never heard? Oh, that's a good question. The question is that what happens if you get into an infinite recursion?
Okay, so there's an answer for today and an answer for tomorrow. But basically, there's a form of gas metering in Starknet, just like in Ethereum. And if you reach a maximum number of steps, the sequencer will reject your transaction. Today, you don't pay for these kind of transactions; they're just rejected. Tomorrow, it will be like a failed transaction on Ethereum. You will pay fees for the execution that led nowhere.
Okay. Perfect. Any other questions for the moment? Okay. So simply we have a recursion function here. Again, it's not that hard, and it will improve. We're talking that Cairo is a low-level language, and we have to be very honest and conscious about that. And finally, let's go to the last function. That is the voting function. This will allow us to call a function, as you can see here, it's an external function. External function simply means that we can write on the storage using it. Okay? Not only read, but we can here write into the storage. Again, we have our implicit arguments. We have an explicit argument called vote. And here, don't mind this part, it's simply telling the memory that we will be using, the compiler that we will be using local variables. No, we don't need to go through that. We're calling the postable function from Open Zeppelin contracts, specifically the function called assert not post. It checks that if this contract is post or not. If it posts, this person cannot vote, as simple as that. Then it gets the caller address. This was a question from before. With this function, we can get the address of this caller. We're storing it inside the caller function. Then we can read the information of this caller, of this address, using the read argument from this storage variable, storing it in info. And then we are simply reviewing if this person can vote or not. If they have allowed 0, then they cannot vote. Then we're creating a new voter info struct that it says that this person has already voted, because we don't want them to vote again. We are writing on the storage here. Everything here, we already know that. And finally, we are updating the status of the vote with the vote of this person. If this person voted yes, or 0 in this case, then it will update that with 0. The count with 0, and if they voted yes, in this case 1, for example, then it will be updated, the count will be updated with a sum that we have here. And finally, we are updating the final status of our update, of our voting, and storing it into the storage. As you can see, this function is key. And if we go to the deploy contract, we go to the write contract, and then I can vote. In this case, this is the function. I don't remember what address I added, I think. So I will go to my Bravos wallet in here. I was in my Argent before, and let's see if it allows me to vote. So I will vote with a 1. And I will be able to sign this transaction because this address is registered to vote. I did when I deploy it. And right now, this is the transaction hash, and we have to wait for a testnet to process this, and we will have our vote. Now, how can you deploy these contracts? You can deploy it using the command line tools by Starnet, or also, and my preferred way is to use Protostar. Protostar is a tool created in the image of Foundry. It has the best practices from Foundry and also some from from Truffle. So it's very interesting. It helps us to test, but also to deploy. So if I go right now to my command line, this is how deploying this contract looks like. So basically, I'm telling it Protostar deploy this contract that is already compiled by this moment. And what I want you to notice here is the part of the inputs. We talked before about the constructor accepting 3 different inputs. First one is the owner, the admin of this voting. Second is the number of persons of registered addresses that can vote. And finally, the actual addresses. So this is how they look. This one, as you can see, is a hexa value, and this is the address that is the owner of this contract. Then only one person or one address can vote, this one. And we can simply deploy it, running it like this. Protostar is very good, it's very usable, it has amazing testing functionalities, but you can also deploy your contracts. And that is simply the contract that we deploy here. And as we can see, we already voted. If I go to read contracts, we should get a voting status where we had a vote with yes. With number 1, it updated, and 0 is still no. I could not vote again because theoretically, I should not be able to vote again. Let's see what happens. Oh, it shouldn't pass right now, but let's wait for it. So that will be the main part of the workshop. We have 3 minutes to more questions. Yes. The implicits? Right now here, I don't have any, but they can change, depending on what you're building. Can you think of a scenario when?
When do implicit arguments change? Every time they're used, basically. It's a bit of a deep question. The workshop is about to finish, so if you want, let's meet outside and we'll give you a more definitive answer.
Yes. I think I have an error message here. While I look for it, any other question in the meantime?
I have a question for the audience. Before we wrap the workshop up, can we just get a quick show of hand who learned something during the workshop? Cool. Who thought this was too difficult? Who thought this was too easy? Okay, fine. So it's great. This means this was spot on. Those of you who still are hungry, don't hesitate, ask us questions, come on our Discord, go on our resources, look at what we do. As Omar mentioned, like most of these things, the paradigm, you're used to that. You're used to how you write smart contracts, how you deal with scholars and stuff like that. The syntax is a bit different, the tooling is a bit different, but you can and will master Cairo. It's just a matter of just like trying. And this tool will give you extreme power in your blockchain applications. So if you're looking to do more and go beyond what you can do with the EVM, I invite you, do take a look. It really is powerful and will let you build super cool stuff.
And again, this is the QR to the educational resources. If you want to go look at them, we will have booths on Thursday and Friday. You can ask any question, come with us. And finally, regarding the question, the error messages, this is how they look. So if this assertion, true or false, fails, then it will print this mistake, voter info. Well, thank you very much.
What does it look like from the browser? Like, Solidity is really complicated?
Well, it depends on the wallet. Let's see, for example, this case, assert allowance.
So your question is, what does an error message look like from the browser perspective? Essentially, you'll get a failed transaction like you do on Ethereum, and the trace, like the way it shows up, is kind of ugly, to be honest. It's still very rough around the edges. There's a lot of info that is not necessarily relevant to you, but the error message will appear somewhere, and you'll be able to know where the error is from. Like in general, this thing works, and this thing scales Ethereum right now. It's a bit rough around the edges, meaning that it's not all pretty. There's a lot of info, or not enough, but it works, and that's cool.
That's cool. This is how the error looks like. As you can see, that's the message that we saw before in the error. Yes, for info, your address is not allowed to vote. Again, we will have a booth. Please feel free to ask any questions, and thank you very much for coming.
And we get T-shirts. We're not taking them back, so please pick them.
Web3 words, all of the most amazing things that we can do with the technology and our products. And most importantly, like, I think, you know, at the end there we have the inclusive community and we have the genius people and the good vibes. Like, that's what I'm here for. And that's kind of what I like to focus on most, right? Like, when I get on stage, I like to talk about people. Because if we only think about the technology and the products that we're building, well, you're going to end up in this situation quite a bit. Because the second that you sort of, I don't know, the second your dreams start to come to fruition, the second that everything starts to line up and you feel like you might have a grasp on it, it really does seem that then out of nowhere, everything keeps crashing down. Building shit is really, really hard, and especially when you're a wallet, and you know, you're the product that people are using to access and manage all of their digital assets. It's really hard. Things come crashing down a lot, and the worst part of failing at like building a good product is actually like the failing people, right? We're failing the newcomers that enter the space. They're getting fished. Getting scammed, they're optimistic one day, and then they have their hopes and they're crushed the next day. And that's what basically the last, I don't know, like 7 years of my life has been, right? Like trying to be better every single day, trying to help people understand the technology, trying to get people to understand how they can use this technology to actually improve people's lives. Because this shit is fucked up sometimes. As hopeful and as optimistic and lovely and as much as we want to believe that we are building a better world,
others.
Significantly better and make Web3 significantly easier to access in the coming years. It means that the products I build and we build are going to be responsible for millions more dollars. And that's like a hard thing to wrap your brain around. It's not super pleasant. I would say it's pretty fucked up. And it's been pretty fucked for a while, actually. This is a comment I made in 2018. One of the earliest mistakes I ever made was when we created my Ether wallet, we didn't really understand why you shouldn't let people enter their private keys in the browser on a website. And so we did exactly that. You would generate your private key, you would enter it on the website, and that's how you access all of your money. That was a terrible idea. Don't do that. Seriously, don't do that. This is Dan. Dan is one of the founders of Clubhouse. It's one of those times in life when you just know that it's right. It's one in a lifetime. For the first time in my life, I'm right on the edge now. I'm looking down. No matter how hard I try, I can't see the ground. I'm on the edge now, taking the lead, taking a chance. 'Cause all I need from you, my angels, to catch me when I fall for you. All I need from you, my angels, to listen to your heart. 'Cause all I need from you, my angels, to catch me when I fall for you. All I need from you, my angels, to listen to your heart. Will give it all I've got. I'm losing control tonight, but I hope you'll do us right. I'm right on the edge now, I'm looking down. No matter how hard I try, I can't see the ground. I'm on the edge now, taking the lead, taking a chance. 'Cause all I need from you, my angels, to catch me when I fall for you. All I need from you, my angels, to listen to your heart. 'Cause all I need from you, my angels, to catch me when I fall for you. All I need from you, my angels, to listen. It's their tokens, it's their NFTs, it's their collectibles.
All right. Hello, everyone. Thank you so much for joining. We have a very packed agenda. This is technically a workshop room, but these are extremely meaty topics. If you have a burning question, you can feel free to raise your hand. I'll call on you. You can ask it. Otherwise, wait until the end. We're going to be outside, and these guys are extremely online, and so you can find them on Twitter. So today we're going to be talking about the staking economy and how it's moving from monolithic to modularity. We're going to introduce our speakers here. I'm the host, Victor Bunyan. The big supporters over there. I got a taste for Colombia. Anyway. So we have an amazing panel before us. To introduce myself, I'm protocol specialist at Coinbase Cloud. Coinbase Cloud is an infrastructure provider. We run validators and nodes across something like 30 or 40 different blockchains at this point. We run a good number of ETH validators, and so we're extremely invested in the success of the Ethereum ecosystem. We're paying a lot of attention to this transition from the, what is currently a validator, which is a, it's a box somewhere that has some software on it. The keys are either there or in some other box, and it's pretty vanilla. And it goes and it does its work, and it performs its consensus duties. But the trend that we're seeing right now is that there's a whole host of essentially middleware solutions that are changing and modularizing the validator experience. And so they're almost kind of like plugins or extensions, you can think of it as. It's a very crude example. This is a fairly recent phenomenon. Flashbots and MEV-Boost was the first and primary example of it reaching an enormous scale within the Ethereum ecosystem. But with the advancements coming from the teams up here and also other teams working in the space, we expect for this to be an extremely exciting and pivotal moment in the development of blockchain infrastructure on Ethereum. And so with that, I'm going to pass it over to the panelists to each introduce themselves and their projects. We're going to give them a little bit of time to not go super technical, but it's important you understand what each project is, because it's really going to inform the rest of the conversation. And these are nuanced, meaty topics. And so the directive we gave them is a VC pitch, but a VC that knows what's going on, And so, and so with that, Stefan, please go ahead.
All right, hello, hello. All right, this works. Hey everyone, I'm Stefan. Until recently was at Flashbots. One of the big things I've been working on there over the last year has been developing and shipping MEV-Boost, which is often talked about these days. So I'm happy to get into discussing what it means to develop this kind of software for validators. MEV-Boost was developed to help solve two very specific problems with regards to validator deployments and MEV. One was allowing access to solo validators to participate in the MEV market, and the other one was to protect client diversity and sort of avoid a future where validators would try to fork their own code and create some technical debt in integrating new upgrades. So the way that it's architected and the way that it works today is anyone running a validator, whether it's at home or a massive node operator like Coinbase Cloud, can plug in MEV-Boost into their system, do some minor configuration, and essentially run it out of the box and get better rewards. So yeah, that's the intro there.
Good evening, everybody. I'm Sriram. I'm founder of this project called EigenLayer and also run the University of Washington Blockchain Research Lab. What we're doing at EigenLayer is essentially enabling the sharing of decentralized trust from Ethereum staking to anybody who wants to build a new system on top. So the core idea here is staking is the root of trust. So when you're, after the merge, we are in a proof of stake world where the stakers basically put down a stake and commit to block validation. And if they make an error or if they behave maliciously, they can lose the stake. So this underwrites a certain economic security into the blockchain. What we are doing is enabling it to be flexibly shared. So for example, you put down your stake and restake. So restake is a new concept we came up with. Restake is the idea that you're using the same stake, putting it at additional risk, and committing to doing additional things. Maybe running a new chain, running a new service like data availability, running other middlewares on top of this common stake. So the exchange here is stakers are taking on additional responsibilities and additional risk. And in exchange, they're compensated with some fees or other tokens which are paid for those stakers. Imagine you want to build a new distributed system. You have to go around and try to create a whole new validation network, which is decentralized, fund economic security to it, which is actually very, very expensive. For example, just to get a sense of numbers here, Ethereum has like, $20 billion worth of economic stake at risk. If you wanted to build a platform which has similar economic security, you're talking about like, you have to pay the stakers an annual APR like 10%, right? That's like $2 billion worth of fees just for your other system to be as secure as Ethereum. It's virtually impossible. So what you can do is you can borrow this massive economic security because you're restaking it, you're using it for additional services. Anybody can come and build new services on top, thus augmenting the feature set of the Ethereum ecosystem. We think of this as a permissionless way to do feature addition to Ethereum. So you're borrowing the Ethereum trust and now running new services. It is purely opt-in from the staker side. It's not forced on anybody. But the stakers that do opt-in are actually able to earn this additional risk-reward dynamic. So that's what we do at EigenLayer.
Hey everyone, Colin Myers, co-founder of Obel. We are focused on building what's called distributed validators. Easiest way to describe what a distributed validator is today all validators are seen as one key, one entity, one individual, and it's very singular in nature. Our primary goal with DBT is to enable and change everyone's minds that validators can become communities. So with DBT, what you can do, you can take a regular validator, you can use a DKG, divide up its key into different shares, and the four of us today can share a validator together. And if Victor's house burns down, all things are fine because we use threshold signing and applied cryptography. So our node will keep going, it'll keep validating, the network will not halt, and yeah, that's what we're focused on. It takes on the form of a middleware, and it sits on the ETH2 side.
Awesome. And I know you folks are all starting out on Ethereum, and you talk a lot about Ethereum. But obviously, it's not the only proof-of-stake network that's out there. There's a proliferation of them, and most networks these days are proof-of-stake. How do you think about the trade-offs of sticking to Ethereum versus also starting to work on other layer 1s or layer 2s and other ecosystems?
I think right now there's a huge narrative of like the bazaar versus the app chain. I think they can both live and survive. I'm an American that spends half my time in Europe, and it's actually almost culturally how the world is divided. Like Europe is kind of a bazaar. All their cities are meant to be lived in. Everything is close to each other. America's like app chains, suburbs, houses, everything's real structured and together. So the way that we look at that is Ethereum is the bazaar, and then who's the app chain? So for us, as we look at where to take DBT, it needs to fit technically within that network. And what's favorable for us are not too fast of block times, because there's rounds of communication that need to go between the individuals that are inside of a cluster. So for us, Cosmos is like another chain where that could work and is kind of the app chain model. They have 5 to 7 second block times. For us to work on other chains, DBT works best with BLS signatures. They're homomorphically additive, which enables you to split them up and then re-aggregate them and broadcast in a very efficient manner. Cosmos does not have that. Maybe they will adopt it, or maybe DBT can be fit into another chain in that sense. But today we are most focused on Ethereum. However, DBT is something that all public blockchains should use, in my opinion, to add like more resiliency and add fault tolerance to the network. So it comes down to demand. It comes down to like where the economic value is. It comes down to like where the smartest minds are. And I do believe that outside of the bazaar, the app chain model is probably the only other layer 1 that would compete with Ethereum, and that's how we currently look at the option set.
Very cool.
We are primarily Ethereum-centric, and the reason is when you want to build a layer like this, you are basically looking for where is the maximum pool of decentralized trust. Because we are basically a decentralized trust marketplace. Where do you have maximum economic security? Where do you have maximum decentralization? How can we leverage this and build a whole bunch of new technologies on top of it. So our attention is actually in onboarding newer and newer modules and technologies. And one interesting thing that, if you look at Ethereum versus the other blockchains, Ethereum has committed itself to the modular blockchain world. And I think very few people understand the kind of scope of what a modular blockchain world is. The way to think about it is one thing we all love, across all these ecosystems about blockchain is permissionless composability, right? You can build an app, and I can build something on top of it, and somebody else can build something on top of it. Together, they stand much stronger than any one person could have ever built. And permissionless composability is at the app layer, and that's how all smart contract systems work. But we want to bring permissionless composability at the distributed system level. You build a new system, I build a data availability layer, you build a broadcast layer, somebody else builds some other thing on top, an authentication layer. You just pack all of these together and then create a new service. So Ethereum, having committed to this modular paradigm where there is going to be different things done at different modules rather than all bundled together. We're all about unbundling trust, right? So we are actually taking the trust network and letting people innovate on the different modules. So for us, it is a natural fit that Ethereum is the right place to build something like this.
For MEV, okay. Deciding where to build MEV solutions sort of comes from the starting point of where is the biggest problem. And the biggest problem is where the most usage is. So it sort of makes sense to start from that perspective with Ethereum. And it turns out that building MEV solutions is kind of hard. So you kind of solve it, you build something on one layer, and then you say, well, it would be nice to go build it on everywhere else, but there's only so much time and resources to be able to do it. So the other thing is, it's not a one-size-fits-all solution. So I think there's some principles, there's some abstractions, there's some research, some ideas that can be reused across multiple different places, but you can't just reuse the model that you deploy for a certain node architecture, for a certain client architecture, and copy-paste it into other chains. It's been really cool to see other teams emerge in other ecosystems that try to solve similar MEV problems at the middleware layer, at the node customization layer. I know on the Solana side, right, the Jito team has been working on it for a little while, and it's fascinating to see how different the solution space is, right? So it's sort of the solution that they are coming up with to be able to outsource the MEV extraction is actually to slow down block times. So because Solana has this main difference of being so much faster at block production than Ethereum, to do any meaningful outsourcing, you need to have slower block time, so that you can add the network latency that's required. And so it sort of highlights that even though the principle is the same, the idea of being able to outsource MEV extraction from the validator level, the implementation ends up looking completely different. The other thing that I'll note is MEV-Boost is surprisingly simple software. Like running a consensus client, doing all the peering and the networking is really difficult. MEV-Boost is just like a plugin that is a sidecar to the system and allows it to connect to a bunch of other resources for receiving blocks. It's just a multiplexer of like an RPC call. Yet it's so hard to get adopted, right? Like such a finite, such a small change, which you'd say like, okay, like anyone could implement this in like a day and ship it, is not that trivial when you're like deploying it to a network with 430,000 or so nodes. There's so many different stakeholders involved, so many different interests. And the hardest part of developing this kind of software is not the technology itself, it's also being embedded into the ecosystem, understanding what are the goals that are being achieved by the development of this software, what are both the technical but social goals as well as economic interests of all the parties involved. And that's where 90% of the work of developing these kinds of solutions lies. It's not necessarily just the technical side.
Yeah, I think it's such a good point, and I think it's something that unless you spend time in multiple ecosystems, it's very easy to take it for granted that people, outside of your ecosystem have the same worldview about what's fair and like what should happen and who should benefit or not benefit from certain activities. And what we find is that, you can't copy paste MEV-Boost because
other ecosystems don't want necessarily these characteristics, right? And so the software just like doesn't make sense as it is. But there, I think Sriram especially, talked about some of the use cases kind of like off the cuff. But something that I would like to do is just make this a little bit more real of like what can all of this look like longer term. And so what I'd love it is if you guys could like talk about like what are the most ambitious use cases that you're thinking about that you could potentially solve or address. Like what does that look like?
So on our side, any type of validator can use DVT. You can be big, you can be small, whatever, it doesn't matter. What we find most interesting is that using its cryptographic properties to partner professionals with non-professionals. So when it comes to like, how do you decentralize a liquid staking pool? Today, most of the pools are run by professional validators, or they are run by the pool themselves. And over time, what you must do is include other people into that validator set. And with DVT, you can get the consistent uptime rewards and performance by pairing someone up with a professional in that capacity. So today, like let's say there's a 4-node cluster, it can be a Figment, it can be a Coinbase Cloud, and it could be 2 at-home validators. And if applied cryptography works the way that it should, that validator should have just as much performance, and it enables the small person to come in with the big person and then maybe become the big person eventually. So taking a node and mixing its constituents between professional and at home is kind of not the tail end of what we're going for, but right now it sits at the most innovative spectrum of how we're testing with people and how we're looking to push it forward.
From our end, the main thing we are quite fascinated about is the ability for the Ethereum ecosystem to become much richer. We can start listing out like the top 5 problems in the Ethereum ecosystem and then like start ticking off how we can solve all of them just by using EigenLayer. I'll give some examples. Number 1, the data availability bandwidth on Ethereum. So in the rollup-centric roadmap, computation is offloaded, but data availability still happens on Ethereum. So the data availability bandwidth of Ethereum, even with upcoming upgrades, will be in, say, 80, 90 kilobytes per second. So when you have a bandwidth like this, the rollups are, of course, extremely optimized to actually take advantage of this and still pump in like tens of thousands of transactions per second. So that is awesome. But in a world where we are imagining a lot of the digital intermediation fundamentally happens through things like blockchains, we want to make sure that there is abundant bandwidth. 80 kilobytes per second is not enough. Ethereum itself has a roadmap with some really interesting ideas called danksharding, where you can increase this up to like 1.3 megabytes per second. But even that we feel, and that's a few years out, and we feel this is not enough. There are applications which will need much, much more. And we are provisioning, the first service we're building on top is a data availability solution on top of EigenLayer, which can actually scale the throughput of data availability quite significantly. We are in our internal DevNet at 15 megabytes per second already, and I think we can scale this another 100x in the coming years. This is one example of taking one pain point in Ethereum and then figuring out how new distributed systems methods can actually come in and solve these things. We stand on the shoulder of giants. We build on top of danksharding, some of the best ideas out there. Just good engineering and open permissionless competition. This has done a lot of good to the layer 2 world, compared to what sharding was, where one solution has to be enshrined, and there's a lot of internal contesting on which is the right solution. Whereas a permissionless competition for each of these different features actually leads to a very, very powerful world. So another example, people think a lot about whether we'll be in a single chain world or a multi-chain world. And I think this is not a very relevant discussion for what we are doing. Why? Because even in a multi-chain world, it's very clear to us that Ethereum will be at the center of this multi-chain world. And why is that? What is the center of a multi-chain world is if you think of each blockchain as like a node and it's like a graph, you see that the hub node of this network is Ethereum. It is the most connected, it is the most liquid, and the most secure. These are the 3 properties you need for a hub node of a multi-chain world. And we feel Ethereum is the right hub node. And so in this paradigm, there are some lacking things. We see a lot of bridge hacks, for example. And can we think about how we can build like very powerful bridges on top of the Ethereum landscape? So that's another thing you can do is once you restake, you can opt in and start running light client bridges for all other chains and start bringing in very powerful inputs into Ethereum. Another example. You can think of other things like MEV management, right? Like you want to do MEV management when when a block proposer is making a claim that I'm going to follow this ordering rule, what makes them hold to that rule? If they can restake on EigenLayer and then opt in to new slashing conditions for what they have particularly agreed into, like I'm following this threshold encryption, I'm following this auction model, whatever the new rules are that you opt into, you can hold by it because you can make credible commitments on EigenLayer. Some examples of what I think we can do.
Yeah. I also think we can just cancel the rest of Devcon. He got it. EigenLayer will solve everything.
It will.
I have a question about EigenLayer. How should validators think about the risks? So intuitively to me, there's okay, I have my stake.
We're gonna get to that.
No,
I'm saving the spiciest ones for the end. You want to do it now? We can do spicy ones now.
All right.
I'll do spicy ones now.
We can do spicy ones now. Yeah.
Yeah, let's do it. But here's the condition. The spiciness actually applies to each of you, not just EigenLayer. And I want to hear about the risks associated with each project and the failure cases that are possible. Have you changed your mind?
Where do we start?
Well, I think maybe I'll give a little bit of background in that. When you think about a middleware solution that does one thing, right? So today, a lot of people run Flashbots, right? They run MEV-Boost as part of their validators, and they're able to participate in the Flashbots software and ecosystem and all that. And the nice thing is that because it's relatively simple software that doesn't make tremendous changes from otherwise expected geth behavior, it's fairly well understood, and we understand the risk parameters, we understand how it interacts with relays and the failure cases there. But what we don't understand is if you're running Flashbots and you're running EigenLayer and you're staking there, and also you're part of Obol, right? And so your validator key is split into 4, for example. And so that actually creates a very powerful situation where you can have these incredibly robust and performant and do everything type validators, but at the same time, it's also a very scary situation because of the risks involved of okay, now you have 9 client teams that are doing different things, and you have 3 middleware solutions, and you have upgrades across all of them happening all the time. And so the risk there starts to compound. And so that's some of the background that we're thinking about. And so maybe there's going to be 2 questions here. One, I'd love to hear about what are the risks and failure cases associated with what you guys are building? What's the worst case scenarios that can happen, and how are you trying to prevent it? And then second thing that I'd love for us to talk about as a group is okay, we are all marching and all kind of making upgrades and doing all the things. If I'm a validator that is going to be using all of your softwares, right, and also something else, right, how do we make sure I don't get slashed? How do we make sure that the Ethereum network remains performant? How do we make sure that your development processes or testing or whatnot are in sync between all of you and also the other clients that you're using, such as the execution or consensus clients? So it's a big, meaty topic. Who wants to go first?
I'll start with block times. We talked about this earlier. So first and foremost, long block times in Ethereum are super important for all this entire middleware renaissance, is what we're calling it internally. You have these core client teams that have been built up over time. They're funded by the EF. It's free software. It's the MVP viable way that you access the network. And now it's time to build enhanced functionality on top of that. Those middlewares must be designed in a credibly neutral manner. They must be designed with simple modes of failure. For us on our side of the equation, the biggest mode of failure. Well, first of all, what is the #1 reason why everyone's been slashed to date in the network? It's because everyone's been running a configuration called active passive redundancy. It means to get more effectiveness or more uptime, you run the same key in 2 places. One is online, one is offline. This can result in lots of false positives. So you can't have a highly available validator without DVT, basically. So first and foremost, DVT addresses the #1 slashable event in the network to date by being able to give you more availability. So when designing the middleware, modes of failure for us today are missing. Just miss your duties. And then you take your time and you bring your machine back online. And that really only happens if you lose more than 33% of the nodes in your cluster, right? So we're talking 7 of 10, we're talking 3 of 4 in different combinations like this. We'll be giving a talk tomorrow, Oshin and I, around how to design DVT at scale while not increasing correlation. So today, now where we're at with DVT is like correlated slashing is one of the worst things that can happen in the network. We try to like avoid that at all costs. We believe that liquid staking pools and DVT will like reign predominant inside of these. So it's our duty and responsibility to make sure that it's designed in a manner that doesn't increase correlation. Because the worst thing that can happen is a correlated slashing event takes place across 80% of the network who's running the same middleware. Obol is a security middleware, right? It's different than MEV Boost, where you use MEV Boost to get more. With Obol, you use it to protect yourself, which in theory will probably earn you more as well. So today, when it comes to correlation, that's our biggest focus on testing. We think it's probably the biggest risk of the whole future of staking is making sure that correlated slashing events don't take place. And yeah, that's where we're at.
Awesome.
What's the biggest risk of using EigenLayer? There are many risks.
As many as things it fixes? Or?
We've tried. So there are really two kinds of major failure modes. One is, you get a whole bunch of stakers collude, and they're not only attacking the core protocol, but also attacking all these other services. So the potential profit from actually your attack has increased because you have a much higher exposure. That's number one. I think this is, even though this is somewhat significant, I think it can be addressed quite well. And the basic paradigm for why this can be addressed well is we have to compare existing systems to this new upgrade using EigenLayer. Imagine you're running a whole bunch of dApps, and all of them depend not only on Ethereum for service, but also they depend on some Oracle bridging service and a few other things. That's exactly how the ecosystem is today. And even though Ethereum is giving you very strong security guarantees in terms of the economic security, you have all these other dependencies which do not have the same level of economic security or decentralization built in. And you're only as safe, the dApps are only as safe as the weakest link. And by restaking, the ETH stakers, for example, if, just to give some numbers, if there is 20 billion at stake in ETH, but like there are 3 middlewares, each of them have like 1 billion at stake, you just attack the weakest pool and you can actually potentially completely corrupt all the inputs. And the alternative universe is where ETH stakers all opt in to provide these services, especially if these services are lightweight or scaled horizontally, then it's possible that a lot of ETH stakers will opt in. And when you have a lot of ETH stakers opting in, you are essentially, to corrupt any one service, to corrupt any one dApp, you have to corrupt a majority of the ETH stakers. And they're putting themselves at slashing risk. At some point, this becomes infeasible. There is a hardening of security. You want to take $20 billion of a flash loan and go and stake and get burnt for $10 billion and going to extract more than that? It's very difficult. So when you have a lot of restaking happening, actually your system's net security increases significantly relative to where we are today. Okay, the counterpart to this is the other kind of risk, which is what happens if there are programming errors? Okay. You have a bunch of these services that are running. One of these servers has like a bug, or even worse, it's maliciously designed to break the entire network. Somebody is offering a 20% yield, things we have seen before, and everybody opts in. And at the end of the day, there is some, massive slashing event at the end of this thing. All ETH stakers are slashed, and there is mayhem. This is our worst nightmare. Okay, how do we solve this? I think this is to get a good analogy, at least, in the Ethereum ecosystem, there has been a lot of thought in how to create systems that are immutable and ossified. And the right approach to this is to start with training wheels, like layer 2 solutions today. And you have these training wheels where you have governance mechanisms which can backstop risks. And that's the same thing we'll do. So essentially, there are two grades of services on EigenLayer. One grade of service in which there is what we call a slashing veto. There is a committee of Ethereum community members. This is not a token DAO, which you can buy out. This is reputed Ethereum community members, including people building on top. In this committee, they can veto slashing events which happen illegitimately, right? So slashing happens, it doesn't get actuated, there's a gap, and in this gap...
And actually, and I'll clarify there, because one thing that when we say slashing, it's not necessarily slashing on the Ethereum blockchain itself, it's slashing via the eigenlayer protocol. And so what it does is that your ETH that you have staked, it essentially gets withdrawn to an eigenlayer smart contract, and the eigenlayer smart contract confiscates some or all of that ETH depending on the slashing condition that you triggered as part of eigenlayer. So it's like slashing conditions on top of slashing conditions depending on like which rules of the protocol you break. And so that's what he's referring to.
Absolutely. So the governance committee can veto slashing on top of eigenlayer. And this prevents things like these risk contagions. But as these protocols evolve and they have been well tested in the wild, they can ossify themselves to another grade, which is not subject to any slashing veto. So the only thing that the governance committee can do is to veto slashing. They cannot add on new slashing. So the stakers are not taking additional risks. But people building on this middleware are taking a governance risk because whatever legitimate slashing gets illegitimately vetoed. And so as you grow in trust, when you build these new services, you've been tested in the wild, you can ossify yourself to another grade where you're not subject to this slashing veto. And so at that point, the stakers have to opt in. You have to convince them to opt in because they are losing one of their core protections, either by establishing reputation and testing yourself in the wild. So that's how we mitigate some of these risks. It necessarily requires exerting subjectivity. And I think this is one thing that the whole blockchain space should take more seriously, is how do we combine subjective mechanisms with credibly neutral mechanisms so that we can get the best of both worlds.
Very good.
All right.
Back in the hot seat you go.
Yeah. Before I start answering, actually, I want to get a sense of what the room is composed of. So I will ask for show of hands and please participate. Anyone who's running Solo Validator at home, can you put your hand up? Okay. Anyone who works for some professional node operator validator company, put your hand up. All right, a good chunk of you. Anyone who's building like validator middleware, sort of what we're talking about here, you can put your hand up. Okay, small group. What are you guys? This is the Obo crew?
That's the whole Obo team.
This is the whole Obo crew. Okay. Amazing.
That's the fam over there.
Anyone who's validating or staking on other networks, put your hand up. Okay, cool. All right, mostly actually professional validators, which is interesting. Okay, so risks, MEV risk, MEV-boost risks, and facts. I mean, at some point, risks no longer risks and they become actual. So in developing MEV-boost, I think, and maybe any software really, it's easy to think about the first order risks, right? Like what are the first order, possible failure modes? And you can sort of create a security model that says, okay, here are all the different ways in which the software could go wrong or get abused, etc. For MEV-boost, this was threefold, right? So from the validator perspective, you are outsourcing part of your power to these third parties that are called relayers. And there's three ways in which these relayers could start to misbehave. One of them is they produce a block that's just simply invalid, right? So you believe they're proposing a valid block to the network, but the block is invalid. The second one is that they can lie about the value of the block. So they'll say, hey, this block is worth 10 ETH, but in fact it's only worth 1 ETH. Second way that they can misbehave. And the third way is that they could withhold the block. So they give you a block, you sign it, you return it, and then the relay just never reveals it to the network. And so it causes you to miss the slot. So okay, you think about, okay, these are three different things that the counterparty is trusting, is trusting. What are the impact of that, and then how do you start to mitigate them? Well, the validity one, right, is if a relay continues to produce invalid blocks over time, that's publicly known, and so you can see this relayer is not behaving as it's expected to. I can simply disconnect from this, and so the validator in this case has the power to be able to protect themselves from being attacked. And they can also critically notice if this happens to other parties. So this is sort of a key part of the security model. You don't want a validator who is maybe going to propose like 3 blocks a year or something, right, to have to wait until the next block proposal to know that the counterparty that they're interfacing with is malicious in some way. You need to be able to see it from the state of the entire network. For the third one, and the block withholding one, is the most difficult because there's this problem of attribution. Like, you don't know if the relayer just revealed too slowly, if it's because the validator never like submitted their block to the relayer and they only submitted it to the to the rest of the network. There's a lack of attribution as to where the fault lies. And these kinds of issues are the most difficult to solve when you're building software for validators. If you don't know which actor in the system the fault originates from, you can't mitigate it as effectively. And you have to look at these like wider health metrics for the system. The solution for that specific risk is looking at is the blockchain continuing to propose blocks? And so you can have this health factor for the blockchain as a whole. If there's X percentage of the last 100 slots that had a valid block proposal, then you can consider it to be good enough. If for whatever reason the health factor falls below some threshold, you have a circuit breaker in which it says it disconnects from all the middleware that could possibly be causing these kinds of faults, and you fall back to sort of a tried and trusted operation of the system. Okay, these are the first order risks. Everyone's still following?
But wait, there's more.
This is making what we do look a lot more simple. This is great. Usually we're the most complex thing on a panel, but this is awesome.
All right, second order risks. So this is like the risks that aren't just directly from the behavior of a single node, right? But more risks are emergent from when you look at what if the entire blockchain is operating the same software, right? What are the economics incentives? What are like the marketplaces that get developed on top of this? And how does that impact the expected behavior of the software? I think this is where censorship sort of comes into play, right? So you can solve all of the micro sort of risk at the individual layer while still having some bigger, broader risks that are more emergent out of the use of the entire system that can't be necessarily solved just through the initial design. They sort of become second order effects. And some of them are easier to predict than others, and it's sort of a question of iterating on the ecosystem of the solution, both at the technical layer, but also at the industry level to try to mitigate these.
Yeah, and I think that censorship is a prime concern for the whole ecosystem right now, and it's been a prime topic of conversation throughout other panels and talks at Devcon. So yeah, we're all working on fixing it together. That's actually one of the things that EigenLayer is often mentioned in ETH research posts about like how it can support potentially solving that problem. And so you guys talked about the individual risks associated with each project, but then I want to go to the next question, which is that how do we deal with the amalgamated risk profile that results from using multiple middleware solutions? Why is that funny? Amalgamated?
That's a nice word. I don't know if it's right, but it's good.
Yeah. Well, this is like I'm an immigrant, and so we don't have preconceived notions about words. Like all words are equal to us. So I'm like, all English words are nice. I like them.
So where we're at here, like, fact of the matter is there's really only one predominantly used middleware, and it's MEV Boost. So there will be many more, and
we made it.
You made it. You like paved the way for all of us to see that it's actually doable. So like today there aren't combinations of middlewares happening. We actually recently integrated Charon, which is our client, into MEV Boost, and now a distributed validator can propose blinded beacon blocks, which is cool. So actually that kind of opens up this new entire landscape where like a validator looking at the mempool, if there's 10 people in a validator, all 10 of them have a view on the mempool. And then that has like, and since there's a consensus mechanism built inside of it, that opens up like a whole new paradigm of not only what MEV looks like, but also like what security looks like. So we have validators combined with MEV Boost running on testnet today. We don't get to propose very often, but going through that process of testing it and figuring it out, fortunate for us, they came first. I like really don't think it would have been smooth if like DVT and MEV Boost launched at the same time. It was kind of the natural of getting to the merge. Let's get MEV Boost near mainnet. Let's change it from like a client into a middleware. Let's merge, and then after that, now we take on the next middleware, which is like DVT or others. So I think doing them in phases as a community is like super important. I think the EF kind of unknowingly designed it that way. And that's kind of how we interact with the client teams, for example. It's kind of like wait in line, you know, and your turn will come up.
Yeah.
So now that we're seeing more middlewares come out and they're getting more use, yeah, what happens when they sit on top of each other? We've been looking at it less from the risk perspective and more from the opportunity perspective. But through that finding, we'll probably find what the risks are.
Yeah, and I'm glad you mentioned the client team angle. That's actually the next thing I want to talk about because I think it's super important. Any other takers on the amalgamated risk?
On the amalgamated opportunities, yes. I already mentioned, for example, that you can do MEV type things on top of EigenLayer. That's one set of opportunities. Another set of opportunities is, can you build distributed validation for some of these other services built on top of EigenLayer? Because again, the same set of reasons why you would need DVT on top of a core layer also applies to services built on EigenLayer. So these are some of the touch points and interfaces. I think one nice thing is the core EigenLayer design is kind of as a sidecar. It's not directly touching the client. So we are basically add-on, right? So opt-in, add-on, that's the two aspects. But there are some touch points between these different middlewares.
One of the other interesting things to mention about EigenLayer and Opal is for like the long-term goal of this cryptography project is to deal with what's called the lazy validator problem. So today it's not like cryptographically possible to like objectively prove who in a threshold signing scheme was not doing their job. So EigenLayer can't fix that. That's more like moon math that can fix that. But then it comes down to how do you solve that once you can identify it. And that lazy person in that DVT cluster, you can disincentivize, you can punish, you can do a variety of different things. Today, the only way that the industry has thought about punishing that actor in our sense would be to like create a token, make everyone bond Opal token to the node, disincentivize, slash that token, and to your point, we would have to create our own trust network. So at the later tail of DVT in its more mature state, the goal is to be able to use cryptography so that a group of people can run a validator together and not know each other. They don't have to know each other. They don't have to trust each other. But to get there, you have to deal with the lazy validator problem. And today, the best way to do that is to create a new trust network, which is just 2017, 18 all over again. So there's like things that we would need for the later tail of what we're doing that EigenLayer is trying to build.
Yeah.
I have a question.
Yeah, please.
Is it better if we like have a world where all the middleware solutions can sort of innovate, right, and like throw new ideas at the wall, figure out what happens, and what sticks? If it gets adopted, then it's just all core devs' problem now, and they like have to deal with it. Or should it be that each of these new middleware solutions have to figure out sort of their own governance mechanism over how to continue maintaining these and shipping new features, and how does it fit with integrating into the principles of Ethereum, into all the other middleware solutions that get built? Is there like one path that's better than the other?
By the way, I really regret showing Stefan the questions ahead of time.
So in our case,
he's known to front run.
Yeah. That was good. So what was the question?
How do you feel about front running?
His question was like, you guys are all building really cool stuff, but it's it's sidecars, it's like different clients, and so like as we mentioned earlier, there's 9 different clients that are either execution or consensus that are currently on the Ethereum blockchain, and now you have this slew of middleware solutions that aren't part of the all core devs, aren't part of the EIP process, they're not part of any established rails by which the Ethereum community releases infrastructure, software, and upgrades. And so the question is like, how do you deal with that, right? And like, do you try to do you just ship whatever you want and then just like throw it at the core devs and be like, it's your problem now?
So ours was a reverse problem actually. I was part of a group of people who were focused on pre-Genesis for ETH2. We spent a lot of time on like enablement, onboarding, education. Then we began to focus on like post-Genesis problems. And one of the first ones was stake centralization. And DVT started off as a research project at the EF. And then we worked with them to like build a reference implementation out of it. And then we took it on. And now it's basically our responsibility as a project to like take that and push it forward. That's more, in my opinion, how the EF is being designed today. Is like, if you want to be a real decentralized foundation, you probably can't ship too much code when you get more mature. So like their job are to be like educators and business people and reference, implement, like, you know, do all the research, do the legal work, do the business work, enable a community, and push out technology that other people can take and run with. It also ties to the economic scheme of how things work, right? The fact of the matter is that the client teams are funded by the Ethereum Foundation and or in some cases Joe. And now, you know, middlewares are not anymore, right? We have our own private funding. We're not reliant on the EF. Our software doesn't need to be, it has to be open source, obviously, but it doesn't need to be free. So that fact then creates a whole new world of like, yeah, the economic schemes of how it works, because economics, incentives, and coordination will deem all relationships. And at the base layer, the relationships in the client layer are straightforward. It's like virally left. Everyone can use it. It will be forever free. The EF has given them good chunks of money to do so. And now we're at a new layer, and we get to create it economically the way that we want to.
Yeah, from our end, I think one of the things that has been lacking, I think already Colin alluded to, is economic models for people to build these new services. And that's something and the other issue that Victor raised is the question of whether these should be governance processes which bring on new things, or should we let permissionless open competition? I'm very much on the side of like open innovation. I think if you look at the rate of innovation on the various layers of the blockchain stack, you would see that the rate of innovation we saw in the dApp layer is simply amazing. You know, you can take anybody else's ideas, compose things on top, and build new things. Whereas if you were a protocol dev, there were very minimal opportunities for you to express your like engineering and building skills, because the only way you could do it is to go and start a whole new network. And what we need is mechanisms by which we can actually massively accelerate the rate of innovation at the core protocol layers, because it's entirely log jamming the rest of the applications that can be built on top. So we feel like as long as there is an attendant economic model to each of these middleware being built, or for example, on top of EigenLayer, that would be collect a fraction of the fees and only the remaining fraction of the fees goes to the stakers. It could be, hey, you have a new token and you have dual staking. You stake your own token as well as you have ETH staked. So there could be a variety of different models in which these middlewares can become self-sustaining. But I do understand that there are some examples. For example, Flashbox has done a great job in stewarding MEV towards away from things like multi-block MEV and reorgs where things can get quite hairy. And I think the pressure on these things should be exerted socially rather than in terms of any kind of governance process.
What about you?
Yeah, I fall on that side of the camp. I think it's really tricky to design good standards body, governance bodies over anything, but open source technology in particular. I think we're very lucky that we have sort of an Ethereum core development ecosystem that's so committed to transparency and openness. And it has allowed for a lot of these social consensus things to get expressed directly into how the protocol gets designed. All these wars and these arguments that are being had in the public can go away if there's this like formal process by which things get approved. Then the question is like, what's acting and getting these things approved, and like how it's a completely different game that isn't necessarily about public dialogue and discourse, and that's a big part of it. Victor, you helped out a lot in the development of an MEV solution, right? Like there was this ETH2 working group that essentially got started maybe this time last year. To develop the MEV boost solution and bring all the stakeholders in-house. Like, what do you think is the role of all these different stakeholders continuing forward? Is it like, you vote with your feet, you decide which technology that you operate as a node operator, which technology that you use, or should there be some more active process for involving, those views and opinions?
Yeah, that's a great question. It's hard to know, but I think that as infrastructure providers, what we want is by and large to be unopinionated, in that we want to take open source software, we want to run it in the vanilla way in which it is designed, and we don't want to ever express opinions over the state of the network and like what is allowed or not allowed, or censorship, or any other properties. And so when we think about the designs of these various softwares, something that we think about is, you know, as infrastructure providers, we know how to run infrastructure really well. And so the things that we focus on are, you know, performance, our security, are like all these components that enable us to run great infrastructure. But when it comes to the characteristics of the design, or the trade-offs that the design makes, I think over there it becomes much more of a conversation and a vote with your feet kind of thing. And we did have a different MEV solution come and talk to us, and they came to us and they you know, explained their design to me, and I was like, that is completely uninteresting to me. And that stumped them, because they were like, well, I had 100% hit rate before I talked to you, and I'm like, yeah, well, here's why your idea is dumb, and I'm not going to do it.
This is why Victor makes the big bucks. Brutally honest.
Yeah, I'm loving but direct. And so, you know, I think that we try to influence as much as we can in a way that still allows us to, you know, remain credibly neutral as infrastructure providers. But at the end of the day, we have to make decisions, and I think that the decision that we make as infrastructure providers always have to be aligned with the long-term goals and health of the network. And if we're not doing that, then our business is dead and nothing matters. So, okay, we're very much at time. Thank you so much, and thank you so much for the speakers. Really appreciate you guys.
Everyone.
All right. We'll be here if anybody wants to talk, and if not, we'll be outside. And if not, you can find us on Twitter and Telegram and all the things. Thank you, guys.
Thanks, everyone.
Good job. Oh.